I wish it didn't have to be this way. You and me, we can run away. Meet me over in a dance hall. You and me, we can have it all. You and me, we can have it all. You and me, we can have it all. You and me, we can have it all.
React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components and have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh. That sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
I use Freestyle Libre to manage my type 1 diabetes, and it's important to me to use a product I trust. It's especially rewarding knowing that I have a hand in improving it for myself and others. My work is personal with global impact. We are engineers focused on understanding our customer needs and prioritizing user experience through innovative technology.
was on fire. You were the water on the horizon, wherever you are. Look to the skyline, the sun will be rising. Oh, there I go, thinking I was better off alone. Oh, there you go, out in the darkness, like you were lightning. So alive, so alive, so alive, just you and I. Now I do 1,000 nights with you. So alive, when I see it in your eyes. Said I do 1,000 nights with you. So alive, so alive, so alive, just you and I. I do 1,000 nights with you. So alive, so alive, I see it in your eyes. Said I do 1,000 nights with you. Keeping it calm. Something inside us, burning in silence, reaching arms, looking around for peace in the violence. Oh, there I go, thinking I was better off alone. Oh, there you go, out in the darkness, like you were lightning. So alive, so alive, so alive, just you and I. Now I do 1,000 nights with you. So alive, when I see it in your eyes. Said I do 1,000 nights with you. So alive, so alive, so alive, just you and I. Now I do 1,000 nights with you. So alive, I see it in your eyes. Said I do 1,000 nights with you.
Everyone, please take your seats as the conference is about to begin. It's now like, okay, I definitely building, I'm like getting my groove. Everyone, please take your seats as the conference is about to begin.
Go from here.
Yeah, let's.
Wait, there's no sound.
CTO and head of Reality Labs here at Meta. I wish I could be there in person to celebrate React and its community with you. It's wild to think that it's been 11 years since we open sourced React.
Uh-oh. That's no good.
Every day.
What's going on? Why can't we hear it?
Hey everyone at React Conf. I'm Andrew Bosworth, or Boz as most people know me. I'm the CTO and head of Reality Labs here at Meta. I wish I could be there in person to celebrate React and its community with you. It's wild to think that it's been 11 years since we open sourced React. And since then, millions of developers have built incredible things with it and are still making a living using it every day. At Meta, React had a profound impact on our products as well as the broader dev community by improving the way we build apps. I mean, two things in particular come to mind: user experience and the developer experience. On the user experience side, React made the UI a function of state. UI was a pain in the ass before this. A toggle would say on, the application thought it was off. This change was such an improvement that other UI stacks across every corner of our industry adopted it. This is a great example of open source innovation making things better for everyone. We also discovered that React's model is relevant beyond web development. Within Meta, we rely on React for products on web, mobile, desktop, even mixed reality on our Quest devices. Developers across the world have improved React for those platforms and introduced it to new ones like TVs and gaming consoles. And of course, on the developer side, React has significantly boosted the productivity of millions of developers around the world by being able to see UI updates instantly without needing to recompile or reload. Can you imagine not having fast refresh? This is why we open source. When technologies are shared, innovations build on each other, and the result is that everyone can do better work. We're seeing a similar pattern emerge now with developers as they adopt open source AI. What Meta learned from React had a big impact on the way we've opened up technologies like PyTorch and Llama 3. And we can only hope that the open source AI community much impact as the React community has. All of that impact has only been possible because of the community you've all built. The contributions you make to React and the ecosystem raise the tide and lift all boats. They make better user experiences possible for every team, big and small. They make products more fun to build, and they help every developer ship better products. So thank you. Thanks for being here today. Enjoy the food, the party, and the time together. We're looking forward to seeing all the things that you build.
Ladies and gentlemen, introducing Seth Webster.
It's like they just got like way more real.
The mic isn't working.
One thing I can do is shout. I'm so excited to welcome everybody here today. My name's Seth Webster. I support the React team at Meta, and I am just super pumped about the program we have for you over the next 2 days. We've got a ton of deep dives, first looks, and announcements. Matt, am I allowed to say announcements? Oh, sorry, anunciamientos. We've got so much stuff packed in the next 2 days that is going to leave you so excited, your brain's percolating in all the right ways. And the cool thing is we are a single track conference, so there's no choices to make. All you have to do is show up. It's not like work, no decisions, just be here. Super exciting. Made it easy for you. I did want to start today with three things. I wanted to, I'd see a lot of familiar faces, but I wanted to introduce myself to the other 634 of you. A lot has changed since the last time we were together in person with React at Meta, so I wanted to share some thoughts with you about that. And last, I wanted to take a moment for some gratitude. As I was reflecting about our last React Conf, I couldn't help but remember that I was in my second week of my time at Meta. I was in boot camp, and I was working on this component called UFI. It's this gnarly component. It's the like, comment, and share component in all of your Facebook news feed items. But anyway, I was sitting there watching the YouTube live stream, some great talks by Tom Okino. Tom's here somewhere. Hey, Tomo. Yuzi Zhang, Joe Savona, and I was thinking to myself how amazing it was going to be that just 1 year later I was going to be able to go to React Conf 2020. Now, by a show of hands, who's here for the first time for their first React Conf? Basically, almost everyone here. Me too. Me too. 2,028 days later, we get to do this together. Isn't that awesome? So I spent my first 6 months supporting the React data team, which is the team that makes Relay. And then I started supporting the React core team. And about a year later, I started supporting the React native team, which is the whole React org. Needless to say, this was like a really fast way to learn about the vast ecosystem of React. It's like a really nice way to say this was an incredibly humbling experience. A lot has changed for React at Meta since the last time we had a React Conf. The team is over doubled in size that works on React at Meta. The number of developers working to build product at Meta using React has more than doubled in size and is into the many thousands. And the technical constraints, the technical complexity of the apps we build products with React at Meta has increased significantly, with things like CPU and memory and temperature becoming increasingly more important as we've expanded our platform offerings from 3 to 7, including things like mixed reality. And we had recognized at that time that what had gotten us here wasn't going to get us there. We needed to make some changes. Previously, as a small, scrappy team, we were able to successfully ship the org chart and do a lot of really great things, focused purely on the technology. But a little over 2 years ago now, we restructured the team to focus more on being able to do more across many more areas by focusing on things like developer experience, our ecosystem, programming model, and a lot more on our core fundamentals like performance, runtime performance, because these things started to matter more than ever as we entered these new environments where these things mattered a lot. And over the next 2 days, you're going to hear a lot of echoes of these themes, but you're going to start to actually feel them. And this is just the beginning. This is one of the amazing things about the Meta's stewardship of React. Through the harshest constraints and keeping this community top of mind and the immense existing code base out there, we're forced to this high bar of reimagining what's possible without disrupting what's already a pretty great developer experience. Imagine this. Each day, thousands of developers at Meta come to work and fire up their IDEs, many of them working in and around the same components, spread across dozens of products, instrumented to oblivion and seen by billions of users each day. It creates this incredible laboratory where we're able to observe and ideate and iterate and test and learn and fail fast. And through this high intensity forge, we can harden these super lofty ideas. And when we're ready to share these ideas more broadly, we bring them to the only place we know that can make them ready for adoption by the rest of the world, and that's this community that you've all built. You're literally the only place that we can take this to make these ideas ready for mass adoption. And so I wanted to start the day by saying thank you for building this amazing community. Thank you for making all of this possible. Thank you for holding us accountable and for all the immeasurable ways you've given back over the years. Thank you. So those are my quick remarks here at the beginning. I wanted to bring up this next person. When I met this person recently, I was at the end of a really long day. It was a day of back-to-back reviews. And for anybody that works at Meta knows that there's some of these days where these just reviews pile up. It's a day of back-to-back reviews. And I was so tired, but I just had to meet them. And it was 5:30, 6 o'clock at night. I was so exhausted. And I was like, I just got to get this in. There's no way we can get all the way to React Conf and not beat this person. 3 minutes into this call, I was so energized and uplifted. And I hope and I know you're going to feel the same way that I did. Hailing all the way from the Haitian nation, please give a thunderous, amazing React Conf welcome to the one, the only, the Chief Vibes Officer for React Conf 2024, Mr. Ashley Narcisse.
Wasting wasted time, wasted yours, and I wasted mine. Won't feel looking.
All right, it's a little bit shocking just to really see like the scale right now of just how many people of y'all are here. Thank you so much. It is an absolute honor to be here and share the vibe with y'all. 5 years ago, I was in your seat, and there's a lot that kind of happened, and I'm really excited to hear the speaker and amazing programs over this next couple days that we're going to be together. I do not bite. If y'all see me in the highway, I'm a huge hugger. I'm a huge lover. Please come stop by and say hi. I have 2 housekeeping items I wanted to go over. First is this month is Asian, Pacific Islander, and Native Hawaiian Heritage Month. So as we have quite a bit of representation throughout this conference, I really would like y'all to help me out right here and help me celebrate the folks that represent these heritage. So diving in, the second item that I have on that topic is something that my uncle usually always told me every single time I went to visit his house. He was I get my vibes a lot from him. He cooks great food. But every single time I'd come visit, he'll say, hey, make yourself at home, but don't forget that you're not home. And what he meant by that, he was putting me in line, was that respect the space, be courteous to others, but also you belong here at the same time. So let's also extend the same thing during this conference. And I don't know if you've noticed, there's been a code of conduct posted in posters around the registration desk. It's also available on the Discord. So this is a call out to please review and adhere by it throughout the conference to make sure that it's an amazing experience for everyone here. Last thing, since we're talking about culture and Heritage Month, I want to share with y'all a little bit of my culture. So everyone say it with me. Can anyone say map, boo, lay? All that together. Map, boo, lay. All right, awesome. You guys are on your way to being fluent Haitian Creole speakers. So that's the response to the call, which is sac passe, which means what's up. So let's do it together. Sac passe, sac passe, and sac passe. Awesome. This also Haitian Heritage Month. So with me, y'all are gonna get some little honorary little stickers of Haitian just to share with y'all a little piece of my culture. I will be giving a little bit more stories, but come along with me on the journey on Haitian heritage and also celebrating and highlighting Pacific Island and Asian heritage and Native Hawaiian Heritage Month. Now, let's get started with the conference. Giving up for our next speaker, coming in from the beautiful Pacific Northwest, he identifies as a true-born New Yorker, so bagels are life. Let's give it up and help me give a huge warm applause to Joe Sanova.
Thanks. Awesome. Thanks. Wow, there are a lot of you here. I'm probably going to say wow about 10 more times. Wow. Also, the lights are very bright. All right, we got a lot of awesome stuff to show you today, so let's get started. My name is Joe Savona. I'm an engineer on the React team at Meta. In the past, I worked on Relay, which is our GraphQL data fetching library, as well as Skip, which was an experimental reactive programming language that we built at Meta. And the last few years, I've been working on React. I'm supposed to advance the slide now. So back before all those things, back in 2010, I was living in Japan, and I was working, I had my first full-time job as a web developer, and I was writing raw HTML, CSS, and jQuery. That's the only way I knew how to write JavaScript was jQuery at the time. And I'm pretty proud of my work at the time, considering that I was testing on Internet Explorer, not just Internet Explorer, but IE6. There's one computer in the back of the office that had it, could still run IE6, and you had to FTP. Do y'all know what FTP is? Yeah, you had to FTP and then run over there and check it. Yeah, that's the old days. the dark ages. Thank you for laughing. Oh yeah, I gotta use the clicker. This is gonna be, yeah, I'll get used to it by like the second or third time I come up here. I'm the class clown in meetings, so just kind of, setting expectations low. So anyway, testing on IE6, you can kind of imagine that it wasn't super easy to realize the full vision that our clients had for their sites. I think we did a really good job, and I'm proud of my work, but it was just always really hard to build something as great as what our clients were really hoping for. And I think that this really speaks to our goal with React, to make it easier for anyone to build great user experiences. Now, it sounds nice. What do we mean? Let's start with user experience, or UX. When we talk about user experience, we're talking about a few different things. The most basic is things like good design. But we also want our apps to do more. We want our apps to start up fast. We want users to be able to move through our apps quickly and with confidence. But more than that, we're all here in this room because we're user interface engineers. We care about building something great. Things like small animations, subtle design tweaks, and all the bits of craft and polish that go into taking a good app and making it great. Now, we know that it's always been possible, in theory, to build a truly great app. But our goal is to make it easier, and not just a bit easier, but dramatically easier to build a really great experience. We want to make it so that anyone can build something great, whether you're a student, a hobbyist, a designer, a developer, whether you're a first-time developer like I was back in Japan, or an experienced engineer, whether you're a back-end engineer, a machine learning expert, just trying to quickly get something up to show your colleagues, whether you're working alone or in a giant organization or anywhere in between. This requires focusing on the developer experience. Again, it's always been possible to build something great, but it's usually so much work that we just focus on the basics and move on to the next task. So we want to lower the barrier to entry, not just for basic features, but for sophisticated UI, to help you build something amazing in the time you actually have. So, how are we doing on this goal? In today's keynote, we're going to answer that question by looking at three things. First, we'll look at the state of the React ecosystem. Then, we'll look at the type of experiences you can build with React 19. And finally, we'll talk about what's next for React. To kick things off, here's Lauren Tan to talk about the state of React.
Thanks, Cheryl. I'm Lauren. I'm an engineer on the React team. And I'm so excited to be here. And it goes without saying that this conference wouldn't have been possible without all of you. It's so great to see all of you again, some of you for the first time, since our last virtual React Conf in 2021, but this time in person. So I thought it'd be really interesting to take a look at how the React community has grown since then. So let's start by looking at how many times React gets downloaded a week. So in 2021, in the year of our last React Conf, at its peak, React was downloaded 13.5 million times. And now, I went too fast. Oh. All right. Yeah, 1 billion downloads. Very cool. In 2023, all of you NPM installed React more than 1 billion times, which is awesome. Much better than me at handling slides. So let's also take a look at the React Dev Tools. So back in 2019, Tomo shared that there were 1.8 million active users of the Dev Tools. But as of this month, we have more than double the amount of developers who currently have the React Dev Tools installed. Last year, there was also a Stack Overflow survey sharing that 63% of developers use JavaScript, 40.5% used React. But the number I'm most excited about is this one. 36% of people learn to code learning with React. And I think that goes to show how much all of you in the community have given back. in the form of tutorials, videos, blog posts, and even libraries that make difficult things simple. And this is all really important because I'm sure all of you know how much fun and rewarding it is to build software. So the more we can do to bring in the future generation of React developers, the better. But who cares about numbers, right? There's way too many people to thank when it comes to how much all of you have given back to the React community. And there's so many of you, I couldn't fit you on this slide, so sorry about that. But the work all of you are doing to share what you've learned about React, making it accessible to a wide audience, and being welcoming to newcomers is why I'm so happy to be a part of this community. So seriously, thank you all for making React so awesome. I'm sharing all of these numbers because it's easy to see React as just a library, or an architecture, or an ecosystem. But really, it's a community. This is React Conf, but there's been React conferences for communities in India, China, Miami, all over the world. And with people who've come to React with really vastly different experiences. So whether you've used React from the beginning or your journey is just starting, and whether you live in Las Vegas or in Paris, React lets us all create user interfaces together. And that's because, as Joe mentioned, React's long-term goal is to make it easier for anyone to build great user experiences. So this reminds me of my own journey into React. A few years after college, at my second job, having just learned JavaScript as a baby developer, I found myself being the first junior front-end developer of a startup. And when I joined, their app was this old-school server-rendered application with a dash of spaghetti code here and some jQuery over there. And I was somehow given the responsibility of picking a JavaScript framework to help modernize their architecture and make their site more interactive and easy to maintain. But as I did my research over a few weeks, I compared the options, and React's simplicity and composability really jumped out at me, because we needed something that was intuitive and easy to learn, but it would also scale with us as we grew. But as I did my research, I couldn't help but notice that there were a lot of loud voices on the internet telling me to reconsider. But as I built a small prototype in React, and I saw how intuitive it was to me, a noob, I was convinced that React was the future. And I'm happy to say that to this day, that's an actual picture, by the way, that startup uses a lot of still uses a lot of the early infra that I helped them build. So React really did grow with them, so I made a good choice. I'm sharing this because a lot of you may have had a similar story in how you found React. But no matter your background, there's so many people like you and me in the community who saw something special in React, and we believed in it enough to bet our future on it. And that's why we're all here today. Along the way, many of you in the community have went on to make us all stronger by creating reusable libraries that build upon React's key features and primitives, and helped us innovate on new ways to make it easier to build great user experiences. So whether it's state management, charting, routing, UI libraries, there's a really good chance that there's a well-maintained React library out there that helps your app achieve its goals efficiently and with high quality. But that's a lot of choice, right? And yeah, sometimes it can be just way too much choice. And it can be really hard to make a decision about what to choose when you start an app. So this is why last year, we started recommending choosing a React framework. React frameworks handle many foundational features of an application for you, while still giving you a lot of flexibility in choosing additional libraries. We have several great speakers lined up over these next 2 days who will share more about these React frameworks, so please don't miss these talks. Now, all of these frameworks share something in common, and that is that they build on many of React's key features that we've developed over the years in our pursuit of making it easy to build great user experiences. So here's Joe to tell you more about those features.
Awesome job. Awesome job. Thanks, Lauren. Next, let's turn to React 19. Andrew and Josh will share more about what's in this release in just a moment. This release builds on the foundation of concurrent rendering that we established with React 18. So to put these features in context, it helps to understand how we got here and our approach to solving problems with React. So what makes UI so hard? Many of the most complex challenges in user interface development are really problems of coordination and scale. For example, synchronizing application state with our UI is a giant coordination problem. There's an exponential number of state transitions to consider. And our approach to problems like this in React is to turn these coordination problems into declarative APIs, like JSX, where you describe what should happen, and React manages the complex coordination on your behalf. We solve the scaling challenges by ensuring that our APIs compose. You can wrap one component in a larger component until you build up an entire app. Declarative, composable UI. Let's see a couple more examples. In 2019, Meta's UX research showed that users perceive sites as faster if our content loads all at once, rather than popping in individually as things are ready. But how do we know when everything's ready? That's a complex coordination challenge, coordinating all the data loading across the entire page. React Suspense is a declarative API that lets us describe what data we need and what loading states we're willing to show, and lets React do all that complex coordination to show those loading states appropriately. Suspense also incorporates the results of this UX research, balancing the desire to show content quickly with the need to show a complete experience. So by using Suspense, you can build a site that takes advantage of all this UX research out of the box. But these types of coordination and scaling challenges aren't just limited to the client. Some of our logic belongs on the server, and some of it needs to be shared between the server and the client. Server components make React's same declarative, composable approach to UI work seamlessly across the server and client, allowing us to have easy access to back-end data sources while also continuing to render interactivity where we need it. This lets developers continue to break down their applications into small, reusable pieces, regardless of where those pieces should live. In React 19, we're continuing to expand on this theme, solving more places that currently require complex coordination. To tell you more, here's Josh.
Hi, I'm Josh. I'm a member of the React team at Vercel. And today, Andrew and I are going to give you a sneak peek at some of the great features that are coming to you in the next major version of React. We're going to tell you about some improvements to server rendering and suspense that simplify some tricky coordination problems with HTML. We're going to cover some long-anticipated improvements to hydration. We're going to talk about a new core concept in React we call actions. And finally, we're going to give you an update on some welcome changes to JSX. All right, let's begin. The React team takes special interest in solving problems that require coordination across an application. But data loading and UI states aren't the only aspects of an application that can benefit from built-in coordination. During the past couple years, I spent a good bit of my time digging into the challenges of HTML document ordering to make declarative composable HTML possible. Now, I know what you're thinking. That's kind of silly. React already allows you to write composable HTML, and that's true, but it's for visual content. But HTML conveys document metadata, scripts, style sheets, and preloading hints for fonts, images, and more. Imagine an app where some routes render articles. Our article component is a great place or a natural place to put page-specific information, both the visual article content, but also things like the page title and the styles that are specific to the article's visual representation. But consider where these elements will end up in your HTML document if you were to actually render them like this. They're almost certainly not going to be where you want them to. The title is document metadata. That belongs in the head. The style sheet is deep within the document. The browser can't start downloading it as early as it could, and will likely paint before loading the style sheet, and you'll end up with a visual bug called flash of unstyled content. This seemingly simple task of fully utilizing HTML from within a component isn't so straightforward. So let's see how we might solve it today. One sign of a good component is whether you can understand, one sign of good composition is whether you can understand a component's behavior without having to consider all of the other components in your application. We call this concept local reasoning. We can preserve local reasoning by using UseEffect or portals directly inside our article component to insert these tags into the document. But now we've lost these critical pieces of information in our server render. This is even worse than before because bots and other technologies that don't run client-side JavaScript are going to completely miss the title. And the style sheet's loaded even later, so the browser won't be able to discover it until React has hydrated. Really, the only viable path forward is to split our component up. We need our HTML to look like this, with our title and style sheet server rendered and in the document head. So we can provide these tags to the component responsible for rendering the head. But now we have another problem. We have to figure out how to get article-specific information into one of the most generic components in our entire application. We've thrown local reasoning out the window, and we have a complex coordination problem to solve. And whether you solve this problem yourself in your app or you use a library to handle it for you, this coordination is tricky to get right. So what would it look like if we had a React-powered solution for this problem? We started with the premise that this composition of HTML, this composing of our HTML was ideal for component composition. And we also said that this was ideal for our document composition. So in React 19, we set out to make it possible for you to have both. Solving document metadata isn't that complicated. Title tags title tags, links, meta, they're typically only in the head anyways, and so we can just kind of ensure they're positioned there when server rendering, and we just need to make sure that hydration can find them, even if they're not sort of inside the component where it would normally look. But style sheets are a bit more challenging. Style sheets are sensitive to their relative order because later style sheets override earlier ones when style rules conflict. For this, we need a little help from you. In React 19, if you tell React about the precedence of a style sheet, React will insert it into the document head, ordered relative to the other style sheets with a defined precedence. In this example, I have a list component, which renders a style sheet with a precedence that I chose to call default. Precedence is loosely modeled on CSS layers, where later values define higher importance. So now, when I render a style sheet in my article component with a precedence value of high, React will insert it after the style sheet found in my list. But now imagine I have a carousel component which renders a style sheet with the original precedence, default. React ensures that this style sheet is ordered alongside other style sheets with default precedence, even if it was discovered much later in the render. With precedence, React can safely reorder the style sheets to optimize their loading performance, but we still need one more thing to make these really composable. React understands that each style sheet needs to only be loaded once. So even if you have different components that all depend on the same style resource, or you render the same component multiple times, you won't end up with unwanted duplication. But relative order is only one part of the problem with style sheets. Earlier, I mentioned that browsers wait until all the style sheets in the head have loaded before doing the initial paint. This is a critical feature for browsers because it prevents pages from rendering unstyled content or flashing unstyled content on the initial load. But React isn't just about loading initial documents. With server streaming rendering, it might discover a style sheet late, long after the head tag has already been sent to the browser. And on the client, React can discover new style sheets on any update. If React is going to provide a useful capability with style sheets, we can't let flash of unstyled content bugs ruin the experience. So when you use the precedence prop, React will also ensure the style sheet is loaded before revealing the content of the nearest suspense boundary. You can think of this feature as suspense for CSS. Suspense for CSS works across server components, streaming server rendering, and the client, so you can confidently render your style sheets inside the components that depend on them. React 19 also adds support for hoisting and deduplicating async scripts, another HTML feature that has historically been hard to compose within components. And it also has support for preloads and other kinds of browser hints with new APIs that can be used both during render and during user events like hover and click. Now, I can probably guess that many of you don't include these kinds of HTML tags or features directly into the components you write for your applications. And that makes sense. These features have historically been very hard to coordinate, and it often took the power of a dedicated library or a bundler to make this feasible. And that's okay. We expect the earliest adopters of these new features to be libraries and bundlers that can remove significant complexity from their implementations. But we hope over time folks will experiment with using these features directly in their applications now that React has made it possible to actually compose them nicely. You can find more information about React's HTML coordination features in our docs at react.dev. And if you want to learn more about how these features work, check out my talk this afternoon where I go into more detail about the problem and how we chose to solve it. Okay, before I wrap up, I want to share a quick update on hydration. In React 18, we launched a new selective hydration feature. And with this, React can hydrate parts of your application and prioritize components that have user interaction like click events. However, as part of this release, hydration warnings became more prominent and were often frustrating to debug. Well, in React 19, we made two key improvements to hydration. First, React will now make extra DOM nodes in the body and the head. React will be more tolerant of extra DOM nodes in the body and the head, which will improve compatibility with third-party scripts and browser extensions. Thank you. I don't want to ruin the enthusiasm, but hydration errors are still going to happen, unfortunately. And for that, we've made some serious improvements to how we report these errors. Before, when a hydration error occurred, your console repeated the error multiple times, and the necessary information to debug the root cause was hard to find and often not very useful. Now, in React 19, hydration errors are consolidated into a single error report, and most crucially, they contain a diff of the props and the elements that are different. Now, look at this. All right, I hope you're as excited for these new features as I am. Here's Andrew to tell you more about actions and JSX. Thank you.
Good job. All right. Thanks, Josh. Hi, I'm Andrew, and I am also an engineer on the React team at Vercel. I've been working on React since 2016, and it was actually at that year's React Conf that I somehow tricked them into letting me join the team. So I'm happy to be here again. So let's talk about some more improvements in React 19. The first one we're going to talk about is React Actions. Actions originally landed in the Canary channel last summer, and you may have heard about them in the context of something called server actions, a feature available in server components frameworks like Next.js. But actions are not exclusive to server components frameworks. They also work on the client, even if you don't use a server framework at all. So, what are actions? Actions are a first-class pattern for asynchronously updating data in your application in response to user input. Actions as a general pattern are not a React invention. They've been part of the web platform for decades. In fact, when HTML form actions were first introduced to the web back in the 1900s, JavaScript had not yet been created yet, if you can believe it. Form actions were the way to add interactivity to your web page. And in recent years, there's been a resurgence of actions-inspired APIs within the JavaScript community, thanks in large part to Remix, a React framework, Remix. A React framework whose web-centric and form-centric design has been greatly influential in reintroducing actions as a pattern for server-client communication. Nowadays, it seems nearly every JavaScript web framework has their own take on the actions pattern, and for good reason. We think that actions are a fantastic way to build applications, and they fit perfectly into the React programming model. But if action-based APIs already exist in React frameworks, why are we building them into React? We think we can take actions even further by integrating them directly into React features like streaming SSR, selective hydration, suspense, and transitions, all while maintaining React's obsessive insistence on composability. Our goal is to provide a core primitive that frameworks like Remix, Next, and Redwood can build on top of, the same way they currently build on features like streaming and suspense. To understand how actions in React work, let's go back to the beginning and look at form actions in HTML. So in a classic HTML form, you specify a server endpoint by passing its URL to the action property. When the user submits the form, the data is sent to the server, and the server responds with a fresh HTML page. So submit form, load page, submit form, load page. It's pretty simple, right? And what's great about this model is that you can use it to build almost anything. So why don't we? Because I've seen a ton of web apps, and almost none of them are built this way. Nowadays, a web developer could go their entire career without ever using this API. And what happened is, upon the introduction of JavaScript, we all love JavaScript, if it eventually became possible to build client-heavy web apps that provided a much richer, more interactive experience than apps whose behavior was confined solely to the server. Today, when a user opens your app, they have certain baseline expectations. They expect instant feedback when interacting with the app. There's no time to wait for an entirely new HTML document every time you click. And they expect apps to remember their current state. So you shouldn't lose your scroll position or your text input whenever you perform an action. In other words, users expect more than what's possible to achieve without at least some client-side interactivity. Because of this rise in user expectations, code written for the web went from looking like this to looking more like this. And there are some nice things about client-side event handlers. They can be used to implement instant, rich feedback to user input, and they can compose client and server behavior together. However, they also have some downsides. Managing local state asynchronously is super hard and frequently leads to bugs like race conditions. And because event handlers rely on JavaScript, the UI is not interactive until the code loads and runs, which is slow compared to raw HTML and leads to dropped interactions. So it's tempting to revert back to plain HTML actions. They have a very simple reload everything model that is super forgiving to all your application code, whether it's good or whether it's maybe a little bit sloppy. And they don't rely on JS, so the app is interactive as soon as the HTML renders. But we shouldn't forget about the reasons we moved away from actions in the first place. They provide little to no immediate feedback in response to user input. You're basically just stuck with whatever the browser stock controls give you. And it's really difficult to sprinkle on additional client interactivity, because it's an entirely different programming model. React exists to solve exactly this kind of riddle. We've done it over and over and over again. How do we combine the structure and simplicity of server-driven apps with the rich interactivity of client-side apps, all within the same unified, composable programming model? So, how do React Actions achieve this? React Actions are an evolution of two existing APIs. The first is React Transitions, a powerful feature for updating state without blocking user input, introduced in React 18. Actions build on transitions by adding support for asynchronous functions. And the second, of course, is the HTML form API. Using a React action is a lot like using an HTML form action, except instead of passing a URL to the action prop, you can now pass a function. And in the most basic example, that's all you have to do. Pass a function to the action prop, and when the user submits the form, the action is called. By using an action function instead of a URL, you can define the behavior of the action directly inside your component. And now notice there's nothing special about an action function. They're regular functions. You can compose them, you can write abstractions for them, the same way you would any other function. You can define the action on the client, or if you use a server component framework, you can define the action on the server via the use server directive and access your data layer directly. You can have any number of actions per page, per component, per whatever. You can swap out actions at runtime, And we can achieve this level of maximum composability because we've integrated actions into every layer of React, from the client runtime to the streaming SSR renderer to the server components data format, all working together to provide a seamless experience. You'll notice that in addition to looking a lot like HTML actions, actions also look pretty similar to event handlers like onSubmit or onClick. By convention, we use the word action when naming actions and the prefix on or handle when naming event handlers. Despite the surface level similarities, though, actions have some important abilities that set them apart from regular event handlers. One such ability is support for progressive enhancement. Form actions in React are interactive before hydration occurs. And believe it or not, this works with all actions, not just actions defined on the server. If the user interacts with a client action before it is finished hydrating, React will queue the action and replay as soon as it streams in. If the user interacts with a server action, we can go one step further. It immediately triggers a regular browser navigation, just like a classic web form. No hydration or JavaScript required. Yeah. Another area where actions really shine is in their handling of asynchronous logic. React actions have built-in support for UX patterns like optimistic UI and error handling. These are essential to building delightful user experiences, but they're notoriously difficult to implement correctly due to their asynchronous nature. Actions make these complex UX patterns super simple by deeply integrating with React features like suspense and transitions. With new hooks like use optimistic, use form status, and use action state, you can start implementing these patterns with just a few lines of code. Later today, we'll get an in-depth look at how to use the new action APIs to improve your app's experience. I'm really excited about those, so stick around. So that's actions in React 19. They're effortlessly composable. They have a unified client and server API. They're interactive before hydration, and you can implement advanced UX in just a few lines of code. So before we wrap up the React 19 portion of the keynote, I want to cover one more topic. Fair warning, this has nothing to do with actions or anything else in the rest of the keynote, but I think it's worth mentioning. React 19 includes a couple of changes to the JSX runtime, and most of them are related to everyone's favorite React feature, refs. Boo! Oh, okay, let's just wait. Well, I'm happy to announce that in React 19, ref is a prop. We did it! This took a lot of work. Okay, so on the surface, this is maybe an unremarkable change, but it in fact fixes a complaint that people have had about React for a while. Because in past versions of React, ref was not a prop. It had special behavior in the runtime. You could pass a ref to a component as if it were a prop, but in the receiving component, the ref would not appear in the props object. And as many of you are well aware, this made it difficult to create abstractions and components that accept a ref, which is a bit absurd given that React, as we all know, is all about composition. The historical reasons for why React treated refs this way are pretty boring. It's related to something called class components. I don't know if you've heard about that. So a few years ago, to solve the problem, without breaking existing behavior, we introduced a workaround API called forward ref. Boo! So mission accomplished, I think. Look, we all know you hate forward ref. It's cumbersome to write, doesn't play that nicely with TypeScript, and it shows up everywhere in your component tree. It's also just a little bit offensive, right? Why is something that should be so simple so complicated? It was the best way we knew to solve the problem at the time without introducing a breaking change. But today, we are finally making that change. Ref is now a regular prop. It appears in the props object, and that means you never need to use forward ref again. All right, that's the end of the conference. I think we can just end it there now. To make this happen, we are removing some long-deprecated APIs, including string refs and the legacy context API. We've been warning about these for a while, so most of you are probably unaffected. If you do have an older code base, we publish an upgrade guide with advice on how to gradually upgrade your components. So those are just some of the features and improvements coming to React 19. There's a lot more that we did not cover, but you can read all about those updates on our blog. And speaking of our blog, a few weeks ago, we announced the React 19 beta with a call for library and framework authors to test it out in preparation for a stable release. And so far, the feedback on the beta has been pretty good. So as a result, today, we are upgrading the beta to an RC, release candidate. That's right. That means we think it's stable enough for you to start trying React 19 in your applications. And pending any last-minute feedback, we expect a stable release of React 19 within the next few weeks. And with that, I'm going to hand it back over to Joe to talk about what's coming next in React. Thank you.
Awesome. Thanks, Andrew. We're really excited about the features in React 19, and we can't wait to see what you build. So forward ref, it's gone, finally. So speaking of APIs that are a compromise and that took us a while to get rid of, earlier in the presentation, we mentioned that our goal with React is to help developers achieve a great user experience. And a key part of that is near and dear to me is performance. Now, developers are able to achieve great performance with React today. We hear this all the time. But it comes with a compromise, the need to do manual memoization. Now, sometimes in life, we all got to compromise, right? Got to eat your vegetables. But there's something so elegant about the code that we write with React. So rather than add yet another API or change the way developers have to write their code, we think that there's a better way to have great performance and a great developer experience. To show you what I mean, here's Satya.
Thanks, Joe. Hey, everyone. I'm Satya. Awesome. All right. Well, with that out of the way, let's get started with the demo. So, yeah, we have a music player app here. We've got the now playing song and a playlist with a list of songs on the right. It's pretty snappy, right? I can drag this slider and there's no lag. React is actually pretty fast by default. But this is a high-end MacBook, right? Let's see how this app runs on a lower-end machine. I'm going to simulate that with the Chrome Performance Panel and do some throttling. OK, when I drag the slider, it's a bit choppy, but not really noticeable. Let's add this clock that my teammate Dan built. You may have seen it in one of his old talks. So green means everything's snappy. Yellow means we're slowing down. And red means we're in the slow lane. So let me drag the slider and see what it looks like. OK. There's some lag that we can see now with the clock. Let's debug why that's happening. So we've got the React DevTools. The React DevTools can highlight components that re-render by drawing boxes around them. Let's turn that on. All right. Now when we drag the slider, we see that the playlist is re-rendering. That doesn't seem right. Let's dig into the code to see what's happening. OK, so here's the music player component. We've got some initial state. And the state is being updated by the now playing component when I drag the slider. And that causes music player to re-render, which then causes the playlist to re-render. OK, I see the problem now. Luckily, there's a handy function that React gives us called Memo. Let's use that. So we can wrap our playlist in Memo and update the JSX. OK, going back to the demo, now we see that the performance issue is fixed. Playlist is no longer re-rendering, and the app is fast. Now imagine a number of engineers have worked on this app to make it fast and find all the optimization opportunities. And then a few weeks later, a new engineer comes along, and they want to update this component. We no longer want to display all songs, but filter a list of new songs. So they come in and update this to create a new list of filtered songs, and then pass that down as props. And when we go back to our app, the performance issue is back again. With one small change, we've lost all the optimization work that we've done. The problem is that filtered songs is being recreated on every render, which breaks our memoization. To fix this, we need to wrap this filtered songs in a use memo. And now, going back to our app, the performance issue is fixed once again. As you can see, performance is like a game of whack-a-mole. You have to constantly think about it. Also, looking at our component, there's a lot of memoization code here, distracting from all the product code. Right? We want to just see the actual business logic. Wouldn't it be great if we could automatically memorize our component and not have to do all this manual labor? Yes. Well, we've been working on a tool to do exactly that. Let me stop the server, delete all the memoization that I added, restart the server, but with the new tool that we just built. And going back to our app, there's no re-rendering of playlist. Our app is performant even without manual memoization. OK, but what if I add back the filtered songs? Does that break the memoization? So we can go back and update the component and then pass filtered songs as a prop, and going back to our app. And our app is still fast. So as you can see, you don't have to think about memoization again. You just focus on building your app, and the app is fast by default. To talk about this tool that I just showed you, let me invite Joe back on stage.
So you all have no idea what that possibly could have been now. You didn't see anything. It's still a surprise. Okay. It's all good. So we just ran a different command, and things got magically faster. That was React compiler, so you kind of figured that out, I guess. But it's React compiler. It's a tool we've been developing at Meta over the last few years. React compiler automatically optimizes your components and hooks so that only the minimal parts of your UI update as state changes. So that seemed pretty magical. How could that possibly work? It's really not so scary, so let's walk through it. First, let me explain what I mean by compiler. We hear a lot about compilers these days to refer to all different kinds of tools that transform code ahead of time. There's been a lot of really great exploration in this space, and it's so exciting to see all the different approaches. React compiler is more like TypeScript, or the compilers inside JavaScript engines like V8 or Hermes. It breaks your code down into individual expressions and builds up a control flow and data flow graph. It performs sophisticated optimizations, like dead code elimination, constant propagation, type inference even, alias analysis, and a whole bunch more. If you aren't familiar with these terms, that's OK. The whole point is React compiler does that for you. These are optimizations that would typically appear, again, inside a JavaScript engine or compilers for languages like Rust or C++. With React Compiler, we're applying these ideas to improve performance without sacrificing developer experience. The code you write doesn't change. You saw that it was just the original React code right from that component. And our apps get faster by default. In particular, updates get faster by default. In fact, our code gets even more clean and concise because we don't need manual memoization. So that's what I mean by compiler, but what is it doing? How does it actually make that work? So let's go back to that media player example from earlier. This is a really concise, clear description of our UI logic. There's really nothing extra or unnecessary here. No use memo calls, no random unnecessary callback functions, just clean code describing the values we want to show in our UI. But there's a lot of information contained in this code that we might not always think about. For example, consider the filtered songs list. From reading the code, we know that filtered songs depends upon songs. Whenever songs changes, React is obviously going to have to filter that songs list again and update the playlist. This code also tells us the inverse. If songs doesn't change, then React shouldn't have to update the filtered songs, and it doesn't need to update the playlist. And as Satya showed, that's exactly what happens with the compiler enabled. We don't have to update the playlist when songs isn't changing. Now, we're able to understand this because JavaScript and React have clear rules for how they work. And we've learned those rules. We use them every day as we're reading code, writing code, debugging code, and occasionally testing code. We can also teach a compiler to understand those rules. The compiler sees this code very much the way that we do, except it's way more thorough, applying the same process to every value in our code, creating a computation graph of how your data moves through your UI. So this gives an idea of how React Compiler sees your code. But as I mentioned, the compiler knows the rules of React, and it knows some extra things. For example, it knows that set state functions don't actually change. So the compiler doesn't have to consider whether that value could update. So we can remove that dependency edge. So now we know that if setSong gets called and the song changes, from this graph we can clearly see the only thing we have to update is now playing, not the playlist. So this explains the behavior that we just saw in that demo. But the best part is that all this information comes from the same React components and hooks that you're already writing today. There's no API to learn. There's no need to change the way you write code. We can simply take advantage of all the information that's already right there in your code today. Some folks describe these type of precise UI updates as fine-grained reactivity, which I think is a pretty apt term to describe it. But as we've shown, we don't need anything new. All the information is already right there within your React code. Now, that all sounds great, and I know when I see a demo, I'm skeptical. Does it work in prod, right? Well, I'm excited to share that we've been using React Compiler in production at Meta since early last year with exciting results. To tell you more, here's Mofe.
React Compiler at Meta. So we're going to talk about how the compiler performs and pit it against apps at Meta. But first, we need to see what these apps even look like. Ooh, I got to update. Somebody did not update their operating system. Oh, I can't click away. I have to click update now. Ah, thank goodness there's a conflicting application running. We're back. Okay, but anyways, so we're going to talk about how these React Compiler performs on these apps, but first we're going to need to talk about what they even look like. So let's first talk about their code. We noticed that React code at Meta can be mapped neatly onto 2 dimensions. On one axis, we have how fast or slow the app itself feels. How long does it take to repaint the page when I hover or click a button? On the other axis, we have readability. How concisely does the code describe business logic or what's shown on the screen? And just so we're on the same page, you want to be here. Fast interactions and easy to read. Now, a lot of the code that we see is in this quadrant. Most React code at Meta is pretty easy to reason about and also performs well. But on pages that have a lot of interactivity or just even a lot of components, for code that describes complex bits of UI, we find that developers start making trade-offs. Complex apps that haven't been optimized with use memo and use callback tended to be a bit slower but stayed easy to read. And a small sample of the code that we saw was pretty difficult to read. This code contained a lot of manual optimizations, which helped make the UI feel snappier, but they also made the code much more difficult to reason about. This is all a bit abstract, so let's take a look at one of these samples. So this is an actual, real React component from our code base. I had to rename some of the variables for legal reasons, but please trust me, some poor engineer at Meta actually needed to write all of this to describe their UI. And just to repeat, this is a single function, one component. We're not going to read any of this code, but I want to show you why it takes so many lines to describe this logic. Let's Control F to search for every call of use memo and use callback. Wow, that's almost 20 places where that developer hand-optimized an object. I also want to see how much of this code on the screen is spent just describing memoization. So let's also highlight the dependency array arguments. Oof. So all of the code in red that only exists to describe how to avoid recomputing values. And finally, I want to see how much of the business logic had to be wrapped and passed to use memo. This reflects how much cognitive overhead it takes to edit the core logic of this component. Oof. So now that we've kind of drawn this graph and written these axes, I'm going to tell you about the real meta apps represented here. This highlighted point we've been talking about, with the super long piece of code, that comes from a React Native app called Quest Store, the app store for Meta's Quest VR devices. Meta engineers spent a really long time hand-optimizing Quest Store because of how dynamic and interactive it is. For example, take the product details page, which I'm showing here. I've already bought Beat Saber, so I get a button that says download instead of purchase. And I can click or scroll with my headset controller through the left panel for different detail types, which might also differ across games. Now, you might also recognize another very dynamic, highly interactive React app built at Meta. And that's Instagram.com, a pretty complex website with a lot of hand optimizations. In 2023, we began rolling out React Compiler on both of these apps. Now, I originally had some boring stuff here, like how we resolved to roll out without rewriting any code, and how the compiler avoids cheating by removing memoization that developers wrote. But let's just get to the fun part and talk about some results. The rollout was a success. React Compiler has been enabled on Quest Store and all of Instagram.com as the default experience. Woo. So if you've browsed for any Quest apps or used any part of Instagram.com in the past couple of months, you've almost definitely been using React Compiler. In terms of performance, we measured that for some click and scroll interactions, the compiler-optimized version was more than twice as fast as before. We also saw initial load and cross-page navigation times improve by up to 12%. And finally, we observed that there was no impact on either memory usage or overall crashes, which may reflect out-of-memory errors. This improvement didn't apply to just a few pages either. We observed that Quest Store loads and navigations got faster by at least 4%, and Instagram saw an average 3% improvement across every route. At Meta, this was a really big deal. I mean, to put these numbers in context, engineers had combed through every single bit of these apps to add thousands of memoization calls. And of course, this work was done against metrics, which rewarded and the scale of every single optimization. On such an app, improving just a single thing, something like the time to first paint of a specific page, by just 1 or 2% would already be a huge deal. But React Compiler had significantly improved the performance of nearly every page it rolled out on. So how did the compiler do it? What did it do differently from all of these hardworking engineers? let's take a look at that code from Questor again. Now I'm going to draw some white boxes to show places where React compiler was able to add memoization that wasn't already there in source. We see that even on such a heavily optimized function, the compiler can still find additional opportunities for optimization. On less optimized apps, we found that React compiler can add over 15 times the amount of memoization already present in source. The best part? Developers can now go back and delete all of this cruft without affecting the performance of their app. Yeah! So what this all means is that with React compiler, developers will be able to get fast interactions on apps that haven't been manually optimized and improve the readability and maintainability of already optimized ones. In fact, we've just seen how React compiler can even raise the ceiling for just how fast apps can be, as it can optimize much more than developers can with nested and conditional memoization, as well as sophisticated static analysis. Since proving out the core of the compiler last year, we've continued to roll out to even more apps to iterate on the compiler and, of course, the development, debugging, and testing experience. You may recognize some of these. To talk about what's next for the compiler, I'll hand you back to Joe.
Good job. So that's React compiler. We will give you another update in 3 years. Let you know how it's going. So as Satya demonstrated, React compiler allows developers to continue writing the exact same code you're used to. In fact, as we saw, we can stop using manual memoization, so get even more clean and concise code. And as Mofe shared, React compiler can deliver significant performance improvements to real-world applications. That slide is blank. Rick changed the slides last minute, so thanks. No, it's good, it's good. I like it. Now, we've tested and shipped React compiler at Meta. And at this point, we need your feedback to help get it ready for widespread adoption. So I'm excited to share that today, we are open sourcing React compiler and publishing yes. 2 years. I'm not going to lie, 2 years building to this moment. It's been a lot of blood, sweat, and tears. You know, literally blood, like thinking about the compiler while going on a run, tripping, falling. Yeah, just like it's been a lot. So starting today, when you upgrade to React 19 RC, you can also install an experimental version of the compiler to get these same user experience wins without sacrificing developer experience. Installing the compiler is simple. There's a lot of complexity going on within the compiler, but to install it, it's just a Babel plugin. So install the Babel plugin. There's also an ESLint plugin that you can use, which will help to show if you have violations of some of the rules, like kind of an extended version of the current ESLint plugin. And again, you know, just drop this into your Babel config. The compiler is definitely not done. This is an experimental release, so expect that there will be bugs or things that don't work. To help get the compiler ready for widespread adoption, we are also announcing that we're starting a React compiler working group to collect high signal feedback from a small group of early adopters. If you're interested in taking part, please see how to apply at the URL here. If you'd like to learn more about the compiler, we have 2 amazing talks scheduled. Later today, my teammate Lauren Tan will talk more about how to get started using the compiler in your app today. So if you're interested in trying out the compiler, highly recommend checking out Lauren's talk. And if you're a nerd like me and want to know how the compiler works, Mofe and Satya will be talking about that tomorrow. It's a really approachable talk. I highly recommend checking that out to kind of get more of an idea of how the compiler is actually doing this magic. Last but not least, this has been an incredible journey. As I said, 2 years of a lot of work. I'd like to thank my amazing teammates, Lauren, Mofe, Satya, Jason, Jan, he's here somewhere, and of course, Seth, who runs React at Meta. He helped to convince our leadership to fund this crazy effort and see the forest for the trees. That's it for now. Check it out, tell us what you think, and enjoy the conference.
Now keep the love going, keep the love going. Gives you a huge round of applause. That's amazing. That's a lot of that was actually jam-packed first hour. Like, we're hitting it strong for the day. All right. So we are gonna continue our practice, right? So I'm gonna say sac passe. You guys are gonna respond ma boule. So sac passe. All right. So like y'all have been repeating that, but does anyone know what that actually means? Okay.
And mot boule, sac passe is what passes, or what's passing, what's going on. Mot boule is I'm boiling.
Spot on, spot on.
Sac fait.
Hey, now fall. All right. So our speaker has definitely gone through, well, I'll say like the boot camp, and definitely has earned his Haitian Creole title. Shout out Duolingo. They actually has Haitian Creole on Duolingo, so if you're really interested and want to follow through, be my guest. But yeah, so hailing in from Salt Lake City, our next speaker. Most of y'all have probably heard around. If you haven't, I need a shout out and really like anticipate for this talk and be really excited. So let's give you some huge love for Ryan Florence.
Holy cow. This is fun. Thank you, Ashley. Last time I was on this stage, I got to introduce to the world Use Effect. Let's hope the content of this talk ages a little better in your minds than Use Effect has. Now, I still like Use Effect. You're all just haters. So, Vanilla React, or 10 years of React Router. I made the first commit to React Router literally 10 years ago last week on May 9th. I was a young man back then. My wife got me that sweater. And I had no idea that I was signing up for 10 years of open source, and that changes a person. Here are the first commits to React Router from the bottom to top. The highlighted one's my favorite. What's up? I just beat React. I remember this. Look at the timestamp. That's 1:13 in the morning. I was just going all night, and you can see I like wake up and I'm making commits at 7:50 in the morning right after. So this is when I fell in love with React, and I knew that it was changing everything. And I was so excited. So, and I felt like I'd beat React. I'd figured it out. React these days is a little harder to beat. But on the remix team, we're trying. We are trying to beat our React again. Speaking of remix, it is a full stack web framework on top of React Router. So this is something that our team, we build both React Router and remix. We launched this a couple years ago, and Shopify reached out and said, hey, we like what you're doing. How would you feel about building this under our roof? And we said, absolutely, and it's been awesome. People ask me all the time, what's it like since you guys have been at Shopify? And I think for the relevance of this talk, probably the biggest, most important thing to me about being at Shopify is when you're building a framework, it's really easy to like fall into this idealism, pedantic trap of like, no, this is the way it needs to be. You got to balance that with the pragmatism too, right? And there's so much code at Shopify in React for both our own stuff and externally with our merchants that it's really helping us to find that balance of idealism that you need. You need that in a framework, but also the pragmatism that comes from the real world. So why is this talk called Vanilla React if I'm just going to shill Shopify, Remix, and React Router? I wanted you to stick around after the keynote. No, the docs have recently said on React, if you're building your whole site in React, you probably want to use a framework. And so if React is saying, hey, use a framework, naturally this new kind of term pops up of like, well, I don't use a framework, so I'm using Vanilla React. And if you go and dig in and look at those Vanilla React apps, most of the time they're using React Router. In fact, 7.8 million repositories on GitHub have React Router in the package JSON. It's more stressful than it is exciting for us, but One of those is the admin app at Shopify, and it's 5 million lines of React and React Router. Just enormous, right? There's just so much React out there. I can't believe we're still using it after 10 years. I thought we were supposed to switch JavaScript frameworks every month, right? But here we are, a decade later, and we've got apps at Shopify. You've got apps that are 7, 8, 9, 10. Some people even have 11-year-old React apps. And we got to figure out, when an app gets that old, you kind of start asking questions, right? Anyone been in a meeting like this about that old React app? What are we going to do about this thing? We should probably start modernizing it, right? So what does that mean? This guy over on the right, he's like, modernize? I still got a Flux store in my spot. We're probably looking for code splitting, simplified data loading, form actions, server actions, simplified pending states, optimistic UI, server rendering, static pre-rendering. RSC is coming. Again, that guy's like, don't talk to me about RSC. I've got Flux stores. Actually, no. This one is Apollo, and this one's just GraphQL by itself. Most of these vanilla React apps were probably bootstrapped with Create React App. Great project that helped get a lot of React apps started. Here's the commit history of Create React App. 10 months ago, last year, 2 years ago. Those are the top 3 commits. So not only is this project dead, it's been dead for a long time. So if you're trying to modernize your stack, this probably isn't the thing. And if you want to join what we're doing at Shopify and what appears to be what a lot of the community is doing, people are making a move over to the Vite plugin React. The absolute numbers on these graphs are usually not super interesting, but the trends are where you can actually find information. And we can see that the trend here is definitely moving vanilla React apps over to Vite. So even if you switched over to Vite and you're happy with it, you still have all these questions of how are we going to do server rendering or whatever else we're looking for. You're either going to have to build your own framework around this stuff on Vite, or you're going to have to go adopt a framework to take advantage of not just current features of React. It's had server rendering since forever, right? But all the future stuff. You want your app to be ready to take advantage of everything that we've already heard about and everything that we're going to hear about for the next couple of days here at this conference. So the React docs are like, oh, you should probably adopt a framework. And so someone says, well, let's try Next.js. Someone says, well, that's a rewrite, and it's 5 million lines of code. We're not doing that. Well, I heard Astro's a little less opinionated. That's still a rewrite. Well, we use React Router, and the Remix team builds both, so maybe let's do that. And they said, no, that's also a rewrite. I take offense to the last one, because we've always said Remix is just React Router plus compiler equals Remix. And I've said that till I was blue in the face, and then some people believed me, and they tried it, and they're like, all right, fine, I'm going to go move my app from React Router to Remix. And they came back. They said, nope. That felt like a rewrite. So I, as a team, but even me personally, I made that first commit to React Router, and it kind of blows me away that it's at this stage now, and it would not be here without my partner, Michael Jackson. I feel a great responsibility for all of these millions of apps. I mean, most of these are just stupid things you did on the weekend, right? But there's got to be at least 1 million real ones. And I feel responsible for that stuff. How do we move that stuff into the future? We're really proud of Remix. We're proud of and appreciate the shout out with our form actions and pending states and revalidation. We're really proud of what we've built, but it does feel like a rewrite. All the options today in that meeting are just kind of hard. So we've been really thinking about this. We talk about bridges a lot on our team. We're trying to help people. We're trying to build a bridge to the future of React. We shipped a couple of features recently that got me thinking. We shipped SPA mode in Remix that allows you to ship Remix without a server. You don't have to do server rendering. You can still get the benefits of Remix without a server. And then we also brought in the Vite compiler instead of building our own. And these two features kind of drew some pretty good lines around all of our code to where it really was just React Router plus a Vite plugin equals Remix. And I realized, and I tried it, I could swap the dependencies in my app from Remix Run React to React Router DOM, and it still worked. So everything that Remix does today, it's simply reaching into React Router to use features from React Router, and the Vite plugin is what makes it a little bit more convenient to do that. So I started thinking, Well, maybe we don't have a React Router v7. We just do Remix v3, and we tell everyone using React Router, hey, install Remix now. That sounds nefarious. So I thought, well, maybe we go the other way then, and maybe Remix becomes React Router v7. Maybe we go the other way, and Remix becomes React Router v7. 33 people had a clue what I was saying here. So what do we get? What if we brought the Vite plugin that makes React Router easier to use just over to React Router? Well, we'd get all of this stuff. So now you're sitting in that meeting and you're just thinking and you're like, first of all, what happened to the rest of my finger? And then the second thing, oh yeah, wood shop in 9th grade, I remember that. And someone's like, we really need to start server rendering this page, and RSC looks interesting. There's a few pieces that we want to use RSC. What are we going to do? This is not scary, especially if the React Router team can pull it off in a way that's incremental, right? That isn't a rewrite. Not only does it not need to feel like a rewrite, it needs to not be an emotional rewrite, but it needs to technically not be a rewrite. We got to be able to increment into this thing. So that's exactly what we're going to do. We're going to bring the Vite plugin from Remix over to React Router. And now you'll have easier access to all the features React Router already has, but Vite just makes it more convenient. It's not out yet, but it will be in React Router v7. If you've been watching our commits, you'll know exactly what's been going on the whole time. We haven't hidden any of this. So the question comes, well, what about Remix? Because we got any Remix users in the house? A few of you? A couple really loud ones. Kent's up here. I don't know if you noticed, but on that slide with everybody's avatars, Michael was just showing me, Kent is on it like 12 times. In the bottom right corner, there's like 5 of him. Remix is going to just take a little nap. We got some ideas for what Remix, the project, the code is in the future. But for the time being, all the code, we've been doing this the whole time. We've been moving Remix features over to React Router ever since we started building Remix. And we're just at the point now where it's like, yeah, the last thing is just this Vite plugin, so let's just bring it over. So Remix is going to take a little nap. The brand, the swag, we've got some, go get it. The team, we're the Remix team. We have Remix meetups, we have Remix community. We're not getting rid of any of that stuff. We love our community and we love our brand, but you're just not going to install anything that says Remix. It'll just all be React Router. The split between the projects serves no technical purpose anymore because we've found the right lines and we figured out, oh, it's just a Vite plugin for React Router, which is how we described it from the beginning, so just kind of funny. So what does that mean for React Router? Like I said, it's all about incremental improvements. If we're going to bring those millions of React Router apps into the future of React, it can't be a rewrite. So I want to try to, I'm going to try to show that that's exactly how it's going to work out. If my demos and everything else are going to, oh man, I haven't even started this app. I thought I had it running in the back already, and this one takes forever. So this is a little demo app from the SST dev team, their demo on how to deploy to AWS. It's got real authentication with, I think it's using Cognito. It's got real data stores. It's got a payment processing with Stripe. So a really nice little demo app to just try out. So I have been migrating this over to React Router v7. So you can see here, this is the routes component that you probably have used before, and then you list all your routes underneath. I'm using a different HDMI cord than last time. That font's too small, isn't it? All right, is that good enough? Okay. And light mode, I'm blasting you. I use light mode on purpose because I like to see your faces. So I'm blinding you on purpose. So I've been migrating these one route at a time, and I want to do the last one right up here in front of you. You can see up here we're importing this notes component from containers notes. I can come down. This is the very last route that I have to migrate. No, it's wrapped in an authenticated route, a kind of common pattern that we see. So I'm going to comment this out and save. And now, oops, I should be on that screen. page not found. I don't have a note like that. Now I'm going to come over to my Vite config, and I'm going to add, I'm going to give myself a little more room. I'm going to add the route to the route config in the Vite plugin. So if I save this, notice it's pointing at containers new note as well, and the whole thing still loads. I didn't change any application code whatsoever. It's just moving to a different route. So what's different? Well, the first thing that's different is this just automatically and intelligently code split that route. That wasn't happening before. So after I migrated this whole app over to React Router v7, it dropped from about a 700 kilobyte initial JavaScript bundle to about 150 for whatever page you land on. So pretty big deal. And you just get that for free by moving it into what we call a route module in React Router v7. So let's go over and check out the component. And we've got, here it all is. The second thing that this enables is now that it's a route module, you have access to the React Router data layer. And like I said before, Remix just made it more convenient to get into the features that already exist in React Router. One of those features is export async function client loader. So this is going to call this function before it renders any of the page. And you get a request here, so it feels similar to the server, and you get URLs and things like that. I'm going to say await, require auth, and pass in the request. So this require auth thing came from the same thing that component, the authenticated route wrapper, was using. That's the same code there. I'm going to bring in function, client loader function. This is the worst named thing. It's not good if you love everything about it, right? It means you never shipped it. Let's rename it. Client loader function args. Okay. The sulfur. Yep, that's about how it smells with being that long. That's a fresh joke right up here. I didn't even think of that one ahead of time. But not fresh, actually. It's not going to stop now. Okay. Now that's how you protect the routes with a client loader. So this is a single page app. This is not server rendering. There's no JavaScript server. There's no Node stuff going on. It's all just in the browser, and that's what client loaders do. So here's what's interesting. I just did a tiny bit of stuff right. I got some features. I got automatic code splitting, and I can actually walk away from this now. I can make a commit. It can get deployed, and I can, if some bug, some fire is happening somewhere, I can go and deal with that fire, and I can ship this. So we can already see the incremental steps that we're able to take. Let's now move this note. It's in state right here. And this effect is what's fetching it. So let's move this whole effect into our client loader. Since we're in a client loader, we're outside of the React lifecycle, so I can just get rid of my effect. Don't need that. I don't need this funny onload thing that you have to do in use effects to have an async function, right? You've probably done that before. We've also got, gotta get rid of that. React Router automatically wraps all of your UI and your loaders in error boundaries, and this error is not really helping anybody. So I don't even need to wrap this in a try-catch because React Router's got us covered. This is just some state management stuff, which I don't need to do anymore because my client loader is going to deal with that. So I don't need this content anymore. This is a funny function. This has nothing to do with refactoring to React Router, but I just can't stand it. So I'm going to just, there we go. Don't need that load note thing. Notes ID, I'm going to need some params in here. So our client loader is going to get the params from the URL. And yeah, that's not bad. Oh, return the note. And then down here, where we were reading the note, we're not going to read it from our state anymore. We're going to read this from a thing called use loader data, which is a feature already in React Router, but it's just a lot easier with a client loader on your module. We're going to have better types here in a minute. Just don't get mad at me for this coercion, like you didn't see anything. And then this was a controlled component here for controlling the content over there, and it comes from the note, so now I just set it initially, and I should be able to save this thing. And if I click back here, and then click the note again, pretty cool. All still works. We got a little, not only did we delete a bunch of code, but we got a little UX improvement. Before, you'd get a blank screen because down here, this code is like, it's saying, where is it? It's way down there. If I don't have a note, just don't do anything. And so they would get a blank screen there at first. But client loaders are guaranteed to run before the component renders. So you don't have to worry about if there's a note or there's not a note. The transitions are handled by React Router. Now keep in mind, this is all React 18. So we got a lot of cool stuff coming in React 19 that we saw, a lot of stuff that the React Router has solutions for, but we had to build them outside of React because they weren't in React yet. It's really cool to see some of these features come into React in a little bit different shape because now they're composable. But even before React 19, you can still get most of those benefits with React Router v7. So again, it's all about incremental, right? This is another point where I can make a commit, and I can deploy it, and I can get back to other things, and I can get back to this again later. The final thing that I'm going to do here on this demo, I'm just going to copy all of this and just go back and paste it. So what I would do next is I would move my client, I'd bring in a client action, and this thing is just going to say, hey, delete the note or save the note. Pretty simple code. And note what happens to my component. Up top, all the states are gone. You remember what that looked like before? Had a whole bunch of states, and now they're all gone. In fact, this is pretty cool. If I do a search in the original demo, and I say use state, you can see there are 14 occurrences of use state in the original demo before React Router v7. Remember, it's already a React Router app. It's a v6 app. And incrementally, I remove some use states, and by the time I'm done, if I search in the migrated one, well, that can't be right. How can you have a React app with no use states? They're all gone. How much yeah, you can, I mean, just clap internally, clap loud, whatever you want to do. So much of our React state is just, I fetch something from somewhere and I put it in a cache. It's really what use state is most of the time. So this is all stuff that you can do with a single page app in React 18 with React Router v7, and you just saw we can do it incrementally. Let me show you a couple other demos. These should be pretty quick. This one over here is another store. This is also a single page app right now. And it looks really similar. Or sorry, no, the next one is the same as this, whatever. All right, so this is a single page app. You can see we get a little like loading state up there, like loading single page app. If I go into my Vite config in React Router v7, I can say SSR true. Make that change, and then I can come back to my thing here, and I can say instead of a client loader, let's do a loader. And you're not going to believe me, so I have to prove it. So I'm going to disable JavaScript, and I'm going to reload this thing, and it rendered. What the heck? So the Vite plugin figures out, okay, the loader's a server code, let's move it over there, and then it creates server bundles. And so you'll need to deploy that server bundle that it creates somewhere. We got presets and stuff that make it easy for most hosts. But you can see it's just these little tweaks. This page needs to be server rendered, maybe another one doesn't need to be. If you've got that JavaScript server, you can just turn that flag on to true and then switch client loaders to loaders. Or go the other way. Maybe it would make more sense to fetch things from the client, so switch it from loader to client loader. We kind of got obsessed in our community with static site generation. And we've been buttheads about it the whole time, like, get out of here. But anyway, we added it. So you can say pre-render, you can return store, and if I save this, we're going to take our server bundle that we just use on servers that get requests, and during the build, we're just going to make requests, new request, and pass it to it, and save some stuff. So check this out. If I say npm run build, generated build client store.data, generated build client store index.html. So if you want it, React Router v7 will let you do some static pre-rendering. So we got single page apps, we've got server rendering, we've got static pre-rendering. Am I missing something? I hear people whispering it. Should we chant it? All right, for my last trick, I already have errors. Oh, phew, it's working. It's not shipped. Like I said, this is all React Router v7 stuff. But if we come over here, I've got my loader. And you might decide one day, like, you know what? This bit of UI, this list of products there, these top products, we want to move that rendering to the server with RSC. So how do you move rendering to the server in React Router v7? Well, you select your code that you want to move to the server, and then you move it to the server. And then you come down here and you look at this product thing, and you're like, what is that? Well, I guess it's some stuff that I can render. Oh, yep, like I told you. I'm running on an experimental React router and a beta of React, so I got to restart this thing. Oh my goodness, look at this. Wait a sec. Is that interactive still? If I come in here to my carousel, it is. So React Router v7 will support server components. You just return it out of loaders. And now everything else in React Router still works the same. Loaders, actions, fetchers, our automatic revalidation. Your server components will just get revalidated the same way that React Router and Remix have always revalidated everything. And so everything here is incremental, so that you can take your current React Router apps and start getting the benefits of where React is going. So what do I want you to know? What do I want you to know about this talk? React Router has been here for the last 10 years of React, and with v7, it's ready for the next 10 years of React. Thank you.
All right. Oh, man. That's amazing. I always appreciate talks and projects that account for the brownfield, because that's where we spend like 80–90% of our time anyway. So love to see DevX improvements and advancements in that. Great. So time for a little recess. We're gonna go for a break and be back by 11, which I'll be hollering at y'all. If y'all see in the hallways, come by, say hi. I have stickers and vibes and hugs. See y'all.
Get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components.
two, hey, ha. Hey, yep. Huh. Oh God. Hey, ha. Hey, yep. Ha, 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 ha. Ha. Ha, ha, ha. Hey, hey. Hey, yep. Two, two, two. Copy. One.
Everyone, please take your seats as we are about to begin. All right. I hope everyone is now rejuvenated and ready for the next leg. I've been sharing where I'm from, but one thing I'm curious is where are y'all from? There's a lot of folks online, so I'm gonna assume definitely all over the world. I would love to see stats after this talk on just where everyone's tuning in from. But for those of you in the audience, is anyone coming in from North America? If you can, raise your hand. Woo, a good portion. Let's leave him up. Let's leave him up. Anyone coming in from Latin or South America? Raise your hand. All right, got a nice little cluster right there and over there. All right, shout out, que lo que. Anyone coming in from Europe? All right, hell yeah. Asia. Nice. Hey, we got some nice good representation out here in terms of regions. From the motherland, Africa. Anyone coming in from? Yes. All right. Great. Every continent has been covered. Ish. Australia, just for coverage sakes. No. No one from Australia? No. All right. Awesome. Well, the thing that I love about different cultures. I'm currently going through like a language journey, and I'm right now tackling Spanish. And like Ryan Florence was mentioning around like React routers, like how it's an amazing bridge. Right now, I love memes. I consume memes. I'm that friend that bombards everybody and my friends with the memes from my feed. But having going through Spanish now, I'm realizing that there's a whole category of memes that's getting unlocked. And right now I'm at the baby stage. So when I laugh, I'm starting to laugh. I'm saying ja, 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 because J is pronounced ha, ha, ha. I get that. Knee slapper. But even though, like we just mentioned, different locations, our next speaker is hailing in from Amsterdam. But the thing that's really, really exciting is that she just got her pilot certification. So she'll be able to reach out and visit your zones. Let's everyone help me give a huge and welcome applause to Lydia Halley.
Good morning, everyone, or good day if you're watching this online. I'm Lydia Halley, and I don't have much time here, so let's just get right into it. What is new in React 19? Now, I know that many of you sitting here today have used frameworks that already had React Canary bundled, so not all of these features will be really new to many of you, but there are many that are now stable in React 19. So the first one is that in React 19, we can now pass asynchronous functions to start transition. So transitions were introduced in React 18 as a way to mark a certain state update as non-urgent. And we can do this by wrapping this update in a start transition. So by default, React renders all the necessary components in a single, uninterruptible task. But depending on the complexity of this update, it can take quite a while before React has actually rendered these updates and then committed them to the DOM. And since this is all happening on the main thread, our application is unable to handle any other tasks during this time, which leaves the UI unresponsive. So if a user interacted with our website while React was rendering an update, they would experience quite some visual feedback delay. So transitions provide a solution to this, because instead of rendering the update as a single uninterruptible task, React will yield back to the main thread every 5 milliseconds to see if there are other tasks waiting to be handled instead. For example, that user interaction. Because if that's the case, React will pause the current render, let the browser handle the task, and then eventually get back to rendering. And it only commits these updates at the most performant time. So transitions ensure that the UI stays responsive during an update. Now, it's very common to have a scenario like the following, where a user can submit some input based on form data. So within the submit handler, we first manually set is pending to true. That causes React to re-render, showing the pending states. We then initiate the async task. Eventually, once that completes, we set pending to false, and then handle the data or error that gets returned. And this works, but a few things could be better. Let's say that we first update the data with the name Lydia. Now, if we rendered this to the UI, saying you successfully updated to the name Lydia or something, it could happen, or the following scenario could happen, which looks a bit visually overwhelming. But first, we update the name to Lydia. And while this submission is ongoing, we change the name to Evan. Now, finally, some data gets returned because our network request finishes. So now we set the data in the UI, so the state is now Lydia, but the user might have expected Evan because that was the latest submission. And that only happens after the second request return. So this could lead to some unpredictable, suboptimal user experience. And also, there's just quite a lot of boilerplate to handle data, pending, and error states. So in React 19, we can now refactor this to be a transition instead. So the use transition hook provides both the isPending states and the start transition function. So we no longer have to deal or manually set that pending state. So now, when the user submits some input, the transition starts, and isPending is automatically set to true. The data is fetched, after which the transition then starts to update the state based on that returned data. Now, a limitation at the moment is that by default, state updates after an await keyword within start transitions are not marked as transitions by default. So to make this a transition, we do have to wrap it in yet another start transition. This is just a limitation until async context is available, so just something to keep in mind until then. So now, again, if we have a similar situation as we had before, so we first submit Lydia, and then while that submission is ongoing, we change it to Evan, we only see one value rendered to the UI. And this happens because if there are multiple ongoing transitions, React will actually batch them and only commit the changes once all the transitions are done. And in this case, that only results in a single paint, namely Evan. So in React 19, functions that trigger transitions are now called action. So an action is just any function that triggers a transition, which we can do in multiple ways. The first one that we're now familiar with start transition. But we can also create an action using the new useActionState hook. And this is a new hook in React 19 that makes it really easy to use actions and also get these status updates on that transition that this action triggered. and also then set the state based on this return data. So this hook returns an array with 3 values. So first we have the action states, which is either the data that we pass for the initial state, so null in this case, or it's the data that gets returned by the action once the action completed. Then we have the actual action, which returns that action function that we pass as the first argument. And we can use this value to actually trigger that action or invoke the action to trigger the transition. And lastly, we have the pending state indicator, which is true as soon as the transition starts, and then automatically set to false once the transition has been committed to the DOM. So looking back at the code we had before, even though this was already refactored with the asynchronous transition, we still had to manually set that data. So instead, we can refactor this to use the useActionState hook instead. So we no longer have to have a separate data state, because that is now just returned from the useActionState hook. And the initial state value is now passed as the second argument, which is null in this case. The submit action is the first argument that we pass to the useActionState hook, which by default also receives the current state and the form data arguments. And because we get access to this form data, we also no longer have to manually set the state of the user's input. Instead, we can just directly get this from form data. And we can get the isPending state from the useActionState hook as well. So the behavior we see is the same, just with a lot less boilerplate. So invoking this action triggers a transition, automatically sets isPending to true, and then set to false once it's been committed. Now, React DOM allows you to work with actions directly through the action prop or the form action prop for buttons and inputs. So the values that we pass to action or the form action prop can be any function, whether synchronous or asynchronous, but they're all considered actions, meaning they all trigger transitions. So this action can either be from the useActionState hook or just a standalone function. And an action automatically receives the form data as a prop, which makes it really easy to work with these form values. And React 19 also introduces a new useFormStatus hook, which makes it even easier to get the status information from the last form submission. So this returns an object which includes the form data that's currently being submitted and also the transition's pending state. So the useFormStatus hook uses the action data from the parent form, similar to how contexts work. So we can use this hook within components that are rendered within forms, and it will just directly access the values of the action. So when the transition is pending, pending is true by the, or returned true by the useFormStatus hook, and once the transition has been committed, this is automatically set to false. So creating reusable form elements is super easy this way, and it's very easy to also provide that real-time feedback and status updates to users. And again, it works pretty similar to context, so just make sure that you don't use this hook directly within the component that actually renders the form. It has to be a child component. Now, an asynchronous task within an action can take a while to actually return some data, or maybe users are on slower internet connections, anything could happen. And instead of showing a pending state, we might want to show the data as if the action has already completed, which we can do if we already know what the return data is going to be. And for this, we can use the new useOptimistic hook. So the function returned from the useOptimistic hook can be used within an action to update the UI before a transition completes. And it receives a state which gets returned initially whenever no action is pending, and also a function that we can then use to actually add that new optimistic state. So the first element of the returned array is the current state, which is either the initial state when no action is pending, or it's the returned value from the update function if an action is pending. And the second value is the actual update function, which we can use to actually invoke this function and set a new optimistic value. So for example, let's say that we have some messages that we receive from the server through the messages from server prop. Oops, sorry. No, I have to go back. So in the useOptimistic hook, we set the initial state to be the value of the messages from server prop. So this is the initial value of the first returned element, which in this case is called all messages. So then we map over all messages and then render this, which is just the initial messages from server. Now, when a user submits a message, the add message action is triggered. And inside the add message action, we first invoke the add optimistic message function with the value of the message that we just typed. And this triggers the update function of the useOptimistic hook, which then returns an array containing the current messages from the server along with this new optimistic message. So this now updates the value of all messages because a pending transition is ongoing. And because this now changed value, React will re-render and show the list of messages, including that optimistic message. And maybe to indicate to users that this is still like being sent, we can display some sending or pending text, stuff like that. Now we actually send the request, and after some time, the request succeeds, and this updates the messages from server prop. Now, since we use this value as the initial state, all messages now gets this updated value, which again causes a re-render, so now we actually have all the messages. But in the meantime, the user saw the optimistic message. So actions trigger transitions, which are asynchronous by default. But useOptimistic essentially opts out of that asynchronous behavior, so it's immediately reflected in the UI. Now, moving on to some server features, React 19 now also introduces React Server Components. So traditionally, we essentially had two ways to render our application. So we could either use client-side rendering, in which case the server-side React tree got rendered to a JavaScript bundle, and then we had some minimal HTML that both got shipped to the client, where then the client-side renderer uses this bundle to rebuild that React tree, or we could use server-side rendering, in which case the React tree got rendered to both HTML and a JavaScript bundle, still sent to the clients, and then this static HTML was made interactive through that bundle. Now, both approaches rely on the fact that the React renderer needed to rebuild that React tree client-side, even though it already had it on the server. So the introduction of the concurrent renderer in React 18 allowed for a different approach, namely React Server Components. So React Server Components allow React to send the actual serialized component tree to the client by using a special JSON-like format. And the client-side renderer understands this format and can just rebuild that tree client-side without the need for HTML or JavaScript. So React Server Components are never sent to the client, only their return value is in this JSON-like format. So this means that we get to use server-side functionality directly within our components, like accessing databases, the file system, and so on. And this is especially easy because in React 19, we can now use async await to render server components. And the RSC payload remains the same because that's just a representation of what is actually returned. Now, it can happen that this data lookup takes a while to complete. And in that case, the entire React tree needs to wait before it's sent to the client or before that data is completely fetched before it's sent to the client. So to fix this, we can wrap the server components in a suspense boundary. And this allows React to already stream the parts that were faster to the clients, and in the meantime, render that suspense fallback. Only once the data has been fetched and the RC payload has been generated will this component actually be sent to the client. Now, since React Server Components are only rendered on the server and then rendered to JSON without needing any JavaScript, we cannot use client-side functionality by default. And this includes things like hooks, event handlers, windows, and so on. So to render components client-side, we need to explicitly add them to the JavaScript bundle. And to tell bundlers that we want to add them to the bundle, including their imports, we can use the now stable useClient bundler directive. And adding this directive adds the components and its imports to the bundle that gets shipped client-side. So React won't render this component on the server. Instead, it takes the CSR, the client-side rendering approach here. So now, because we're actually shipping the component to the client and not just the return value, we cannot fetch data the same way that we could with server components. But there are a couple things we can do here. First, we can just fetch the data within a server component and then pass this data as props to the client component. Or we can use the new use API within a client component and pass the promise as a prop instead of the actual data. So use is a new API, not a hook, that accepts either a promise or a context. And it returns the data of the resolved promise in case we passed a promise, or the value of the context in case we passed a context. So in this case, we're creating the reactions promise within the server components. And instead of awaiting this value, we're just passing the actual promise down to the client. And on the client, we then pass this promise to the use API. So this API automatically integrates with suspense and error boundary. So while we're waiting for that promise to resolve on the client, we can show these suspenses fallback. And then once the promise resolves, the fallback is switched to the actual components, Or in the case the prom is rejected, the error boundary gets shown. Now, the benefit of using the use API directly on the client is that the rest of the server components can already be streamed to the clients without having to await that data. So the use API makes it incredibly easy to work with asynchronous data client-side, whereas previously you had to deal with API endpoints and setting loading and error states. React can now handle all of this for us, which really simplifies our code. Now, we can also use the use API with context, which essentially replaces the use context hook. So one big difference here, though, is that we can conditionally call it, because it's a hook, or it's an API, it's not a hook. So this means that we can call it after early returns, within conditions, and so on. So the use API gives us a lot more flexibility to use context based on any runtime condition. Now, in our server environment, we can also create a server action. And a server action is a function that runs server-side, but can be called client-side. And really, this is more of a framework feature, because it requires a framework to actually use it. But we can create a server component within a component by using the use server directive. So this can either be on top of a function's body that we then pass as a prop to the client component, or we can create an entire file dedicated to just server actions by adding the use server directive on top of that file, and then import the server action within the client component. Now, it's up to the framework to actually implement this endpoint, but whenever a server action is triggered, React will send the request to the server to execute this function. And we can track the state of this request by getting more information about the action status, for which we can use the use action state hook, use start transition, derive it from the use form status hook, and so on. So server actions make it incredibly easy to work with any server-side functionality within client components, because we no longer have to create those separate API endpoints. And they're especially useful in scenarios whenever we want to offload certain computations or any data manipulations to the server, which really reduces that load on the client. Now, moving on from these server and client features, some other improvements in React 19. So in React 19, we can now access ref as a prop for server components. So previously, to pass a ref to a server component directly, we had to use forward ref. But starting with React 19, function components now accept ref as a regular prop without the need for forward ref. So just this change makes React feel a lot closer to the platform, because we no longer have to import anything from React to actually make this work. And also, ref callbacks now allow a cleanup function. For example, to remove any event listeners, which is really great to prevent any memory leaks. React 19 had support for rendering document metadata text directly within components. So whenever React renders this component, it will see the title, link, and meta tags, and automatically hoist them to the head of the document. So whereas previously we had to use tools like React Helmet to handle this directly within components, we can now just use it natively in React. But for more custom meta tags, you might still want to use React Helmet. Now, React 19 also adds support for directly using style sheets in the component that actually uses these styles. So we can just directly add them to our components, and React will again hoist these to the head, which ensures that the browser will not render the components until the CSS has loaded. And we can also load a style sheet within a suspense boundary. So in this case, we're loading the button and the common CSS within the suspense boundary. And since the button CSS has a higher precedence, because that's high, React ensures that this style sheet will be loaded first. And when loading CSS styles in a suspense boundary, React will keep rendering the suspense fallback until the style sheet is inserted into the head and fully loaded. It'll only reveal the content once the CSS is completely loaded. So this prevents that that flash of unstyled content. Now, lastly, staying in the head components, React 19 also includes new APIs within React DOM for working with browser hints. So within our components, we can use APIs like preload, pre-init, prefetch DNS, and many more to use these browser hints. And browser hints can be really useful to fetch or connect to certain resources before they are discovered, which can really help to speed up certain loading times. And React handles the hoisting to the head, but also automatically reorders the browser hints based on their priority to early loading. So as developers, we don't have to worry about the orders performance implications. So this ensures that the most critical resources are made available as quickly as possible. Now, in the next talk, Sam Solikoff will show you how to use these new features by refactoring some existing React code with these new APIs. Thank you so much for coming to my talk, and have fun building with React 19.
Now, how many of y'all can appreciate the beauty of those slides? I'm gonna need a referral later, Lauren, on what you use to make those, because a brother has a talk coming up next month, so pro tip there. All right, cool, so let's gear up for our next speaker. Coming in from New York, this person is a big personality, both figuratively and physically speaking. Probably like 6'5" or so. He has a very smooth, slick vibe going on, and I hope that it comes off very much so in his talk, and that you guys get to enjoy it as well. Let's all give it up for Sam Sadikoff.
All right. So my name's Sam Selikoff, and this is my first React Conf, actually. It's been awesome so far. And my talk is called React Unpacked, a roadmap to React 19. But as you just saw, there's a ton of features in React 19. And since I only have 20 minutes, really, today to play, we are going to basically focus on actions. And also, because I'm the last talk before lunch here, I figured it would be more fun to just do some live coding. So we're going to take a look basically at what Andrew was talking about this morning and see how some of these new action APIs work. So this should be fun. Let's see here. OK. So is that big enough? Let's see, maybe one more. A little more space. OK, so this is the demo that we are looking at. Pretty simple app right here on the right. We have a little debug toolbar down here with kind of the server-side state. So we have a value for how much stock the t-shirt has. We have a description right here. And I can expand some details for the shirt. And if I go ahead and refresh, I reset the cart down to 0. I can click Add to Cart. We see some pending UI right here, and then we get a refresh. And I can refresh this down here. And if we make this down to 0 and I click Add to Cart, we get a refresh, and we see an error because we can't add anything else to the cart. So pretty simple UI, and right now this is built all with client-side, typical React 18 APIs. Nothing fancy going on here. I have a little use query hook. It's probably similar to data fetching hooks you all have used. It gives us the data right here. If we don't have it, we render an initial spinner on load. And then we show the details. We have a little form right here. And then we have a submit handler right here. So handle add to cart, just a little event handler. It's going to prevent default. It sets some pending state to true. That's what renders this spinner. And it makes an API request here to add to cart. So these are just hitting API routes. Same with this one right here. And once that comes back, if the JSON is OK, we go ahead and call revalidate. That's bound to our query, so that's why this cart updates when we click this. And if it's not, if there was an error, we set some React state called error, and that's what shows this. Once we're down to 0, we hit add to cart, and we see our little error. So pretty standard stuff. We've probably all written a lot of React code that looks like this, and I want to talk about some of the things in React 19 that address some of the issues with this code. So there are some issues with this code. What do you think I should do to highlight, to reveal those issues? Any ideas? What should I do to break my app? How would you break my app? Let's just try pressing the button a couple of times. That's usually how you break most React apps, right? OK, that's pretty strange. Let's look at that again. I'm going to go ahead and refresh. I'm going to add two items to the stock right here. And let's press it twice. 1, 2. OK, so it goes from 6, and then the pending indicator goes away, and then it shows 7. So we have a little bit of a race condition in our event handler. Once the first submission goes through, this line gets called, and it flips the pending indicator false. But there's another one going out, and it calls revalidate, which causes that update. So if we go up to 2 here, and I press this 3 times, 1, 2, 3, we're going to see a similar kind of race condition-like behavior here. So historically, this kind of async behavior, these async submissions, event handlers, React hasn't really had anything as part of its first-class APIs to help us sort these sort of race conditions out. And this is exactly where actions come in. So the first API we want to look at here is start transition. And you may have heard of start transition because it's been in React for a while. We can take this handle add to cart, and let's bring in start transition from React. So I'm going to wrap this whole thing in start transition. Now, we have a problem here, and that's we have these awaits. This is an async event handler. And again, if you've used start transition because it's been in React for about a year, you may not know what to do here, but React 19 is introducing async support for transition. So we can actually pass in an async function to start transition, and this creates an action. This is what an action is. And so if I save this, let's come back, add to the stock here, and see how the behavior changed. I'm going to click this once, and let's just see what happens. OK, so we get from 9 to 10. We lost the pending indicator, but it seemed to work. Let's add 2 and click this 1, 2, 3 times. So we don't see any pending indicators, but we also dropped the stale updates to the UI. So our UI didn't update for any of those kind of stale updates. The app waited for all of the async transitions to settle before making an update. So right away, it's a huge win. We didn't have to really change anything about this logic here. This kind of goes back to what Josh and Joe were talking about in the keynote about how this is really a coordinating local updates with asynchronous functions. This is a great way to do it, and we really didn't have to change much at all. But how do we get that pending indicator back? Because that would be nice to have right here, and we don't have it anymore. Well, if we click add to cart, we're not seeing it. And it's kind of weird, right? We're calling set is pending right here in our function, and we still are rendering from this state. So why aren't we seeing this in our UI? Well, anything that is inside of start transition is a low priority update. You might hear it called low priority or non-urgent. And the whole idea with transitions is it's kind of like a bomb shelter where React can kind of make all these updates in the background without blocking the current UI, still keeping it responsive, and wait until all of those actions settle before it applies updates to the UI. So that's great for things like this revalidate function or our error, right? Because those come in all at once. But this pending state, that's not very useful to us. When we click on this, set is pending to true is being called in the background, but we want it to actually apply to our current UI. So what we can do is bring in another new hook called use transition. And this hook is going to give us 2 return values, a Boolean and a start transition function. So we get the is pending right here, and we also get start transition like this. So now we don't need to import start transition from React anymore, and we don't need our own is pending state. So we can delete this whole thing right here, and we can also delete this, and we can delete this. So now if we refresh, add 1 to the stock, let's click it once. We got our pending flag back, pretty cool. Let's go ahead and add 2 and click this 1, 2, 3 times. And now we don't have any of those race conditions at all. We get a single update, again, once all actions settle. Very cool stuff. So these actions are solving a lot of these kinds of problems for us. I kind of think of it like use effect lets us put a lot of this imperative logic inside of these declarative boundaries. And transitions are kind of letting us do the same thing for asynchronous functions. So let's talk about this start transition function right here. This is pretty cool. We like the behavior that we're seeing. Does this mean we have to wrap all of our event handlers everywhere and start transition all over our app? Well, this is where the action function comes in on the form element. And Andrew talked about this as well. So instead of just using an event handler, handle add to cart, Maybe handle submit is the generic version of this. We're going to change this to the action prop. And actions don't get the event like this, so we don't need this. And we don't need to call prevent default right there. So that's kind of the first benefit. Actions on a form already know we're submitting a form. They're going to prevent the default for us. They're going to do some other cool stuff like progressive enhancement, like Andrew talked about. But that's kind of one little cleanup right there. And then secondly, we want to go ahead and rename this from handle add to cart to add to cart action. And this is just a convention. It doesn't actually have any behavior, but this is a nice convention for passing functions to the action prop. And in the future, UI libraries, things like Radix, might expose action props on their calendar components. And so things like that would be good to, this is the kind of convention that the React team has set for us here. So we have an action. We're still calling start transition. Let's refresh this. Let's add one to the stock and click add to cart. Looks like everything's still good. Nothing's really changed. 1, 2, 3, everything's still working. But let's go ahead and delete start transition. So I'm going to delete start transition. And now we're just back to a good old async function. Let's refresh this. And now if I click add to cart, well, it works. We've lost our pending state because we're no longer using our own start transition. But if we go ahead and add 2 to the stock right here and click this 1, 2, 3 times, we are going to see the same batching behavior. We get a single update once all actions settle. So this is kind of the way we use actions on the form element. And so we don't have to call start transition everywhere in our app. But now that we're not using this use transition hook, which can be nice if you're not using a form or you just want access to the pending state. How do we get that pending state back? Well, there's actually a couple ways. If I delete that and we go ahead and organize our imports, get rid of things that we're not using here. The first way, if you remember, Lydia mentioned the use form status hook. And that gives us the status of any pending actions that are being submitted on a parent form. And you can think of it, the form is kind of like the context provider, so we need to make something as a child here in order to use that. So pending, let's just make, actually let's just make this called pending. And this is like, it's kind of useful for design systems. It makes it easy to share these around different forms. We'll talk about a second way to use it, which I think is going to be more common, but I just want to show this. So pending, let's say, takes in children, which is a React node. And it's going to use form status, right? So status returns an object. And we can destructure this and see what's inside. We're going to see has all this cool stuff about the last submission, including its pending. So if we're pending, then let's go ahead and return children. And now when we click this, we'll render our children if the form is pending, and it goes away if not. So we can just stick our spinner right back in here, just like that. And now you could drop this in any form that has an action. Again, it's really nice that React now speaks the language of async transitions. It's really like, I think of actions kind of like first-class promises that React understands. And so any form that takes an action that's coming from anywhere will trigger this pending component. So this is a nice little pattern you can see for getting our pending indicator back. So if we add 2 again, we're going to see the same behavior, 1, 2, 3. The pending indicator stays there the whole time. The UI only updates once all the actions are settled. But let's look at the second way, which is not going to be this pending component. It's actually going to be use action state. So use action state is another new hook. And ignore the import right here. This is just a local one because these are React Canary-driven conference demos. But it all works exactly the same. It's just a little local version. And how does use action state work? Well, just like use state, use action state gives us some state, and it gives us an updater function, right? Use state gives us a state and an updater. Use action state gives us a state and an updater. The updater, in this case, is the action, right? It's the actual action that we're going to pass to our form, but it's the function that updates the state. So that's how to think about the signature of these hooks. And the third thing it gives us is pending. So how do we actually use action state? Well, we just pass in an async function, and we just move all this stuff right up here. And let's go ahead and call this action add to cart action. We're just going to rename this. Just like use state, we can name this whatever we want. So we're still passing it in right here. All we've done is use the return value of use action state. And now, if we use is pending to show our spinner, we should get back to where we had at the beginning. So is pending. Let's add some to our stock. 1, 2, 3. Pretty cool. Back in business. So I think use action state, and there's the update. I think use action state is going to probably be a pretty common way that you will get a hold of the action within, like your main routes and your main page components. Use the is pending state for some feedback in the current UI. But what about this state right here? We haven't used this argument yet. What is the state value from this hook? Well, this is actually whatever our action returns. It's the return value from the last submission of this action. So if you hover this over right now, you see it's void because we don't return anything. It kind of is easiest to see if you just return something here and you look. This is going to be a string. And on the first render, if we just log this and I just pop open this console right here, the first render is actually undefined because what is the last return value of your action submission when you first load the page? Well, it hasn't been submitted yet, so it's undefined. And that's actually what this second argument is for right here to use action state. So you could say ABC right here, right, DEF. So when you first load this, you get that initial value. But for our case, undefined is just fine. And then once we actually submit this, we see undefined. Once we submit this, we see that return value. So what would we want to use this return value for? Well, this return value is useful for anything you want to use from your action that you want to use in the current UI. And what are we doing with this error right here? Exactly that, right? We're seeing if we have an error from our action, let's go ahead and set that state in React and show it right here, that it's out of stock. So this seems like a perfect use case for state. So instead of setting the error right here and right here, let's just return this. And that way, this state variable is just going to be an error. And if it's null, it means our action didn't return anything or it wasn't run yet, and so we don't have an error. But if it does exist, it means we're in this branch of our action, and so we want to show that error. So let's get rid of this state right here. Get rid of that. And down here, we're still rendering error and this little p tag in red in case we don't have a stock, in case we have an error. So let's try it out. There we go. Let's add one. And it clears. So pretty cool. Everything's working just as before, but we don't even have use state anymore, kind of like Ryan was saying, State is still very important to React. It's still the state setting that is making this all work, that is allowing React to kind of update our app in the background. React State is powering all of this, but from our perspective, we don't really have to use a lot of this stuff. And I think this is pretty cool. If we actually just come here and take a look at the diff and what we have, let's see. Maybe I can just close that for a second so we can get this full screen. This is what we started with over here on the left. We had our own state managing for the error and the pending state. We had an async function handler for handling the submit event where we had to prevent the default. We flipped the pending to true. We waited some stuff. We flipped it back to false. We saw that gave us some race conditions. And over here, we just bring in use action state. Our business logic right here is very similar. It's kind of the same. You can kind of squint and see that's really the important stuff. That's the meat of what our application's doing. But we've delegated the error handling, the pending, and the action behavior, again, with some added benefits like progressive enhancement, the hydration stuff that Andrew was talking about, just by switching this from on submit to action. And not only is this the refactor, and the code, I think, reads a lot better, it's actually, it performs better. It doesn't have those race conditions that we saw in the beginning. So that's pretty awesome. And again, just like Andrew said, actions were first introduced kind of in the React ecosystem through server actions and server component frameworks like Next, but everything we just saw is all client actions. So we're all in client land. That means all of these features are useful for any React app out there. They work for any React app. So that's pretty awesome. Cool. So this is kind of like a nice recreation of our initial UI using use action state. And we have a little kind of pessimistic UI right here, right? We don't show any updates. We show the user something's happening, and then we re-render once everything's happened. What if we wanted to show an optimistic update? Well, there's another hook called use optimistic. And this is a really cool hook. I really like this one. So what is use optimistic? It's kind of like use state again, so it kind of gives us the same two things, except it's going to be derived from some server props, some other props, but usually from some server props. So let's pass in the initial value of data, and this is going to give us optimistic data and set optimistic data, so just like use state. And let's start by grabbing optimistic data, and right here where we're rendering the items, let's save this, and we're going to see that everything is basically the same. So that's pretty cool. Nothing really changed. Well, what's the point? Well, the point is, if we come here to our form, and we go ahead and invoke this, we can use this set optimistic function to update the data that it represents in the client while any actions are pending. So let's just actually call set optimistic data. And what are we going to do here? Well, data is this object that we get back from our cart, has a bunch of properties. Let's just copy those properties over. And what do we want to do when we actually click this if we wanted to make an optimistic UI? Right? When we click this, if we're assuming that the submission is going to go through, we think the cart's going to go up by 1, right? And right here, we're rendering optimistic data.items. So let's just say that the new optimistic items is d.items plus 1. So let's refresh this. And when I click, look at that, 34. Let's add some more. 35, 36, 37. So this is basically giving us a portal into the current UI. It's letting us make changes. But once all the actions settle, anything we've done, any calls we've made to set optimistic data get thrown away. They get discarded. And we revert back to the original server data that's passed in right here. And this is really cool because check this out. If I go back to toStock and I click this 1, 2, 3 times, we're going to see optimistically we're showing 40, but once all of those finish, we go back down to 39. And this is another point that Andrew made, which is the traditional form action model, where you kind of just submit a form and then you refresh from the server. There's something that's forgiving about it. It's very forgiving because if you make a mistake, you're just going to regenerate your UI at the end of the day. And so you don't have to worry about things that you manage on the client disagreeing with the server-side data. And this is basically the design of optimistic. Once all the actions settle, all of these optimistic updates are discarded. They're completely thrown away. And so that means that your app is guaranteed to render exactly the same whether or not you're using optimistic. It's a really neat property of use optimistic, that once your app is in a settled state, it renders exactly the same as if you didn't use it. And it's actually, that property is also true of suspense. When you have suspense boundaries, they render their fallbacks when your app is in a pending or loading state. But once your app is settled, an app with suspense and an app where you just comment out all those suspense boundaries will look exactly the same. So it's a nice forgiving model, and I think it's a really cool hook. So those are the client hooks. Again, we haven't even talked about server actions or server components, but the cool thing is that all of these work with server actions and server components. So I'm here next, and I have a client component. If I just made this, let's just make this a server component. Let's see what this change would look like. I'm just going to comment out all of this client stuff. And this is the last little demo here. And here we see kind of the skeleton of the UI. Now I'm in a server component, so I want to make a query directly. I don't want to make an API query. Let's look at this API cart route, and we see it's just doing this. So let's just kind of inline this right here. This cart has an ID and it has an items, or it's null. So if there's no cart, let's just not found this, just so we can make sure we have a cart down here. And let's bring back our cart's items. So there we go, refreshing the app. We don't have a loading state anymore because we always have the data, since the server components block on fetching the data. Pretty cool. And how do we get, so we don't need this. What about this action right here? Add to cart action. Let's bring this back to kind of how we had it before. We have an add to cart action. We can't use action state, so we don't need that. Let's undo this. And let's just go back to function. This is an async function. Add to cart action. But we are in a server component now, so we can't pass functions directly to client components unless we make them a server action. So let's actually just mark this with useServer. And again, we don't want to make a fetch call. Let's just pop open add to cart, the route right here. And it looks like it's just calling this add to cart function, so we'll just replace this like that. We'll go ahead and import this. And that's going to be the JSON response. So if we're OK, well, we don't know what to do to revalidate yet. But let's see if this works. I'm going to add something to my stock, press this. We're not seeing an update. That makes sense because we didn't revalidate. But if I refresh, we do see it worked. How do we revalidate in next? Here we call something called revalidate path. This is one way to do it. So let's just add that right there. Go ahead and organize our imports, clean that up, refresh. Now when I click add to cart, eventually we see an update. But we don't have any of the feedback, the pending state. Let's see, or the error. Let's see if we have no stock left. Whoops. If we have no stock and I hit add to cart, nothing happens. We don't see any feedback, but of course there was an error. And so at this point, you could make a client component and basically do everything we just did. But you can also get a little creative with your client components, the interfaces they expose. And I'm just going to import a form component right here from components/form. And let's see. Oh, as form. From, thank you. It's lunchtime. So I'm going to switch form with form.root. Okay. And I have a form.pending that we can use to render the spinner. Let's import this again, because I just commented that out. And now we get our pending indicator back. And what if we go down and we have an error? We don't see that, but I also have a form. Before we were rendering this with state. We don't have state because we're in a server component, but I can just actually, change this to form.error. And I'm not going to render the error in here. I'm just doing that kind of inside of this component. But there's the error. And so now I can refresh. I can add 2 to the stock, press this 1, 2, 3 times. We're going to see exactly the same behavior as before. We only get a single update. We get the error, we get the pending state, but now we're in kind of server component land. And this is a server component with a server action. It's powering this entire UI. Pretty cool stuff, I think. I love seeing that React now speaks this language of actions. It works on client React. It works in server React. Actually, this form action doesn't even know whether you're passing it in a client action or a server action. I think that's pretty awesome. And basically, just like suspense decoupled the loading state from our code and decoupled it and basically delegated it to React so that we could write more composable loading states. Error boundaries did the same thing for error handling. It decoupled the error handling from our code so that it could compose in the React tree. Actions do exactly the same thing for our pending states And if we look in this form code, components form, we're just going to see all the stuff that we just saw. We're just using action state here. So again, this coordination problem, we just ask React for the action state. It's going to tell us here whether it's pending or not. Here's the last state. Actions let us decouple and compose our code while being able to delegate the is pending state up to React, just like suspense and error boundaries did for loading and error states. So I'm pretty excited to see how actions kind of percolate through the ecosystem. I think they're going to unlock a lot of unexpected ways that different libraries will work together. You know, when hooks first came out, I mean, use effects and use state, I mean, they were cool, they're fun to write, but these days, we really don't write a lot of use effects ourselves because it's all tucked inside a library code. And it really opened up quite unexpected ways for different libraries to work together. You know, when use effect came out, I didn't know I'd be able to use Spring from Framer Motion to animate a dialogue from Radix that was created with a portal. And I think in the same way, these actions, now that React speaks this language, is going to open up a ton of cool stuff and a ton of novel ways that libraries and components will be able to work together in very unexpected ways. So I'm pretty excited for that, and that's my talk. Thank you so much.
Laptop?
Oh, take my computer.
That was fun. All right, let's do a clapping exercise. Ooh, clap with me one time, 2 times, 3 times. All right, everybody's active, tuned in. That was in perfect sync, actually, I was actually surprised I got it on first time. But yeah, so we learned sac passé and ma boule. There's another sort of call and response that happens in Haitian culture. And this one tends to occur more in the provinces. It's usually the caller would initiate with honneur, which means honor. And the person that hears that responds with respect, or respect. So we'll do it in English. So say honor. Awesome. And that's kind of a way, instead of saying hello, we use that to kind of like enter a safe space or a territory. All right, our next speaker is coming in from Brooklyn and also representing Singapore. So with Asian Heritage Month, I want y'all to give a really, 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 really strong and loving welcome. Let's give it up for Lauren Tan.
Thank you. Green.
Yeah, it's green.
Oh. Hello, everyone. I guess I am the final boss before lunch, so we'll try and make this good. So hello, I'm Lauren. I'm an engineer on the React team, and I work on the compiler. And before we start, to keep things a little fun, I have a small request. So I hope y'all can, fulfill my request. And my slides went away again. So my small request is, I have a bottle of water here, and it's really important to stay hydrated. So I'd really appreciate if every time I take a sip of water, y'all could give me a clap. Should we try it? While they fix the slides, yeah. So thank you for that. I think I might be a little thirsty during this demo and talk. Should we give a round of applause as well for the staff for helping us? Okay, there you go. All right, so let's get started. So earlier today, you heard from Joe that we open sourced the React compiler as an experimental release. And you saw Mofe and Sathya tell you about how it works and how it performs at Meta on large and really heavily optimized apps like Instagram.com. So rolling out to Meta apps took us weeks and months, but we only have 30 minutes together today, and we're all hungry. So I want to show you how you can adopt the compiler with very little effort. So we're going to look at what it's like to add the compiler to your app, what it feels like to write new code of it, and build some intuition for what the compiler does. So to do that, let's add the compiler to a real open source app, Blue Sky. Now, if you're not familiar with Blue Sky, it's a decentralized alternative to Twitter, and it's built with React. And I asked someone who works there, and Blue Sky already has a pretty good amount of manual memoization already. So I'm not expecting that we make it way faster, but I think we can make it much easier to maintain performance and write better React along the way. So let's get started. All right. So I already have Blue Sky running in 2 tabs in my browser. So on the left, you can see that the compiler is enabled with the green circle emoji. And on the right, the compiler is disabled with the red circle emoji. I also have the app open in my iOS simulator. So the first thing I want to highlight about the compiler is that it works on all platforms. So Blue Sky is an Expo app. And if you've never used that before, Expo is a really great way to build a React app that works on all platforms. And that's really nice because when I set up the compiler here today, it's just going to work on all these platforms. So that's really cool. But to make the demo easier, I'll just use the web version. OK, so the first thing we want to do is to install the compiler. And as you saw earlier in the keynote, starting today, we can install the compiler from npm and update our Babel config to add the compiler. And I've already installed the plugin using npm install Babel plugin React compiler, and I've also added it to our Babel config. So let me show you what that looks like. So as you can see, it's not a lot of code. And don't worry about writing this or even reading this. We have a lot of detailed instructions in our docs on how to get the compiler set up. And I'm going to link to that later. So now that the compiler is installed and we have Babel set up, the second thing we need to do is run our app and confirm that the compiler is running and optimizing our app. So as I mentioned, I already have Blue Sky running. If you can see compiler left, not compiler on the right. So I want to just click around a little bit on the compiler version and just double check that it all works. So just jump around. Maybe even write a tweet. A post, sorry, not a tweet. I love use Memo. Cool, that works. Very nice. So it looks like the app still works. But one thing we found through rolling out the compiler at Meta is that for debugging purposes, it can be really useful to tell if the compiler is enabled or not. But obviously, you don't want to add an emoji to your app. So one way that we recommend is to actually look at the React DevTools. Uh-oh. There you go. So the first thing you'll see in the React DevTools is there's a whole bunch of these blue sparkly badges. And that tells you that the compiler has automatically memoized this component. And that's really great. And let's just double check on the right that we don't have any badges. There you go. So yeah, on the right, we have the compiler is actually disabled. All right, great. So we've installed the compiler. We have added it to our Babel pipeline. We've confirmed that it works through the DevTools. And then we did a quick check to confirm that the app still works. But how do we know that it actually did something or anything? Did it actually optimize, or did it just skip over stuff? So one way you can do this is, to open your console, look at the sources tab, and the stable source maps, and look through the compiled code and try to see what would happen. But that's really annoying to do. So let's go back to our editor and see if we can learn just a little something about what the compiler is doing to optimize our app. So to do that, I'm going to look through the lens of a component called the post controls component. So that's this row of buttons at the bottom of each post, so you can reply to a post, repost a post, and also like a post. So let's go take a look at that. Post controls. OK. So to better understand what the compiler is doing, I hacked on a little a small IDE extension just for this demo. And this isn't the official VS Code extension for the compiler, but it's just something to help me show you what the compiler is doing better. But actually, through building this, it's given us some new ideas on like what an official VS Code experience could look like, so that's pretty cool. So let's take a look and see what the compiler has done to optimize this component. So there's a whole bunch of code on the right, so don't feel like you need to read it all. But this essentially shows you what the compiler has compiled. So one way to tell if a component or hook was optimized by the compiler is to look for this little $sign variable up top. And don't worry about how to use this. It's not meant to be used directly. It's really just for the compiler. So one way you can think about this is it's just a big array of values that the compiler can use to cache and retrieve values efficiently. We can also see, if I scroll down a little bit on the left, that the compiler, as much as possible, preserves the original code as it was written. So like when you're debugging, you can look through this and it looks familiar. But it does do optimization, so it's just a little bit harder to read. There's like a whole bunch of like $signs everywhere, and there's like these like kind of hard to read if conditions. So that's okay, because there's a better way to understand it. So I'm going to close this panel real quick and do that. So I added another view to my little bootleg IDE extension to just help me see at a glance what the compiler is doing. So the first thing you'll see is like there is this sparkly emoji next to the component name. And just like the React DevTools, this tells you this component has been auto-memoized by the React compiler. We also have these dep labels, which is short for dependency. And that means that this value is a dependency of some other value. So that means that when these dependencies change, the output values that require these dependencies will also update. And then if I scroll down a little bit more, you'll also see, where is it? This RTV reactive label. And that tells you that this value depends on one of those, or one or more of those dependencies that we just saw earlier in the code. So I want to take a look at this variable a little bit, just so we can dive a little bit deeper here. So if I hover over this value, you can see that the compiler says it's reactive, or it depends on theme.palette.default.postControl, which makes sense, right? Because again, this is the post controls component, which is the row of buttons at the bottom of each post. We want to make sure that depending on the theme that we have chosen or selected, that the correct colors are used. The default control color is also a dependency, which is pretty interesting. And that's because it's used later on in the JSX to determine the correct colors for the buttons. But here's something also interesting. This variable and value has been already manually memoized with React.useMemo. But the really interesting part is here in the dependency array, because originally we wrote this as just depending on the theme object. But the compiler says it's not the theme object, it's theme.palette.default.postControl. So let's look at the JS output again, just so we can understand what's going on. So let me scroll down and find this. That's over here. So the first thing you can see is the compiler has removed the manual memoization. You don't see use memo here at all. And if you look at the if condition, this check over here, you can see that it lines up with the what this value depends on. So this condition tells you what this block of memoization depends on. And as I mentioned, it's different from what we've specified in the manual memoization, because the compiler has figured out that we can just depend on the property changing and not the entire theme object changing, which you can imagine might just change a little bit more frequently. So this is a really small example, but it shows you that the compiler has memoized this more granularly than we often do by hand. And the same will go for the rest of the component. The compiler will figure out exactly what needs to be memoized and what they need to depend on. So the second key thing to remember about the compiler is that it can granularly memoize much more efficiently than we can. Computers, it turns out, are way better at this type of granular tracking and optimization that we are. OK, so now we have a little bit of an idea what the compiler is doing. We know that it looks through our code. It figures out what the dependencies are. And then it memoizes values such that they only change when the dependencies that actually affect it change. So now I want to take a look at what it feels like to add new code with the compiler. So let me turn everything off. So the feature I want to add is going to be on this post controls component, which is, as a reminder again, is like this row of buttons here. So let me back to my profile. So sometimes, when I when I look at my timeline and I see something that someone posted that I just disagree with, like this post right here, I secretly want to dislike that post. So I kind of want to add that feature as a local-only thing, so I can dislike posts in private without anyone else knowing. Just to feel something in my cold, dead heart. So let's add a dislike button to the post controls. All right, so let's go down to the JSX. So there's a lot of JSX here, but this is essentially a big block of code for the like button. So what I want to do is just add the dislike button right next to it. So I've already prepared something here. And remember to save. So if you've never seen this before, the view component is from React Native Web, and that allows this code to run on both web and mobile. And if we click on the dislike button, it doesn't return anything right now, so we have to implement it. So first of all, I already have some theme variables prepared, just so it looks good. So let me just paste those in. And just like the post controls, this just makes sure that depending on the theme that's chosen, we use the correct colors. We also need to return some JSX. And again, this looks like a lot of code, but really it's a button that wraps an icon, a thumbs down icon, and some text that shows you the dislike count. So it looks like a lot, but this is really good because it has a lot of good stuff like accessibility. And the compiler can just handle all of this, right? Even though it looks complicated. So the first thing we got to think about is, all right, we want to dislike post, so how do we do that? So we know that we need some state, right, to increment whenever we click on this button. So let's just add that. And then we'll initialize it to 0. So we have a dislike count and a set dislike count. So on our onPress handler, we'll just set the dislike count to be whatever the count is plus 1. And then we'll save and go back to our browser, refresh. And we can see, hooray, now we can dislike this post. I love use Memo. This person is so wrong. OK, so we can see that this works. And cool, are we done? No. You see, now that I've added it, I don't really like it. You see, the thing that I dislike more than posts like this is unnecessary rendering. It keeps me up at night every time a button re-renders, right? I'm raging inside. Anybody else hate unnecessary rendering? So what I want to do is I want to make this dislike count automatically go up whenever the button re-renders. But I also still want to be able to click on it just to, express my anger. So let's build this. Thank you, thank you. All right. Wow, this talk is going so well. So, OK, to do this, I'm going to need to delete the use state, of course, because we don't just want the number to go up only on clicking the button. We want it to go up every time the button re-renders. So to do this, I need to break some rules of React here. So don't try this at home. OK, so what did I do? So I added a ref to hold on to a number. And every time the component renders, we'll increment that number by 1. And then we just set the dislike count to whatever the number is. And this is pretty sketchy because it breaks one of the rules of React, which is to not read and write to refs during render, because it breaks the expectation that this component is a pure component. Now, some of you eagle-eyed developers may have noticed that when I added this code, we got a little red underline underneath our code. So here we have an example of a lint provided by the compiler. And it says, ref values to current property may not be accessed during render. But the compiler doesn't just warn us. It can also detect that we're doing something sketchy and then safely skip over this component and continue optimizing everything else. So let me take a look at the compile output again, just to show you what happens. So I just enabled both of the features, like the visualization feature and the output. And so just to confirm, you can see that we no longer have the const $ variable, which means the compiler isn't optimizing this component and it's left it untouched. And similarly, on the left, we no longer have our little sparkly emoji. So that kind of sucks, right? Like, this component was being optimized before, but now it's not. But that's OK, because even though the compiler assumes that you follow the rules of React to optimize your components, you can also tell when you've broken the rules and then just skip over it safely. So let's just keep moving on and ignore this red line for now. Let me turn this off. So let me hit save. And we still need to fix our onPress handler because I just deleted the set dislike count. So what I want to do is whenever I click on the button, I just want to make it re-render. So to do that, we can add another use state. Oh, this tooltip is so big. And that should make it re-render. OK, let's go back and check on our progress. All right, cool. So now you can see that the dislike button starts at 1 this time, which, as expected, we increment the number when it renders, so it obviously starts at 1 when the page loaded. But now let's see what happens to this dislike count as we navigate around the non-compiled version. So I'm just going to jump around, go here, go there. Taking a while. So as you can see, it's kind of going up slowly. OK, well, yeah, it went up. So you can see that the compiler, or sorry, the application is re-rendering this button every time we kind of like navigate around, which is really not nice, and we just don't like this. So I also want to show you what happens when I click on the like button. So if you can see this, let me zoom in. Well, let me click on this a bunch. Call stack. That's no good. But you can see every time I click on the like button, the dislike count actually goes up by 3 times per like. So we really dislike this post. This is a terrible post. But I want to show you what happens in the compiler version. So let's just navigate around as well. I'll also click the like button. And yeah, awesome, right? So now some of you might be wondering, like, wait, didn't the compiler just not optimize this like button? So how come this is still 1? So remember that we broke a rule of React, right, in the dislike button, and so that we saw in the output that the compiler is no longer optimizing it. So the reason this is still optimized is because the post controls component, which is the parent of the dislike button, is still being optimized. And the compiler is adding the equivalent of React.memo around all of the children of the post controls component. So even though this component isn't being optimized, we still get a lot of the benefits from using the compiler, which is really great. But if I go back to my editor and, what do we do about this red line? Because, like, I don't know about you, but every time I see a squiggly red line underneath my code, I feel so compelled to fix it. And I can't, this is like, catnip. I'm like, ooh, a red line. And it's true, it can be really tempting to try and fix all of these rules of React violations that the ESLint rule detects. But as you also saw in the app, it's not strictly necessary to rush into fixing these if there are no bugs. Because again, the compiler can detect many cases of such violations and then just safely skip over it while continuing to optimize other components. And so if I turn back the memo visualization, just to confirm, right, we don't have the sparkly badge. So if we want to, we can come back and fix this later, right? But for the sake of the demo, let's just say that we've already done that, and we're now coming back to fix this. So what can we do? So one thing we can do is to extract this code. So if I just delete this, you'll see that our sparkly badge immediately came back because the compiler saw that this code is no longer sketchy. So let's just add that back as a new hook. We'll call it useRenderCount unsafe. You can also call it useRenderCount do not use or you'll be fired, I guess, if you like that. So let's just add that back. And you can see that our red lines are back. But this time, it's just around the useRenderCount unsafe hook and not on my dislike button. And then let's just update this to use that new hook. And as you can see, we are still optimized. So hooray, we've made some progress, and we've helped the compiler compile a little bit more of our application. So that's really awesome. But how do we know that the compiler is memoizing correctly, right? Like, how do we know it's just not holding on to the number 1 or 2 and then just caching that forever? So let me just refresh both tabs real quick to reset all the counts. So first, let's click on the like button here. And you can see that the dislike count doesn't go up. And so remember that the onPress handler for this button doesn't modify the count directly. It just triggers a re-render. So that means that the button is still correctly depending on the dislike count that comes from my sketchy hook. Let's also change the theme from light to dark. And you can see before I do that, that the count is currently 1. So let's change the theme from light. And I'm sorry, it's going to be really bright. Cover your eyes. OK, we're good. All right. So you can see the count went up to 2, and the thumbs down icon is the correct color. It flipped. So that means that the dislike count, or sorry, the icon is still reactive, and it still depends on the theme changing, and it does it correctly. Very cool. So let me switch it back to dark, and then you'll see that go back to 3 as well. All right, cool. So we verified that the compiler has memoized this correctly for us, and it only re-renders for the things that actually affect it. And we did that without writing any memo ourselves, which is really, really nice. But oh, by the way, if you remember, we still have our iOS simulator running. And it is not correct. I think my iOS simulator got disconnected. But anyway, the point is, because Blue Sky is an Expo app, and it runs on all platforms, the work that we just did will work on all of these platforms for free, which is really nice because I'm a pretty lazy developer. OK, so let's go back to our slides. All right, so I think you can see now that the compiler really helps React move closer to its vision of great developer experience that's easy to build and enables great user experience. And the compiler works on all platforms, on all modern React apps. So what we did earlier works on both the web and on mobile. And the compiler can also memoize far more effectively than we can do by hand, while also keeping that memoization resilient to code changes. If your code base follows the rules of React, adopting the compiler could be pretty straightforward. And as you saw, I didn't need to rewrite anything. There's no new APIs, because the compiler understands plain JavaScript and React. So let's recap. We just dropped in the compiler to all of Blue Sky without having to rewrite anything. And if you look at the PR to enable the compiler, it's a few lines of config and installing some packages. And we added a new feature to express our hate for this re-rendering without worrying about memo at all. So that seems kind of easy. I promise I didn't script the drinking. OK, so it's easy because Blue Sky's code base follows the rules of React. But if you have a code base that doesn't, it might be a little bit more difficult and require debugging. And the rules that I'm referencing are the rules which some of you are probably quite familiar with. But it's OK if you're not, because you can check out the link above, and you can find out more about these React rules. These rules don't just help you write better React, but they also help you create a safe space for the compiler to optimize. And it's really important to follow them if you want a better quality application, but it also makes it easier to adopt the compiler as well. And as we also saw in the demo, the compiler also ships with an ESLint plugin. So that surfaces the compiler's diagnostics right inside of your editor, which is really nice. Because it's the first time we've been able to show rule of React errors in your code. The current React ESLint rules only show you the rule of hooks, which is only a subset of our rules. As part of the release, we're also including a health check script, which will give you a little sense of how much effort it'll take to adopt the compiler. It's not perfect, of course, but it can give you some signal into whether this might take a few days or a few weeks of effort. So some of you might also be wondering, how exactly does the compiler just work out of the box on any React app? How do we trust it? You don't need to know the theory behind the compiler to use it, but I think it's important to build an intuition for what it's doing. So let's build this intuition by first looking at how we do memoization today. So in today's React, when a component state changes, React is going to re-render that component and all of its children. And this sounds like a lot. In practice, React is usually fast enough that most of the times it's fine to just re-render. But of course, we all know that there are many occasions as well where re-renders can really hurt performance. So you don't have to understand all of this, but let's take a look at an example and see what the compiler figures out automatically. So first, there's a couple of values that don't have any dependencies. These are static, so they never need to be recalculated. Then we also have values that depend on the online count here, which is a value that comes from the hook in the first line. And here's something interesting. A value that's cached can also become a dependency of another value. Third, we can also have values that depends on the friends prop. And finally, the overall view of JSX that gets returned can also depend on values that are themselves reactive values. But forget all of those boxes, right? It's kind of confusing. So let's just look at the original code again. This is a really simple example, but it's such a pure description of what your UI looks like. So one way to think about the compiler is that it's an auto-reactivity compiler. React is too reactive sometimes because when you change anything, everything changes. But the compiler now automatically adds just the right amount of reactivity, and it makes updates fast by default. So in React, you describe your UI using plain JavaScript values, and the compiler automatically takes care of reactivity and performance for you. So you can forget about reactivity, and what you're left with is just React. Yay. All right. Another case where you may also need memoization today is if you have expensive calculations. So for example, let's say that you, for whatever reason, need to synchronously process a really large amount of data on the client. And running this function takes a long time, so you don't want to run this repeatedly on every render. So it's really important to memoize this. The compiler also handles this, since you can see that this expensive calculation was used during rendering. And when you combine it with optimizing for re-rendering, this is where a really large part of the compiler's performance benefits come from. One thing to note with this example, though, the compiler doesn't memoize everything. It only memoizes React components and hooks. So I mentioned earlier that the compiler understands the rules of React, so ordinary functions which don't abide by those rules are out of scope for the compiler and should be memoized outside of React if they are expensive. So when you combine these two optimizations, automatically figuring out dependencies and reactivity to skip re-rendering, and memoizing expensive calculations during rendering, The React compiler gets us closer to React's vision, where you continue to work with plain JavaScript values that stay at just the right level of reactivity, making it easy to build great user experiences that start up fast and have responsive interactions. If you're interested in gaining a deeper understanding into the many different kinds of optimizations that we do in the compiler, please definitely check out Mofe and Sathia's deep dive tomorrow. It's going to be awesome. But our time together is coming to an end, so here's a slide that you can all tweet. So please check out our docs on the compiler, and I hope you have a really good time trying it out. I have one more slide. One more slide, sorry. While we wait for the slide to come back. So I also want to announce that we're launching a compiler working group. So we'd like to invite teams to join the working group to provide feedback so we can help you roll out the compiler. And obviously, we cannot help everyone at the same time. So please get in touch through the link above, and we'll reach out when we're ready to help. My name is Lauren. You've all been great. Thanks so much for listening, and enjoy lunch and React Conf. Thank you.
React Conf 2024 can be beat.
I do have one. Thanks again, Lauren. There's one announcement. We're going to pick back the afternoon sessions at 2 p.m. Pacific time. But other than that, bon appetit. Thank you.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components and have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components and have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components and have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components and have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system. And with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components and have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components and have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components and have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
I use Freestyle Libre to manage my type 1 diabetes, and it's important to me to use a product I trust. It's especially rewarding knowing that I have a hand in improving it for myself and others. My work is personal with global impact. We are engineers focused on understanding our customer needs and prioritizing user experience through innovative technology.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components and have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components and have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components and have reactivity and responsive UIs, but since it's executing on the server, you talk talk to the database, access the file system. And with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Which channel is it? And then it's gonna be. How's the delay? Which MX Plus is it? Turn it on. Now you wanna hit the post. There you go. Good. Check, check, check. Check, 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 check.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components and have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
specials. Everyone, please take your seats. The sessions are about to resume.
Whatever it is you do for fun.
Ass on the mic, bringing the heat. React Conf 2024 can be beat. Travel beats, don't it, feel the vibe. Get ready to go, let's come alive.
Welcome back, welcome back. All right, we're continuing these sessions. As folks start to percolate back in, I'm gonna share a really fun little story. And this is kind of like maybe, I guess, also doubling as the intro for our next speaker. So, React 2019. I was in your seat. This was my first single track conference. And being on Twitter, all you interface with people on avatars. So, this is my first conference where I actually meet folks that I engaged with on Twitter, which had me very excited. So, one day, well, actually not even one day, during lunchtime, I break, and I start chatting and engaging with that folks, vibing out, having an absolute blast. Then from the corner of my eye, I saw someone that kind of looked like someone that was on my Twitter profile. So I just bolt to him and say, hey, does anyone told you that you kind of look like Dan Abramov? Snapped a selfie with him, and then just bolted. I left Dan poorly. It was a poor thing. He was like very exhausted, and like that interaction had him so confused. For context, on my end, his OG Twitter profile was him with glasses, and he was without glasses. So, bear me some grace. But anyways, without further ado, let's give a huge warm welcome to our next speaker, Dan Abramov.
Hi. Hi. One sec. I need to figure out the bottle situation. Okay. Hi. Excited to be here. My name is Dan Abramov. I work as a software engineer at Blue Sky. We're building composable, open source social media. So check it out if you're into that kind of thing. But my talk is not about Blue Sky. My talk is about React, and it's called React for Two Computers. The first thing you should know about this talk is that this is a talk. Sure. It wasn't supposed to be a talk, so I thought that this would be a blog post. And I tried to write this blog post maybe like 13 times. I have a bunch of drafts that I never published. And I just couldn't quite figure out how to do it. And I realized later that it's just because this is just a different format. And actually, it makes more sense as a talk. So how is a talk different from a blog post? Well, a talk is a performance. So I'm standing here, I'm in front of you, I'm speaking things, doing things. I might mess it up. I'm a little bit nervous. But it's some kind of like live action. And there are things you can do in a performance that are hard to do in writing. But a talk is not just a performance. A talk is also a story. So I wrote some kind of a story, and I came here with this story, and so this is the thing that I'm presenting. So you could say that in a way, this talk is kind of like a collaboration between two people. So there's me, who's presenting right now here at the stage, given this performance, but there's also the past me who has written this talk and the story for it. And me and the past me, we're never in the same room. You know, like we're kind of separated by time and space. Like the past me is somewhere in London, trying to figure out like what to write about, and the present me is here. But there is a kind of communication between the past me and the present me. So the past me has written a certain script for this talk, and the present me is using the script to kind of finish the performance, and then the talk is not ready until both of the stages are done. Sure. So this kind of relationship between past me and me, it's kind of similar to, there are like other kind of patterns of human relationships that follow the same structure. So one similar relationship is between the scriptwriter and the cast of actors. So you know, if like the scriptwriter is working on a like a TV show or a movie, or you know, like a playwright for theater, like they write a play, and then that is the first phase of the process. But then the play isn't really played until the actors actually embody you know, the story and like bring it to life and then connect to the audience. So it's kind of like a two-step process where the author and the actors communicate in kind of in one direction through text or some kind of a script. So this pattern exists in human relationships, but it also exists in computer relationships, if that is a concept. So the pattern I want to talk about today is like the relationship between the server and the client. And there are different kinds of, you know, servers and clients. People mean very different things by it. So I just mean server and client as not even necessarily machines, more like computer programs in kind of context of like traditional web development request-response model. So the client requests some page from the server, and then the server responds with, you know, something that the other computer should execute. So some kind of HTML and maybe some scripts within this HTML. And maybe if you think like of the word script a bit more metaphorically, like HTML is also kind of a script, right? Like it's like a programming language for what the computer should display. So the whole thing is kind of like a script. And so I want to dig into this a little bit, into this relationship. And so I've prepared a little example. So as everyone knows, the naming of cats is a difficult matter. So sometimes you need an app for that. So I built a little app, you know, in case you need to name your cat, you just press. It already picks, you know, it already picked the name for me, so I just press reveal, and I see, yeah, this is the name that is chosen for my cat. And the way this works is that there's an array, kind of hard-coded array of cat names, and I pick a random index from that array, and I take that cat name and display it in the document body. And so this is fine, but sometimes I don't really want to hard code, like let's say I don't want to hard code the list of cat names right here, because I want to have some kind of flexibility. So I want to be able to maybe fetch it from the database or read it from a file system, maybe ask ChatGPT. I don't know, like I want to have some kind of flexibility not to hard code the data that my application needs directly in my application. And so the way I would usually solve this is pretty traditionally, I would, you know, I would have some kind of an API. So I'm going to do like await fetch. I've already prepared an API called cat names. And I'm going to get the JSON from that API. And I'm going to read the cat names from that JSON. And so let's see what happens. I'm going to refresh the page. Oh, I see there's an error. It says await is only valid in async functions. So yeah, I need to make this function asynchronous. So let's refresh again and press reveal, and it works. Yay! I didn't break anything. That's a milestone. So yeah, this works. Ship it. I can go now. But there is a little bit of a problem that I actually changed the behavior quite a little bit here, because now if I load the page, and let's say that my connection goes slow, so I'm gonna throttle it, and then I press reveal, it's not instantaneous anymore. Like, it takes some time to load because the data doesn't exist at the time the user interface is rendered. Like, now I have to go get it from the API and wait for the response. And so maybe if I load the page and then my connection goes out, it will not appear at all. And in some cases, this is actually fine. In a lot of cases, this is fine because, for example, like if you click a link or you navigate to another tab, you kind of expect that, well, we're going to the server, like we're navigating, so we need to, fetch some information. So you expect some kind of a delay. Or if you're mutating some data, so like if you're saving settings or submitting a post or liking a picture or whatever, like you kind of expect, well, it's normal for these kinds of things to take time. But then we also want to have this kind of control over our user interfaces where we want to be able to say this particular interaction has to be synchronous. Like, I want the data to already be there with that screen. I don't want to wait for it to kind of come later. Like, I want to be able to ensure low latency for specific interactions. So how do we fix this? Any ideas? So it's kind of like not obvious how to approach this problem if you look from the client-centric perspective, because, well, this is all I got, right? I have this fetch call, have to await it. There's not much I can do there. So maybe one thing we can do is we can look at the server code. So this is my server. You can see there is an NPI endpoint that I created that reads from a file. This is my list of cat names, and just returns the JSON. But if I keep scrolling down, there's something interesting here. So there is a script tag here that says, here's the client code for this page, which points to this code. And just to kind of make it more visually obvious what is really happening in our program and how our program is really structured, I'm just going to copy and paste this. So I'm going to put the code of this client code inline into the script. So that's not necessarily like the best way to write production code, and there are more kind of efficient ways to do this. But for illustrative purposes, I think it really helps kind of explain what's going on in the code. And let's just refresh to verify that, yeah, the code still works. And so previously, I was looking at the server code and the client code as kind of two separate programs that talk to each other. They kind of pass messages to each other or like request stuff from each other. But now I'm kind of looking at it from a different perspective. So I kind of look at it as a single program that spans two different devices, that spans two different computers. It's like a program that's evaluated kind of in two steps. And now that I start looking at this code this way, I start spotting some like optimization opportunities and just opportunities to simplify it that I wouldn't have noticed otherwise. For example, again, we want to make this function synchronous. We want to make the click handler synchronous. So I'm going to remove this async, but I have these awaits, right? Like I gotta put them somewhere. Well, in React, there's like this thing you sometimes do, which is called lifting state up, where you put the state into a parent component and then you pass it down. What if we could lift data up, and instead of lifting it to a parent component, we lift it up to a parent computer. So we'll lift it up to the server. So I'm going to just copy and paste this from here. I'm going to put it here. Interesting, it also became colorful. It was all green before. This, this like green font just like reminds me of the, the Matrix movie, where you can just like see, like when you're inside, you think this is the real world, but actually like no, like this is the real world. You're on the server. OK, so let's see if this worked. Bam, it doesn't work. Well, it doesn't work because I need to, now that this fetch is happening on the server, I need to actually specify what the host is, because it can't guess it, I guess. And so if I press reveal again, it doesn't work, because it says reference error, JSON is not defined. So if we look here on the page, of course, I'm using this JSON variable, but it's actually defined here. And if this was a regular kind of nested function, that would just work, right? Like that's just a closure. But what we're trying to do here is more like a closure over the network. That's weird. How do we make this work? Well, one way we could do this is, what is the purpose of JSON? Like that's the stuff that you can send over the network. So this is a program that sends another program as a piece of text, as a string. So we can turn this JSON into a string in order to send it together with our program. So I'm going to call json.stringify. Yay, it works. And notice something interesting now is I load the page and I press reveal, and there is no network request. And the reason there's no network request is because, well, the data is already there. It's already on the page. So this is kind of an interesting way to think about client and server, and I'm just going to continue down this rabbit hole and see where it leads me. So the other thing I'm noticing is, OK, like when we hit the server and we want to serve this page, and the first thing that happens is that we call the API, but where does that happen? Well, we hit the same server that serves this API, it returns to JSON, and it returns it like this. And I'm like, do I really need an API for this? Like maybe in some cases, but probably not in this case, because I only have one usage. So I'm just going to paste this code here, and I'm going to delete this API handler. Let's verify that it still works. And you could say maybe, what about abstraction? Like, what about separation of concerns? But I can always, like, if I don't want to have this code in line here, I could always pull it into another file. I could put it into a module. I could give it a name. The API was not really enforcing separation of concerns or anything like this. So we still have tools to do this, and we can still extract this thing if we really want to do that. All right. I forgot what I'm supposed to do next. All right. So there's another thing we'll notice if we look at the response. So what's happening right now is that the list of cat names is inlined in JSON, but it's actually pretty long. But now that we have like a whole picture of what's really happening, including both the server and the client side, we also kind of see the relationship between like how the data flows from the API into the component, into the client code, and how it's being used there. So I noticed that the cat names from here flows here, and then I select a random one from them. And I really only need one of them, so it doesn't make sense to send all of them. So maybe I'll just take these lines, and I'll actually move them up, and I'll extract them. I'll put them here. So this is something I can do ahead of time on this computer. And I can pass the cat name instead through JSON. And so now if I refresh the page and I press reveal, it still works. But if I look at the data inlined on the page, it is only data for this one single thing. And so I want to kind of like take, I've done a bunch of changes to this file. I kind of turned it inside out a little bit. And so I want to take a look at the result. Like, what is the shape of this thing? And you could say it's pretty messy. Like, I think like that's one possible reaction is, oh, this looks like some code I wrote in like 2003 with like PHP and interpolating strings and just like passing things, kind of like a mad scientist. But if you're kind of functionally brained, like maybe you'll think of this as, oh, this is kind of like partial application over the network. There's this concept of applying a function in like several steps. And this is kind of like this, except that there's also like a network step in between, which is kind of interesting. But I think the main way I kind of look at this is that we've removed all the boundaries that are inessential to the problem. You know, we've removed all the boundaries that we can remove, and the boundaries we're left with are just dictated by the laws of physics. So this code executes first, like it has to execute on this computer, and then it emits this code that will have to be sent to another computer, and it will execute later. And then we can pass some data together with this code. So that is really the fundamental shape of the problem, no matter like which library you're using, which approach you're using. It's going to kind of look like this, like when you strip it down. So there are these like two different worlds. Like this code executes in one world, and this code executes in another world. And what I like about this is that there is a very clear separation of how the data flows through the application. But of course, I wouldn't actually want to write code like this way for two reasons. So one reason I wouldn't want to write it this way is just because I don't want to be writing code inside of a string. Like that doesn't make sense. I want to have like syntax highlighting. I want to have modules. I want to have type checking. So this is not really, you know, something that I would like use in production. And the other problem with this code is it's probably going to get very complex very fast. So if I keep layering on more features, even if I want to display this button multiple times, I will have to add a bunch of stuff here. I will have to add a bunch of stuff there. And I would have to somehow like connect them together. So wouldn't it be nice if we had some way to split, you know, like a function into other functions and like give them names that correspond to product features? Wouldn't it be nice if we had like a concept for this so that we wouldn't have to have this like single big function? So of course we have this concept, it's components. So maybe we can take a look at how you know, code like this could look like in the component world. So we're just going to pluck some pieces out of it and see how it shapes up. So the first thing you do with the component is you give it a name. So I'm going to call this one cat name generator, because that's what it does. It's going to be, I need to export that, and it's going to be an async function. And I'm going to need this read file thing. And I don't need this URL part, so like I'm really kind of zooming in on like this particular part. So I won't need the body tag. Like I just want this kind of focus on the logic of cat name generator. And so it's pretty clear that I'm going to need all of these pieces. So I'm going to copy and paste this. And then I'm supposed to do something with them, but I'm not sure what yet. So I'll wait a little bit. And then let's have a look. What do we have here? So there's a bunch of HTML stuff that like seems kind of irrelevant. But then this reveal button, like that is definitely a part of you know, what I want to render. And it has a click handler, and this click handler depends on some information actually. And one thing I want to do here is, so this information, this JSON, it's already known by the time any of this code in this inner world executes. So I can kind of pluck it out, and I can just put it here, because it doesn't matter. It's like available on load. And now that I kind of look at this, like I see here's like the input to this code, and it kind of looks like a React component with props. So I'm just going to put this as a prop here, and I'm going to copy and paste this event handler. Let's see, and I'm going to copy and paste this button. So this will be a button. This is JSX, it's not HTML, so I'm going to need to change the syntax a little bit. And I'm going to need to give this thing a name. So here it doesn't have a name. I'll just call it reveal button. And there's my button. So the next logical thing that I want to do is I just want to pass, you know, I need to pass information from the thing in the outside to the thing in the inside. So I think it's natural to kind of think of this as, well, I just want to render a reveal button with cat name. So is that all, or did we forget something? I think we forgot something. What about all this green stuff? Like there's something there, right? Like there's some kind of a hard boundary that is dictated by the laws of physics. That is, these really are two completely separate worlds. Like this code could execute much, it could execute on a different computer, it could execute much earlier, and just like, the past me who prepared this talk and the present me who's given this talk cannot be in the same room at the same time. These two components cannot be in the same file. It breaks the laws of physics. So what do we do? One thing I'm going to do is I'm just going to embrace the fact that these are really two different programs in a way. These are two programs that execute in separate environments at different points in time. I really shouldn't think of them as a single thing, which sounds contradictory to what I was saying before, but there is some kind of a hard boundary between them. And so if I think of, these are completely separate programs, so like this program executes on the server, and if it imports something, then that will also be there, and then this is the stuff that executes in the browser. If it imports something, it will be there. Well, how do I pass information between them? So how do I pass information here? Like here, I kind of enter a string. There's like a place where I go from one world into another, and I can carry something with me. I can carry some data with me as I do that. And so what if there was a way to say, yeah, these are two separate programs, but you can open a door between them, and this door only works in one direction. It lets you pass things from the past into the future, and only things that can be turned into text or JSON or serialized can pass through them. So let's add a door. So this is the door. This is the green stuff. Like in Matrix, like when you're outside, you look at these green screens and you don't understand what's going on. But then when you're inside the Matrix, you kind of like, it's just like everything looks normal. So we've just entered the Matrix. So yeah, let's verify that this actually works. So I'm using Next.js here, but this example would work in any framework that supports React Server components. And I have the reveal button here. I press it, I see the result. And again, let's verify that it actually works like we expect. So I refresh the page, I press reveal. There is no extra network request because all the server part, it has already executed. And if we look at the HTML, there's a bunch of stuff here, but somewhere here there are props with the cat name. So this is the stuff that gets passed through the door. And so why would we want to do this? Well, one reason is that now that we think in components, we can do all the things that we can do with components. So we can nest them, we can render multiple of them, and each of those components can have these kind of points of handoff where we can pass information from one environment into another. So I'm not going to show that, but there will be plenty of talks today that kind of focus on these ideas, so do check them out. And I really want to just go back here for a moment and kind of just like recap what's going on. So we're used to thinking about the client and the server as two separate programs, but we can also think of like rendering a web page or rendering a UI as a single program that's split between two computers. And when we look at kind of vanilla JS representation, the way this works is that this part executes in the server world, and then it emits a program that will execute in the client world. And there is kind of like a hole through which we can pass information, but only things that are kind of can serialize to JSON can pass through that hole. And so the program is complete after both of these phases have run. And so if we look here in the React version, again, we have the server, we have the part that lives in this world, and it can prepare a bunch of data. And then it can choose, there is a door here. So not every module would have a door, but if there is a door, this module is kind of saying, I can accept props from the server. I can accept props not just from above, but from capital letter above. Like I can accept props from the past, from another computer. It's like an information wormhole. And like this is kind of the second stage of this program. Like this is a program with 2 stages. One thing that's kind of interesting here is that actually for practical reasons, on the server you want to run both stages because you want to generate the initial HTML. So you run this stage with the initial state, and then that gives you HTML. But then on the client, you might want to, this is the part that can update and re-render in response to state changes. So you kind of think of this as like, this is a program for 2 computers, and this is the first step, and this is how it says, this is what you're going to do next. And this is, this is the code, and this is the data that this code needs without going back to the server so that it's available immediately. And this is really the door through which it passes, the door that allows to pass this kind of information. And so I have worked on this talk, and so that was the first phase of the process. And now I have given this talk, and this is the second phase of the process. And now the computation is complete. Thank you.
You, Dan. Don't you just absolutely love the storytelling?
Good luck.
The storytelling talk that was introed by story of the storyteller. Nice, I absolutely love that. I'm gonna do a little exercise if anyone can help participate with me. Can you stand, everyone stand up? Yeah. Only because I didn't do it before coming on, and I kind of want you to do it together with y'all. Just like kind of like rest and rotate, like loosen up, reach up, down, get nice and comfy. Oh. All right, cool. Another thing I want to do is just say hi to your neighbor. Yeah. Oh yeah. Now, you guys officially don't have an excuse to not talk to each other in the hallways. So, you're welcome. I noticed there were some people standing in the back, so if we could probably start moving and get closer to the stage and maybe pack up a little bit. That way, folks that are looking for some available seats can kind of slot in, if it's possible. So if you have a seat near you, let's just scooch in a little bit, and then I think for those of you in the back, have fun. All righty. Once you're good, feel free to have a seat. Enjoy. All righty. So, have you ever encountered a meme that kind of didn't need words, but said so much at the same time? I have no where that I'm going with this. It's just that right now, the ja keeps popping, and I'm trying to find a meme that I can just start splashing that onto it every single time. While are we good? Oh. Looks like we're finally getting finished set up. We had a interesting shift in the schedule, but yeah, I'm actually really excited. Our next speaker, you probably might have heard, depending on what podcast you subscribe to, was a Lego Grandmaster. Has anyone here a fan of Legos? At least at what time did it get exposed to? I didn't get exposed to Legos till maybe around middle school, which was an interesting thing for me, because then I found out that they weren't a single size once my niece got born, and that they came with jumbo size. But, so that was an interesting little culture shock for me. Here's Evan Bacon, who I'm really looking forward to it. I'm low key. If it looks like I'm at loss of words, it's because this is like one of my favorite Twitter profile to kind of follow. So I'm a little fan shock, but I'm really excited. Thank you so much for sharing the vibe and the love. And Evan, please take it away.
Yeah, awesome. All right. So when React Native was announced at the first React Conf nearly 10 years ago, it had a very simple premise, which was web the good parts. And from this basic concept, React Native has grown to become the most impactful framework for building client-side applications. Fast forward to now, and React Native powers hundreds of the most used apps in the App Store trending list every single day. And there's no signs of slowing down. So where do we go from here? Well, I'm Evan Bacon, an engineer and the creator of Expo Router. It's the first file-based router for building React apps that run on both web and native platforms. By simply creating files in the app directory, Expo Router instantly creates robust navigation for both your native app and website. It uses familiar web APIs such as link and href to move between routes. And it's also a nested routing system, enabling you to organize routes into folders to establish shared UI like tab bars and headers. And it uses native primitives like UI navigation controller on Apple devices to ensure transitions feel truly native to the platform. We actually built the React Conf app with Expo Router, and it feels pretty native. Now, there are many aspects to app development, and Expo Router provides universal solutions to most of them. But all these solutions are primarily targeted at client-side apps. And there's only so much that you can do with the client on its own, as we just saw from Dan's fantastic talk. Things get really interesting when you bring in data fetching and server rendering. From a data perspective, most native apps operate essentially like a single-page website, performing all data fetching and rendering on the client. This means slower performance and substantially less networking. Popular native apps, such as Lyft and Netflix and Reddit, many others, use some form of server-driven UI in their native apps. But it's very complicated to configure, and as a result, out of reach for most developers. Now, they do this so they can A/B test and render UIs with high degrees of variation based on all sorts of criteria, such as user type, location, currency, etc. And the approaches all vary in many small ways, but they do share some common architecture, such as JSON as static UI representation. You can think of this as basically the HTML for a custom native application. And we can see a pattern here. The pattern is that server-driven UI is an important feature for building apps, and it's not very accessible for indie developers. So what if we can make server-driven UI available to everyone, but also the most powerful version of it ever imagined? And that's the goal of Expo Router. Now, to do this, we're bringing React server components, the most cutting-edge approach to server rendering, to all platforms through Expo Router. This is a huge undertaking because it will require many refinements across the universal ecosystem, across lots of libraries. Our official implementation of universal RSC is currently in early development, but I think it's worth sharing an update on the progress we made so far because it's pretty awesome. And it's actually pretty inspiring to see what this stuff is capable of. So there's a lot to RSC, such as server actions, concurrent routing, flights, payloads, etc. But I just figure it would be easier to show you guys a demo of what's possible. Now, I've been really interested in AI apps lately, but it's historically been pretty hard to build high-powered AI native apps. This is because streaming and server rendering are both critical aspects of working with an LLM. Now, with React server components in Expo Router, it's actually really easy to work with AI. So here, I have a ChatGPT-like app which pings OpenAI via React Server Action and streams down native text from the server. Everything that's returned back is at least partially server rendered. So we can ask it, should native apps be server rendered? And see what the result is. It'll stream back something like native apps are typically not server rendered, because this is cutting edge stuff here. Now the UI consists of a scroll view with some messages and a text input, which pings our server action. Now to create the server action, we have another file which defines use server in a function. This function will be extracted out of the bundle and then turned into an endpoint on the client. We can render React Native text here instead of a recursive async function using suspense to keep the stream open. Now, one novel aspect of our server system here is that it's multi-platform. So when you make a request or it receives a request from an iOS device, then it renders the iOS version of the server or the Android or the web version of the server. And that's how it knows to render React Native text from iOS or React Native text from React Native Web. So complex bundler magic. Now, let's see. When the client makes a request, an RSC payload is sent back with suspense to keep the stream open. It has the static representation of our root JSX loaded inside of it, a URL to the client code needed for this RSC to load, and then the currently rendered text element. As the stream progresses, more content will be rendered, and React will update the tree with new visuals. And finally, the stream will complete, React will close the connection, and we'll have our mounted element. And this is just one part of a much larger puzzle, but it's super powerful because it means that we can send any arbitrary JavaScript so long as the native bindings are already on our target device. Notice there's no native code being sent here. It's all just JavaScript, which coordinates with code that you ship to the App Store. Think of the native side of this like a browser or a custom browser, which can have custom native views in it. And yeah, this is all just the basics, but it scales up pretty nicely. So we can use this to render any native UI. So let's do something a little bit more exciting. When React Native was first demoed, they showed a truly native movies app. So I thought it could be fun to pull movies into this prototype somehow. For inspiration, I looked at what the state-of-the-art best AI apps had to offer. So first, in ChatGPT 4, when you ask for movies, it renders a bullet list of Markdown. It's got like some links inside of it, and there's some bold text. It's neat. I also tried with 4.0, and same deal, but a bit faster. On Gemini, it does the same, a little bit faster, and this time with some inlined images. But again, this is all just Markdown streaming down and rendering in a Markdown renderer. With RSC, we can do a lot better. So here, we can match any query to search for movies, ping the movie database, and server render an interactive native movies card with images and UI menus and animations and blurs, all from the iOS system settings. We can search for more actors. We can send that back to the device. And we can even integrate with native APIs, such as the Calendar API, render down a calendar card, create calendar events without having to sign into anything or create a database. Feels truly native to the device, and frankly, just incredible. So overall, a way better user experience and a lot less reading. But even more exciting than this cutting-edge user experience is the developer experience, because it only took slightly more code than the text example from earlier. Here, we use a suspense boundary to render our skeleton loader, and then we fetch our movies inside of an async function, and we stream them down to the client. All the secrets, everything that we use to fetch, all of it secured off of the native device. That might not sound too impressive to web developers, but for native development, that's pretty hard. I look at a lot of native apps, and I see a lot of secrets in production. And to make the cards interactive, we simply create a wrapper client component, which has a bit of state inside of it. The JS logic here will be split out of the main bundle and fetched conditionally when the server renders the UI. And then it's also rendered down to Hermes bytecode. So you can think of this like a script tag being injected on the web, except if the web could render bytecode and render it instantly when it gets it. Meaning we're essentially delivering the best strategies from the best web-only frameworks, but running in a custom JavaScript environment that pushes the platform to its absolute limits. Because after we jump through all of the hoops that are required to get server rendering working, we aren't just rendering to the DOM. Now, these are truly native views. We have the Xcode inspector attached here. Everything is fully native. It means you have smooth scrolling, high performance, all the platform behaviors that you would expect. It's progressively rendered, best practices, and truly limitless. But the best part has to be, hands down, that it runs everywhere. So Expo supports iOS, Android, web, Mac OS devices with M chip. I have this app running on every device inside of my house, on my Vision Pro. It's fantastic. It actually does make the Vision Pro pretty useful because they don't have a Spotify app. So I can show animations and pre-recordings all day, but I think it would be pretty sweet if I just show you guys the actual demo running on my actual phone right now. So we will give that a shot. I've got my Cybertruck shirt on in case anything goes wrong. Let's open up QuickTime here, swap over to, oh, there it is. All right, so this is my phone. Yeah, well, yeah, thank you. Got the Expo AI app here, so we can open it up, and this is an end-to-end React Native app running server components. This is the, like, as far as I know, the first server-rendered React Native app. And let's go ahead and hit List New Movies. And we got our trending movies here. We can scroll through them, look pretty good. We can long press to see the casting crew. One thing you'll notice is actually, when I do that long press, there's going to be a little loading indicator. What that is a server action fetching more data and rendering down more UI menu elements, and then pulling them in. So we can search for an actor, just like we did before. We could maybe select a movie, create an event. Create an event will stream down a calendar card. We could schedule the event. I don't actually need to schedule an event for this, but we can do a lot more than just what I showed earlier. So I love the idea of mixing the server with native querying events. So here we could look up something like, what's Charlie's phone number? And now it's going to stream down a contact card, which can request contact permission and then show me everyone named Charlie on my phone. So here we could select Charlie Cheever. It sends that back up to the AI model. We could say send a message. It will stream down a message sending card right there. We can come in here. It's text input. We can, modify it up a little bit. We can hit other or whatever. Like you can send message. If I send the message, it will actually open my messages to Charlie, who's my boss. So we will hold off on that one for now. And you can. Oh, here, this one's pretty sweet. Okay, so I just had this the other day. We can do, show me some things to do on the Vegas Strip. We're here in Vegas. Now it's going to render down, whoa. I think the computer just fell asleep. Wow, that was anticlimactic. It will render down a native Apple Maps view after pinging Google Maps. And then we can just slide through all of the locations here. And again, this is server rendered. The client, the map view is a client component, but all of the data gets fetched in the server, and then this carousel that we see here, fully server rendered. And you just can create these magical experiences with this, which feel incredible, really pushing server components to their limit. We can select this location. We could get the weather for here. We can see the weather. It's pretty hot. It's also European friendly. We can change that to Celsius with a native switch component. We could even book an Uber here. Grab the Uber, request an Uber. And now it's going to order us an Uber over to the Luxor. So much server rendering is possible here because it's not just that it's possible, it's also easy to do. So we're able to just continually throw more and more at it. I mean, it's a magical experience. I love this. So now we're going to go ahead and So let's see, swap back over here. We're on my, and we've got the dev server running here as well. I mean, we could just start the dev server and hit the W key, open it on web. Because if we can run it on native, we can run it on web as well. Say get the weather. I think it's still coded to Austin. It's using like Cloudflare IP. Same deal. We could say, what's the square root of 4 or something? See, 4 is 2. So it can still type out text. We can even open it here on the desktop. We got the desktop version of it running. Show me some new movies. And now it's going to render and stream down movies, running on all platforms universally. Server components are pretty powerful. So let's swap back over here. And by the way, it's pretty sweet that that just worked. First try. Yep. So that's what it looks like when we take the modern state of server rendering and AI and bring them universally to every single platform, seamlessly gliding between server and client in a fully typed file-based framework. We only have to configure APIs for a single platform, which is the server, and it works better than ever before to build things that work across different platforms. Waterfalls and parallel requests are all handled for us automatically, because this isn't just some random server rendering system I stood up for native. This is React server components running on native. It's like the best that there is right now. Static client code is automatically removed from the bundle. We SSG the RSC, we put it inside, that's a lot of acronyms, we put it inside the iPhone. If I were to load that in airplane mode, it opens up instantly because it has anything that fails is tied to a network request in offline mode. So it still feels like a native app when we use it. The secrets are all secured on the server. We're using Hermes Bike. There's just tons and tons of new benefits, too many to get into. And it really just redefines what's possible on our mobile devices and enables new types of apps to be built in record amount of time. So I'm extremely excited about this. Now, everything that I just showed you, that app, is an Expo SDK 51 app. So that's out today with React 19 and new architecture. The parts that are still work in progress are going to be the concurrent router, the server actions, the server render part. And we move fast, we can have that out later this year. So we'll have maybe all the pieces, or maybe sometime next year, I don't know. So consider this an RFC. Is server rendering something that you want to see on native? I believe so. I love using this. There's just never been a developer experience quite like this before in native development. It feels like web development in the most important ways. Like the most important pieces are written once and shared across platforms. So I'm a huge fan. And of course, I'm always looking for people, talented engineers for my team. So if you're interested in ushering in the future of app development, reach out on Twitter. I'm at Bacon Bricks. I'm Evan Bacon, and this has been Universal Server Components and Expo Router. And thanks.
Eyes on the mic, bringing the heat. React Conf 2024 MVP. Travel, stop it, feel the vibe. Get ready to go, let's come alive.
Wow. Okay, there's been an amazing back-to-back lineup of just live demos. And it just gets better and better, Bacon. Oh my goodness. This is amazing. All right, so we're gonna take a small break. Feel free, get refreshments, hydrate, and get ready for the next series. I'll see y'all in a couple minutes.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components that have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Okay. 1, 2.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components and have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
I use Freestyle Libre to manage my type 1 diabetes, and it's important to me to use a product I trust. It's especially rewarding knowing that I have a hand in improving it for myself and others. My work is personal with global impact. We are engineers focused on understanding our customer needs and prioritizing user experience through innovative technology.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components and have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Holy cow, Redwood supports RSC now. What's RSC? React Server Components. Everything's rendered on the server and HTML sent down to the client. Isn't that how the whole internet worked before React? No, this is different. Is it though? You're still writing components and have reactivity and responsive UIs, but since it's executing on the server, you talk to the database, access the file system, and with Redwood, all that stuff's built in. You get loading states, error states, all bundled up together in a single component. Huh, that sounds not horrible. Wait until you hear about the hosting platform that the Redwood team is building.
Everyone, please gather around and take your seats, for the session is about to resume.
Can be beat. Travel beats, don't feel the vibe. Get ready to go, let's come alive.
All right. Hope you guys enjoyed the snacks. We're gonna travel into a whole nother dimension. Is anyone here a fan of anime? Yeah, okay, I'm familiar. So there's this whole genre called the isekai. Well, unfortunately, it starts off with, you get hit by a bus and you wake up in another universe. But let's skip that bus part, and we're gonna go to imagine the Lord of the Rings arena, right? So we have this dragon to slay, and I eventually become your wizard. We have 4 champions. This is my very failed attempt at doing a British accent. We have 4 champions that we need to go to battle with. And I decided to equip with my lightning spell. We're gonna hit that dragon with the lightning bolt, lightning bolt, lightning bolts, and lightning bolts. Anyways, I just really wanted to do that. There's no real point about that. But we're welcome to our lightning talk section. See what I did there? And we're gonna welcome our first speaker. The only thing I could probably say is when asked what his favorite emoji was, it was the party balloon, which is very on brand, but also his vibe is, very wholesome, but party on the backside as well. So let's give a huge welcome to Sunil Pai.
Hi folks, super happy to be here. I'm jet lagged. I just lost my AirPods, but I'm still super excited. Don't worry, we're going to get through this. So I'm going to be talking about real-time React server components. I used to be on the React core team. No one talks about that. I made a CSS and JS library. We don't talk about that anymore. I worked in a bank. We just never talk about that. But for the past couple of years, I've been obsessing over this idea of stateful serverless for building real-time multiplayer applications. I made a company called PartyKit. I just love the logo on that, by the way. It looks way better than any other tech company. Where we explored building interactive drawing boards and text editors and stuff like that. Recently, I just got acquired back by my older company, Cloudflare, so I get to work in big tech again, so that's cool. But let's start. What does a server look like? Not like a literal server. How do you write code for a server? A very popular model is now pretty much 95% of code, right? It doesn't matter which your provider is. You basically write a function that takes a request and sends a response. This is the serverless model for writing servers. And it's super popular. It's nice because you upload it to your provider. They put it on machines all across the planet. And anytime a user makes a request, it finds the machine closest to them and responds to, it responds to it. And you can put whatever code you want inside this function. You can talk to a database. You can talk to third-party APIs, LLMs, do auth, sessions, all of that. But there's a specific problem with this model that I'm not a fan of, which is that it breaks our assumptions about the language itself, about JavaScript or TypeScript. Let me explain what I mean. Imagine you want to build a hit counter because it's, 1998 and you need to put it on your blog. How would you write a serverless function for this? Ostensibly, because you know JavaScript, you would say, hey, let counter equals 0, and anytime a request is made, increment it and send it back in the response. You're even going to test this locally, and it works just great. Every time you refresh the browser, it increments, and you push it out there, and it never works. It always returns 0. Why is this? It's because serverless are the goldfish of servers. All your state gets wiped out instantly as soon as it spins up a response. It like spins up like a little process, returns your response, and goes back to, and it just dies. And it does this for every request. It's quite annoying. Because then the workaround is, OK, fine, we need to use a database or a key value store or Redis. And you end up building this hodgepodge stack for something that should have just been a JavaScript variable. And that's annoying. So the question remains, what if our servers were stateful? Some slightly older folks, myself included, will remind you that this is just how we used to write servers before serverless. We used to actually have live node processes and used to run supervisors to keep them awake. But what does it look like in the serverless model? So Cloudflare, conveniently my employer, in 2020, they announced something called durable objects, which is a new approach to stateful services. And the name is super exotic, but the idea is extremely simple, which is that for a given ID, and we'll talk about these IDs in a second, you should be able to write a class that has a method on request that responds to requests. And for a given ID, it spins up an instance of this process, and it keeps it alive. So this code, with a little bit of an API change, actually does work right now. So what are these IDs? An ID is something that you would associate with, let's say, a user ID, or a user session ID, or a chat room ID, anywhere where you want to build synchronization for like different people to connect and do things. The counter example is OK, but a slightly more useful example would be if you wanted to build a chat room. So let's say for every /chat/ID using your routing library of choice, there's like one that we all use. You maintain literally an array of strings called messages, and anytime you make a post to this request, you add to the messages array, and if there's a get, you just return all of it. And this code is so wonderful because it matches the mental model of how you think about chat code working inside a chat room. Of course, no one is ever going to build a chat room with HTTP requests. Something a little more interesting would be, hey, what if we had methods like onConnect that got triggered every time a WebSocket connected to the server, and a method onMessage that got triggered for every message? You don't have to read all this code, but 3 interesting parts here are you can literally store an array of all WebSockets that connect to this. Every time a WebSocket comes in, you just push it onto this WebSockets array. And anytime a message comes into this chat room, you run a for loop on the WebSockets and distribute it to every WebSocket that's connected there. I love this code. If you have never had to build a real-time system in the past, then this might look extremely normal to you. But the truth is, trying to build a chat room system right now involves an architecture that looks like this. I wanted to put 50 more green people there, but copy-pasting in Keynote is an absolute pain. Like, you don't want to do it. I gave up halfway, and I was like, oh, let me make it a little bigger. But the truth is that you want to, because you can't use regular serverless, you want to provision machines, you want to set up proxying, some kind of persistence, and you need to make sure that connections to a room end up in the same place. Durable Objects takes this architecture and instead flips it and says, hey, no, the infrastructure is going to give you primitives where you can implement something like this. So every chat room gets like its own process, and everybody connects to it, and you can write simple code that just works. I wish the API was a little more complicated. It would make me look a little more impressive, but it is what it is. So what can you do with this? Why is it even useful? Business logic is what it is. You want to be able to write code that does sentiment analysis, profanity checking, anything really. What I decided to give as an example of business logic is what if you could make every message into like SpongeBob case, making everybody in the chat room sound sarcastic as hell. And it's something, because you're not using a pub/sub system and it's a server authoritative model, it means clients can't opt out of it. No, like every message comes in, gets converted into SpongeBob case, and gets broadcast to everyone else. You should put normal logic inside there. So you can actually build systems like this today with PartyKit. It's free for commercial usage since now it's a part of Cloudflare. Just pay Cloudflare usage. There are a bunch of starters. You can build chat rooms, and we're going to keep expanding this list. My favorite is the text editor. It's actually a very complicated use case, which is just 4 lines of backend code. So what does this have to do with server components? The thing that bothers me about server components ever since I started trying them out, and folks here who might have tried it out in Next.js or somewhere else, will know that you can't use state and context with server components. It just says, nope, those are client-side things. You might have a component, a very simple counter, and you say, hey, counter, set counter, use state, and on button, you increment it by 1. This won't work. Like, the compiler will throw and say, nope, you cannot import useState inside a server component. And what you have to do to work around it is to literally opt out the whole thing into a client component. And that's annoying, because I want to use like the latest stuff. That's how people think I'm interesting and smart, like using the newer APIs. So what I really wanted was, I wanted this programming model. I really want to use useState, I want to use state, and I want to use context. Hell, maybe I also want to use like server actions. Like literally inside the onClick handler, I want to say, hey, like this is happening on the server. Here it's doing set counter. It might really be talking to a database, which already works. But I want it to work with a set state call. It's not just state. The other use case that I find that I really want inside server components is context, to be able to have a value that I share amongst a subtree. The thing that comes to mind is like a dark mode flag, but it can be a number of things. And it's complicated because client components might expect it, and you need to like serialize it down. So the workaround for this is to move it into client components. No, I don't want to do any of that. I want to use context inside my server components and have it just work. So where does that leave me? I wouldn't be here if I didn't have something to shill. I've been building something called React Party. I'm incredibly original by naming things, everything has the word party, as you can imagine. And while I'm not releasing it to beta today, you can actually bribe me during the after party, and I'll give you access to the repo. And it looks great. It's exactly the API that I told you. It uses this serverless compute model to maintain state that lives, and it exposes it with hooks that just look like they're from React itself. It also gives you like a little server that you can extend. And if you squint at it, it strikes me that I've reinvented class components, but slightly different. But it works. You can like hack on it. You get access to all the WebSockets, all the hooks like on connect, it's like on start, on request. What is it good for? Well, I am here building a framework, which means it's good for everything. You should probably rewrite all your applications with it today. No, truly, there are a number of new use cases that people are building every day now that it turns out it's a really good fit for. The things that come to mind are chat rooms. Everyone's building a damn chatbot nowadays, but you can make it multiplayer. Collaborative tools, if you want to build the next Google Docs or Figma or what have you, like a linear, I don't know, anything that's like real time. You just want to have cursors on the page. You want to build a game server, so like trying to put a game out there online is something that can bankrupt you, and you don't really want that. But the stateful serverless model makes it as cheap as a regular serverless model. AI agents, so things that talk to LLMs and that are running in the background. Data grids, because I want some of that fintech money. And like a lot more interesting real-time use cases. Instead of just worrying about CSS, I've decided to worry about money-making use cases now. So to recap, React Party should be out soon. It puts state and context in all your components, server components, client components. It uses WebSockets. All of this stuff happens on the server side, and it just sends component divs over WebSockets. It's low latency. Like around here, I checked, and it's about 20 milliseconds to the closest Cloudflare POP, which is insane. Powered by this global edge network. If another provider comes up with a primitive like it, I will gladly make it work on Amazon for how much ever they charge you. There are no explicit network APIs. It's so nice writing code like this. You just write functions, and you just call them. You get multiplayer for free. So the big question is, do we really need a new framework? I started building this a couple of months ago, and I started building like a CSS pipeline and like fast refresh, and I just hated it. I was like, OK, if that's what it takes, that's what it takes. But I think over the last couple of weeks, I figured something out. I think I can ship this in Remix. I think if you give me like another month, I'll be able to ship it in Next. I'll definitely be able to ship it in Waku, because I just love that framework, and it's such a great community. And I also checked out the RedwoodJS code, and I'm like, OK, I can make it there. As you can imagine, I listed the 4 React Server component frameworks I know, because I do not want to build a CSS pipeline. I'm going to try to make it work in existing frameworks, so you don't have to rewrite your code. You can just start using useState and context. So that's mostly it. I wanted to end on a demo, so if you want to get onto that QR code, I love this example because this is something that would have taken a team and a lot of expenditure to build like one of these globes where everyone, like, it shows you where in the world you're from. If you're on the live stream, feel free to like go in. This isn't live, I'll pop it open. But I'm super excited to learn what you people do with this. It feels like it's so much fun to build applications this way, and I just can't wait to see like what you folks do with it. I'm going to quickly see if I can open up that thing. Oh, look, there are like 200 people. Oh, wait, you can't see it. Where do I? Not bad. There are like 200 people on this right now. It works. It's like a 100-line server and a 100-line client code. Amazing. I want to hit like 1,000. Thank you so much.
Ash on the mic, bringing the heat. React Conf 2024 can be beat.
Goodness, I love the demos. Thank you so much, Danielle. And also, representing India, let's give them some love for Asian Heritage Month. Oh my goodness. Yeah, oh man. All right, cool. So our next speaker is hailing in from San Diego. Definitely get a lot of beach vibes from other folks that are from San Diego. Do we have, there you go. I think there's another person from San Diego, Chan. No. All right, cool. Anyways, so as far as vibes, I get a lot of, his favorite emoji is the sweat smile, and he definitely gives that in a bear form. So imagine a very nice huggable bear, but also sweating, smiling at you at the same time. That is how very much would characterize Josh's vibes. So let's give him a huge warm welcome. Thank you.
Stories here, map the code, Excel to React, watch him explode. From IC to XX, startups in sight, chef in the kitchen, pushing limits tonight.
Good? Okay. There it is. Hi, everyone. It's good to see you again. I think I just saw you a few hours ago. My name's Josh. I'm on the React team at Vercel. And this is a deep dive talk where I kind of go into deeper detail about some of the stuff that I talked about earlier today in the keynote. I've been a fan of React for a really long time. In fact, I was here in 2018 and 2019, sitting somewhere. Actually, we were over there, but it's really cool to be up here now twice today. And I really am excited to share with you kind of what I've been working on inside React and get into some kind of the decision making that we made. All right, so let's begin. So in React 19, we added a number of things that help you compose non-visual HTML alongside visual HTML. You can render document metadata, style sheets, async scripts directly from components and still expect React to produce an HTML document with these elements in the ideal position. And in this talk, I wanted to talk about those design challenges that we had to solve. But I have to still recap the problem, so we're going to go through that fairly quickly since some of you might have already heard it before. But in React, you often want to be able to reason about your components locally. And this means that you can understand what the component's going to do without having to understand everything else in your application. But it's hard to write components like this article example. This component's going to render its article contents, but it also wants to render the page title. And it wants to load a style sheet that should kind of alter the visual presentation of the article. But if we actually rendered a component like this before React 19, the page title and the style sheet are going to be somewhere that they shouldn't be. They're going to be deep within the body, and we really want them to be in the head. Now, to solve this problem, you really just have to kind of give up on co-location. There's not really like a good solution for this, and you kind of have to move the coordination of the styles you want to load or document metadata into some other system that sort of lives outside of React. And users often turn to libraries and bundlers to solve this problem for them. And so while you may not directly interface with this sort of coordination challenge, the people who write these tools do, and it can be quite painful. We want React to better support libraries and bundlers by eliminating this coordination work, but we also want to make these things work better with built-in React features like suspense and streaming. Okay, but rather than actually going through each new API and kind of just rehashing what they do and how they work, instead I want to talk about like why you would even care whether the HTML was sort of in a particular location. What are the motivations for us even wanting to do this in the first place? So the first one I want to talk about is tool compatibility. Most of the time, when you produce an HTML document, it's for some person, and they consume it through a browser. And browsers are really good at finding and using things like document metadata, even if they appear somewhere that they're not really supposed to. But sometimes HTML is consumed by bots or other tools. Facebook's or Meta's Open Graph Image Processor is sort of famous for this, where it only really looks in the head. And so you have to be kind of quite careful about how you describe Open Graph properties to make those work on social media sites. So we decided we'd take a pragmatic approach. If the spec says something should go in the head, then we try to put it there. And often we can. But React also believes that streaming UI can provide a better user experience than traditional server rendering. And we need to confront the fact that when you stream, you don't always know that you're going to discover something that should go in the head until after you've sent it. So when React discovers document metadata after the head's already been written, it simply emits those tags into the body. When preparing an HTML document for a live request, with a person on the other end of the screen, we favor showing something useful early, and we rely upon the browser to just sort of tolerate late arriving HTML. And the way that you tell React that you want this behavior is you just start reading the HTML as soon as possible. But maybe you're pre-rendering and you intend to cache this document for future live requests. You don't want to include every intermediate UI state. Or, what if you determine that you're preparing a document for a bot or some other tool that doesn't interpret HTML as flexibly as a browser? You can ask React to ensure the HTML is complete with no intermediate states and simply wait for React to finish rendering before you read the document. And that's what we mean when we say balance. You have the levers to pull depending on your circumstance. That means you don't have to sacrifice raw performance for live users while still being able to produce clean documents that are compatible with tools that require stricter adherence to the spec. And if you're skeptical, go look inside the HTML from your favorite product on Amazon. The largest e-commerce company in the world is happily rendering titles and descriptions deep within the body because it's pragmatic and it works. All right, the second thing I want to talk about is loading speed. Fast sites are good. It's not particularly controversial. And one of the best ways to make a site load fast is just to make sure that the first tags that the browser encounters are the ones that describe all the resources that it needs to complete loading the page. Scripts don't have a visual component, so we could, in theory, put them anywhere in a document. But unfortunately, they have a pretty serious downside. They pause all HTML parsing while loading, and then they execute synchronously. React can't just relocate normal scripts because this document order constraint might be relied upon. But even if we could come up with some way to work around that, it'd probably make the page performance worse if we moved it earlier in the document. But if you can switch to async scripts, you probably should. And once you've made your scripts async, React can safely relocate them and include them earlier, both on initial load and during streaming updates. Another consideration for loading quickly is to eliminate waterfalls. Imagine you have a style sheet that has, uses a font and has a background image embedded within it. These resources aren't represented in the HTML directly, and so the browser's not going to know about them until after the style sheet's loaded. We can provide a hint to the browser by rendering preload tags. However, rendering isn't the only time that hints like this would be useful. For instance, you may want to start preloading on navigation intent, like a link hover. But there's no rendering going on here. So instead, we modeled hints as side effects using an imperative style API. And you can use the same composable API from within your components as well. So far, all my examples for resource hints have been about preloading. But here's a list of all the browser hint functions that are added in React 19. Prefetch DNS and preconnect are interesting because sometimes you don't actually know what resources you're going to load, but it'd still be useful to establish a connection early because you know the host that you're going to actually connect to. Pre-init is a lot like preload, but you actually want to have the browser actually start using the resource early. If you it takes time to parse style rules, so maybe you want the browser to actually go through that step so that later when you need to use those styles, it's a little bit faster. And Webpack chunks are another good example where parsing the chunk can make the loading feel faster by moving this work earlier in time, so it actually loads the script rather than just preloading it. We also support ESM as well. You'll notice there's preload module and pre-init module as well. These are there for people who are living in the future using the ESM for all their stuff. All right, the last important consideration for faster page loading is prioritization. Browsers can only do so much concurrently, and so even if we get every hint possible to arrive early, we still want the most urgent ones to be encountered first. When considering what work needs to be done to get pixels on a screen, resources that block paint should be favored over those that don't. So React will ensure that fonts, high-priority images, and style sheets are all loaded early. But we also want to make sure that we're taking advantage of any early connections, so React ensures those actually come first, and it ensures scripts and other preloads arrive last. This looks like a pretty good prioritization, but there's a few things that are still missing that I think really show off the power of letting React do this coordination. Let's consider the char set meta tag. It's a little strange, actually, that we even need to render this in HTML, but unfortunately, it still kind of matters today. If you render a char set, it really needs to come first because it tells the browser how to decode the rest of the document. And image preloads can be affected by viewport size. So React ensures that if you render a viewport meta tag, it always precedes any preloads so you never end up downloading the wrong size image. And finally, import maps affect ESM module resolution. So when you render an app with an import map, React makes sure it precedes scripts that might otherwise load incorrectly. All right, the last motivation I want to talk about is style coordination. Style sheets are sensitive to the relative order because rules in later style sheets override rules in earlier ones. But being able to coordinate the relative position of style sheets across components is a difficult problem. We actually considered briefly whether we should just recommend style systems not rely on precedence to work correctly, but we knew that we'd leave a lot of users behind if we actually did this. So instead, you tell React what the precedence is. This is both an opt-in to the new style sheet mechanics, but it's also an instruction to React on how to manage the style sheet order correctly. Many of you will be just fine using a single value like default, but for those of you that need more control, you can craft a precedence hierarchy that works kind of like how CSS layers do. But I think the really interesting thing to consider with style sheets is actually the consequences of global order. Browsers do this really cool thing where style sheets in the document head always load before it does the initial pane. It's pretty basic sounding, but it's so critical to having a good experience when you first open up a page. You don't want visual bugs like flash of unstyled content ruining the day. But just like with document metadata, we have to contend with the trade-offs imposed by streaming. When you stream with React, we don't have guarantees that every style sheet will be discovered before we've sent that initial HTML. So React extends the built-in behavior of style sheets discovered during streaming and makes sure that they're always revealed in coordination with UI. When you render a style sheet with a precedence prop, the nearest suspense boundary will not be revealed until that style sheet has loaded. Now, I've actually been a little imprecise in my language. I keep saying the word style sheet, and you're probably all imagining a link tag pointing to some CSS file that loads over the network. But that's only half the story. That's right, I'm talking about CSS and JS. Now, calling it suspense for CSS and JS, it might sound kind of strange. These styles are style tags. They don't actually have to fetch anything over the network. But one of the most difficult challenges with CSS and JS implementation in React right now has to do with streaming server-side rendering. When a suspense boundary is about to be revealed on the client, it's critical that all the styles that were used in that boundary are already loaded in the browser before React sends that instruction. And if you've ever looked into how you'd accomplish this today in React, let me just tell you, it's a mess. Just like with the style sheet links, React needs to know about the precedence of the style tag, and it needs a unique ID. Now, the reason we call this unique ID href was that we originally built this capability for a kind of unrelated feature. We wanted to make React be able to inline style sheets so that we could make some renders, single round trip. We don't have to go back and fetch additional resources. And so we just take a link to some external style sheet, inline those rules right in the document, and call it a day. But it turns out that this model works pretty great for CSS and JS too. Once CSS and JS libraries adopt this method of encoding rules, all the complicated code it takes to intercept the HTML stream and ensure the rules arrive before the content can simply be deleted. This will improve the internal implementation of these libraries, but it'll also allow the removal of difficult to understand APIs that you have to use if you want to use these in server-rendered environments. There's one last thing that I want to share about style sheet coordination. For many developers, styles are managed by their bundler of choice. But bundlers often do their own style coordination to prevent visual bugs. So when you load a new chunk from your bundler asynchronously, the module will not be made available until after the style sheet has loaded. While this is good for correctness, we have the opportunity to speed things up. By leveraging React's new suspense for CSS capabilities, the resource load can be done in parallel to the code execution, while still ensuring the UI never paints with incomplete styles. All right, so what's the point? React 19 is taking on a new kind of coordination challenge. These problems are hard to solve in user space, and we think React 19 has pragmatic solutions that balance the correctness and capability and support all of our runtimes consistently, and most importantly, allow you to write components that compose even when they contain HTML that is being used somewhere else, or that belongs somewhere else. And whether you use these new features directly, or you just use libraries that take advantage of them, the bottom line is that complex code somewhere gets to be deleted, and your component model is more powerful than ever. Thank you.
Ash on the mic, bringing the heat. React Conf 2024 can be beat.
All right, awesome. That was amazing. Thank you so much, Josh. I almost went back into that wizard character, so I had to stop myself. But let's actually kind of go right now and talk about our next speaker. Coming in from Paris. We actually, when we were just chatting, we were geeking about pastries. I know you didn't ask, but I'm going to tell you anyways. My favorite pastry is called millefeuille. It's the perfect combination of custard, puff pastry, and icing that's just, chef kiss. I think it's called a Napoleon here. I think so, I don't know. I've been on a hunt for it, and I still am chasing just the right baker to make it for me. Anyways, let's give a nice warm welcome to Charlotte Isenberg.
Charlotte's good, babe in hand. 3 years strong in React native land. Let's break React rules. She's got the flow. Hip-hop beats.
React has two fundamental rules of hooks. Only call hooks at the top level. Only use hooks from React functions. You know them. You respect them. Break these rules, you might just break your app. But do you know why that is? Hi everyone, I'm Charlotte. I'm a React Native tech lead at BAM, and today we are going to break React rules of hooks to aim a better understanding of React. So let's begin with the first rule of hook. Only call hooks at the top level. So we're not going to do that. We're going to use a hook conditionally. Inside a recipe example, a recipe that for now only contains a single ingredient, because we're going to start easy. For this ingredient, we have its name, the quantity inside this hook that is called conditionally, so not at the top level, and this, whether it needs to be purchased. We're going to display this value and to add a button to add an ingredient. The first thing you've got to know is that the first time we run our app, React is going to create this virtual tree made of our React components. This tree is called the fiber tree. The fiber tree holds all of the components that make up our app, and their data, their hooks, and props value. This way, when a render happens, React remembers these values and knows which components it has to render. And from this fiber tree, React is going to inject our HTML elements into the DOM to display our application on the screen. So let's build this fiber tree together. The first component we instantiate is this recipe component with this JSX syntax. And JSX is actually just syntactic sugar, and is equivalent to the call of this function called JSX. And this function, when it is called, creates a new fiber. It's a node in our fiber tree. This recipe fiber is kind of like the instance of our component that holds the data of our component through vendors, its props and hooks values. This is the first node of our tree. It's our starting point. So we're going to start there. We're going to render recipe. What does this mean? Rendering a component simply means executing it. So we're going to execute this function. First, we have this useState. useState is going to be writing its default value into the fiber. Then, ingredient is null, so we don't pass this condition. So we move on to this second useState that also writes its value in the fiber. Hooks write their value in the fiber in a linked list, where every value points towards the next one. They write their value in the order in which they're called. Great. Then we move on to this JSX. We're using the JSX syntax here, equivalent to the JSX function that creates fibers. So we are going to create fibers for the paragraph, the input, and the button. And this is our tree. Now, this tree is still virtual. We haven't displayed anything on the screen yet. So what React's going to do is it is going to go through our fiber tree, and every time it encounters an HTML element, it is going to inject it into the DOM. And now our application is live. Things ran pretty smoothly, even though we use this hook conditionally. But wait. Wait till we click this ingredient button. We trigger a set state. What happens then? We are going to render. We are going to calculate a new version of our fiber tree that corresponds to the change that we've made, to our new render, our new state. Then React will be able to compare this new tree to the one from the previous render and apply the differences to the DOM. So let's calculate this new tree together, step by step. We click this button. We trigger this set state. So we update this hook value, and we are going to go through our tree and re-render the components we have to. So we begin with recipe. We render recipe, so we execute this function, and we pass it the hooks and props value coming from the fiber. First, useState is going to be reading its value from the fiber. Hooks read their value in the order in which they're called. So first, ingredient is going to be reading the first element of the linked list, flour. This time we do pass this condition. Ingredient is not null anymore. So we've got the second useState, quantity, that is going to be reading into the second element of the linked list. So quantity is going to be false. Then we've got this third useState, purchase, that can't seem to find its value anywhere. And this is when you get this way too familiar error message. Hooks store their value in a linked list where every value points toward the next one. They're all interconnected in this linked list. So if you call a hook conditionally, you change the order, you break your app. This is what happens if you break this first rule of hook. Only call hooks at the top level. Now, as you can see, this hook is very much linked to implementation details of React. Details that may change. So rules of hooks, they may be kind of volatile. But rules of React, the one that govern the compiler that you've heard about today, they are here to stay. So before we tackle this second rule of hooks, let's talk about a few of rules of React. First, components and hooks must be pure. One simple way of making a component not pure is to mutate a hook value it uses. So this ingredient array, if we push a new element to it, we mutate it, what happens then? Well, we do update this value, but that's pretty much all we're doing. We won't see our new value on the screen. Because what makes the value appear on the screen is not changing this value. It's not even rendering this component. It happens afterwards. React goes through our tree, creates a new one, re-renders our components. Then, from this new tree, it commits the changes to the DOM. Then you can see your changes. And all this inner mechanic, that's something that you can trigger with the setState function, not on your own. That's another rule of React. React calls your components. You don't. We are also told not to use a setState unconditionally in render. That's kind of a cryptic way to say, don't do this. You know why this is bad. You render a component, trigger a setState, so render it again, over and over again, until you get this error message that I know you know. I know we've all triggered it at some point. Instead, you can do something like this. You can call a setState as long as it's conditional, as long as you don't trigger an infinite loop. OK, enough about rows of React. Let's go back to our React rows of hooks and tackle this second rule of hooks. And to break this one, only use hooks from React functions, so function components and other hooks. To break this one, we're going to go into the wonderful world of React Native. Our recipe is now going to have several ingredients that we're going to display in a flat list. A flat list, just like a text, is a core component provided by React Native. A flat list acts kind of like a map. You provide it with an array of elements and the render functions. It is going to map over our array of elements and call this render function for each of them to display it on the screen. So let's build a fiber tree. We've got recipe that we render, so we've got this state, this array of eggs and flour, and we create this flat list fiber because of the JSX syntax. We're done with recipe, so we can move on to the next fiber of our tree, flat lists. We render flat lists, so it is going to map over the ingredients and calls this render ingredient function for each of them. So it first calls this function with eggs, so we create this text fiber because of the JSX syntax, and with flour. And this is our tree. Now, if you try this out, you may see that this does not exactly reflect reality, because flat list is actually a class component, not a function component. So a few things are different there. And also, the flat list instantiates lots of other components under the hood. So this is kind of different, but the idea will still stand. OK, so let's break our row. To break it, we're going to add another functionality to our app. We now want the user to be able to set the quantity of each ingredient. But what if, instead of adding this quantity use state inside a regular render React function like we're supposed to, what if we add it inside this render ingredient function? Render ingredient is no function component. It's just a regular function. The difference is that when flatlist calls render ingredient, it calls it this way, as a function, not as a function component, not with the JSX syntax. And this changes everything. When the flatlist is rendered, it is going to call the render ingredient function twice. First with eggs, so we execute this function. We've got this use state that is going to be writing its default value inside the fiber that's currently being focused, which is flatlist. So we've got this 0 quantity inside this flatlist fiber. Then the flatlist calls render ingredient with flour. So we've got the second use state in there. So we end up with this tree, with the quantity values stored inside the flatlist, where they don't belong. And from this code, with the use states stored below this render ingredient function, this is definitely not the tree that I would have pictured. Instead, if we had properly added our state inside an ingredient component that we call with this JSX syntax, the tree would be much different. When the flatlist is rendered, it will call the render function first with eggs, so we would have this ingredient fiber because of the JSX syntax, and then with flour. Now we're done rendering the flatlist, so we move on to the next fiber in our tree, this ingredient fiber. We execute this function component, and we pass it this props value eggs. We've got this use state that writes its default value inside the currently focused fiber which this time is this ingredient fiber. And the same goes for flour. And this tree, to my opinion, makes way more sense. Now, if we come back to our very, very poor example with this use state inside this render function, is doing this really that bad? I mean, this tree is virtual, nobody sees it. But it can actually make your application crash. If we add this add ingredient button to add a last-minute ingredient to our recipe, if you click this button, you will actually make your application crash. Can you see why? When we click this button, we add this salt ingredient right here. So much so that when the flat list is rendered, it is going to call this render ingredient function 3 times. First, with X, we execute this function. We've got this use state that reads the first element right here. Then with flour, so the use state reads into the second element. And do you see this coming a 3rd time for salt? That can't seem to find its value anywhere. And we fall into the same error we encountered when breaking the first rule of hooks. We are basically adding a 3rd hook in there. So why does this work with the correct version? With the state inside a component, why does this work? When we click this button, when the flat list is rendered, it is going to call the render ingredient function 3 times. First with X, then with flour, and then with salt. So it instantiates this new ingredient fiber. We're done with flat lists, so we move on to the next fiber ingredient. Use state reads its value from here. Same goes for flour. And when we reach salt, this use state sees that this fiber is an amount state, not in a render state like flat list is, like all of the other fibers are. So it knows it has to write its default value into the fiber instead of trying to read it from the fiber. And this is what happens if you break React rules of hooks. React can sometimes seem magic, but it really is just an algorithm that you can learn and master. Of course, React algorithm is changing. So as much as I love understanding how the tool that I use work and why I have to follow the rules that I do, what's important is not so much knowing how the React algorithm works today with all of these details of implementations, because they will much likely change. What's important is more knowing why following these rules helps you write better codes. Thank you so much.
Ash on the mic, bringing the heat. React Conf 2024 can be beat. Travel beats, don't you feel the vibe? Get ready to code, let's come alive.
Great, all right. And we are now at the grand finale of our Lightning series. So, when we're jiving, one thing I'm really keen on is on sharing the good vibes in any opportunity that I can. Hopefully, you guys are really enjoying my vibes, and thank you. And let me know, give me feedback if you would like more vibes, less vibes, different type of vibes. But one quote that our speaker really shared with me that really resonated was that it's kind to be kind. So that's something I would like to also share with y'all, and how, at least with the amount of information that you guys consumed, at least you can take away that it's kind to be kind in any form of interaction. So let's give a huge round of applause to Amy.
Thank you. Well, I can say that we're all friends here, right? We're all here because we love React. It's part of our DNA. We built all these frameworks on top of it. And I firmly believe that every framework is good in its own right. We all bring something to the table. Rising tide lifts all boats. But we all have preferences in how we like to build our applications. We have opinions about what the developer experience should be like, how files should be organized, and what patterns are the most efficient. And with certain conventions and tools, we're able to move faster, not only individually, but also as a team. So let's break this down a little bit. First, let's talk about what we're building, an application. And applications are really about data. So we have CRUD, create, read, update, and delete. And that's really 90% of application development, right? Without the ability to fetch that data, we just have a static website. Now, I've been in the industry a long time. I started working at an agency in 2002, back when people still called us webmasters. I feel like that's from Star Wars. They would call me on the phone, and if they were really high tech, I get an email that says, please make these changes to my website. I'd make the changes, and I'd use FTP to update the files on the server. Now, back then, times were much simpler, and it was still really fun to build, but now we have so many more tools at our disposal. And it's been amazing to see all the things that people have been able to build and what can actually be run within a web browser. But one thing that's common between then and now is that it's still all about the data. We want to take a set of data, we want to be able to view it, manipulate it, pivot it, filter it, and sort it. We make inferences and decisions based on that data. And I'd argue that's the core element of any application, the data. So when it comes to building an application, that's the piece that we care about. Fetching the data, grabbing it from a database or an API, and then doing something with that. So my name is Amy Dutton. I'm a lead maintainer on the RedwoodJS core team. And this is something that my team obsesses over. Redwood has been around for a while. It's 4 years old, so it's not a brand new project. We are co-founded by Tom Preston Warner, who also co-founded a little project called GitHub. Maybe you've heard of it. Or if you've used the extension TOML, he is also the Tom in TOML. So I'd say his track record is pretty good. We are an independent open source project, and it's sponsored by Preston Warner Ventures, so we are fully funded. Applications, startups that have built their projects on top of Redwood have raised over $100 million. One of our most successful applications is called Puzzmo, and this was co-created by Orda. He started at Microsoft. He worked on the TypeScript team, and he left Microsoft to build Puzzmo full-time. It was actually acquired by Hearst Publications. And since launching in October, they've had over 9 million games played, and right now they're averaging 1.5 million games per month. So now what's interesting about Redwood and what separates us from other JavaScript frameworks is that we are a full stack framework. And I know that term kind of gets thrown around a bit. What actually makes us full stack? Well, we ship with a database. And that data layer that I mentioned that's so important, we ship with that as first-class support. Now, historically, this has been within the context of GraphQL, but Redwood now supports React Server components. And so this makes working with data even easier. And while we'll always continue to support GraphQL, you're no longer tied to GraphQL. And you can bring whatever backend or API you want to work with. So let's take a look at some code, because that's what we care about, and see Redwood's flavor of implementation and how this might vary from some of the other options that are available. So within Redwood, we have something that's called a cell. And a cell is something that's really unique to us, and one of the things that makes that Redwood Redwood. So generating a cell is very simple. You can just run yarn redwood generate cell sample, and in this case, sample is the name of the cell. Now, this will create a file that looks like what's on the slide. And if you're working with data, there's several pieces that you need to account for. So first, you have a query. You need to be able to fetch that data or query that data from the database. So in this case, this is a GraphQL query. You also have a loading state. So what gets displayed when the component is loading that data from the database? We also have an empty state. So what happens when it was successful, but no data was returned from that database? Or you also have a failure. We need to be able to see the error that came back from the server. And we also have a success component. And this gets displayed when everything is going according to plan. We want to see that content displayed. Now, you'll notice that these are all components. Redwood is smart enough to deliver the appropriate component depending on the result that it gets back from the database. So normally, you'd have to write a bunch of conditionals. Redwood handles all of that for you. Now let's see how this changes with React Server Components. So this is actually a server cell. And you'll notice at the top, we have a data component. And it's no longer using GraphQL. This is a Prisma call to the database that ships with Redwood. Then we still have a loading state, an empty state, a failure state, and a success state. And here, with the success state, it's displaying the products that get returned from the server. Now let's look at the router. And this is even more unique to Redwood. We have a single file called routes.js, or if you prefer TypeScript, routes.ts. And this file defines all of our application's URLs. This is a huge differentiator from other frameworks that use file or folder-based routing. Personally, this has become my favorite way to handle routing. Why? Well, with file and folder-based routing systems, your file organization is tied to your routes. If the route needs to change, then you need to move the files and folders around, which has the potential to break import paths. Or with a frat router, you're including layout details within your file and folder names, so now you're smushing two pieces of information into your file names. With Redwood's routes.js file, there's a single file with all the information that you need. The syntax also looks similar to JSX, which is something that you're probably already comfortable with. Now let's take a look at the first route component within this file. So we have a path attribute, and this specifies the URL that you want the page to use. We also have a page attribute, and this is the component that the user should see when they go to that URL. Then we also have a name attribute, and this is how you want to identify the route. And in my opinion, this is one of the best features about our router. As long as you reference the routes throughout the application using that name attribute, you can change your paths, that URL, all day long, and none of the links within your application will break. As a prime example, you'll notice a little bit further down, I have a login page. And right now it's set up to be /login, but if you wanted to change that to say /signin, you can make that change in a single place here within the routes file, and everything continues to work. So let's talk a little bit about handling layouts. Here I have my auth pages, login, sign up, forgot password, reset password, and accept and invite. And these elements are wrapped within a set component. And this has a wrap attribute that specifies the component that I want to use for my layout. And again, you aren't forced into a URL convention or a file naming convention based on what layout you want to use. Let's look at it one more kind of set component. So here I have a private set, and these are password-protected pages. That's right, authentication ships out of the box with Redwood. So here we have an unauthenticated attribute that will send the user to the login page if that user is not logged in. And just last week, we shared a blog post on our website explaining how auth works with middleware in Redwood. So Redwood has so many integrations out of the box. We just touched really on one, the data side, which includes databases, but it also has Storybook and testing built in. So it's easy to see all these tools that Redwood provides and say, hey, isn't this just a starter kit? Well, with starter kits, yes, they provide you with different ways to get started faster, but what happens when the library or tools upgrade? All that maintenance work, that falls to you. So Redwood handles all of your dependencies for you, so you don't have to. And upgrading is as simple as running a single command within the terminal, yarn redwood upgrade. So with that, I hope that you will all upgrade and take a look at Redwood. You can scan the QR code to go to a dedicated landing page for React Conf, and here you can find additional information about key differences between Redwood, Next, and Remix. You can also see some of the stuff that the team has been working on with React Server Components and SSR, including our roadmap. And if you're interested, I'd encourage you to sign up for our newsletter so that you can follow along. Thank you.
Ash on the mic, bringing the heat. React Conf 2024 can be beat. Travel beats, don't feel the vibe. Get ready to go, let's come alive.
Thank you so much, Amy. That was the last talk of our lightning series, which means that we've reached the last segment of the day, which is the Q&A with the React core team, the React team. Apologies. I misspoke. So, I'm going to introduce someone that's going to probably give y'all the right vibes that y'all need right now to smoothen out the day and really have y'all leaving on a great note. So, coming in from San Diego and representing China as a flag, let's give him a nice warm welcome when he gets on stage for Asian Heritage Month, which is almost a tongue twister, because it rhymes a lot with Haitian. But yeah, he has a nice server vibe. He has a nice flow going on. Let's please give a warm welcome to Chan. Ooh. Michael Chan, sorry.
Here, bringing the funk, Michael Chan's groove, never in a bunk. Coding rhythm, he's got the flow, lighting up the stage, watch him go.
Is that a Taylor Swift?
Yeah, awesome.
I'm so happy right now. Hello, everyone. How you doing? Let's try one more time. It's the end of the day. This is the last session. Let's get that energy up. How's everyone doing? Good. Yes. Yes. That's much better. Man, speaking of hair, I got it all over my mouth. That little swoopy thing just gets it everywhere. Okay, so something that we're going to do today is really fun for me. We're going to do a Q&A panel. And I want to bring everyone out. It looks like we're all set up. I'm super excited about this. For about 3 years, I got to host a show called React Podcast, where I talked with a lot of people about React. If you were like, I kind of recognize that guy's voice, but he sounds drunk, you probably listen to React Podcast at 2x. So today we're going to do a 1x version of that. It'll be much slower, but it'll also be a lot of fun. We've got the React team. You've seen a lot of them give beautiful talks already. Let's give them a round of applause real quick. Now, my goal today is to ask some questions that you might have asked, but I've run a number of meetups, and I know that y'all ask bad questions. The mean ones get to the microphone first, and then people just start talking about their own applications and the businesses that they're building. Like, it gets pretty tiresome. So I want to represent you, though, and so hopefully I've compiled a list of questions that will represent your interests and some of the questions that you may have had from these talks. And so I hope I did a good job, and we'll find out. So we got everybody here? Let's start this off. All right. Okay, so the first one is for Lauren. How you doing?
Hello.
Hello. So I want to talk about the compiler a little bit. Right around the time that React came out, Elm also kind of came out, and because it was a language, it had some really world-class developer experiences. The compiler errors were really great, and I think a lot of people were like, well, how do we get something like that in something kind of smaller, focused like React? And so I'm curious, in the compiler, in your work on the compiler, where are some areas where you and your team have really sweat the details to provide a great DX? And did Elm and things like Svelte have a role in kind of shaping what that looked like?
Yeah, I think our team definitely takes the developer experience of using the compiler very seriously. And we spent a bunch of time making sure, just even things like, where does the red line appear? Like, does it appear at the call site where you call it? Where at the declaration? There's like a lot of little details to figure out. And I don't know if we looked at any particular library or package or language for inspiration, but I think, I can't speak for the whole team, but I think a lot of us are like Rust fans. So definitely, I think the Rust compiler with its diagnostics is a huge inspiration for us. And something I also know from the Elm, they have a lot of focus on error messages for humans. So I think we still have a ways to go, but I think we've tried our best to make the error messages very readable and actionable. Anything that isn't actionable, we kind of we don't report it yet. And so we still, correctly detect errors, but if we don't feel like the error message meets our bar for what is a reportable message, we just kind of not report it yet.
Awesome. Now, Joe, I wanted to follow up with you on that, because I know in our conversations, you've said that you had to hit like a surprising amount of granularity in order to even hope to provide messages that were helpful, like where the squiggly line, like where does the squiggly line go? What has that looked like, that path looked like in developing a React compiler?
Yeah, so the way we develop the compiler is we actually have an allow list of syntax that we support. So we sort of, we started with basic JavaScript features, if else, for loops, variable declarations, and then kind of gradually expanded the syntax that we support. And so over time, we started, finding, okay, everything kind of works. We got to push to more and more of our code base in order to actually find errors. Yeah, it's been, which is exactly what you want, right? And so, I think, I don't know.
No, that's great.
Yeah,
that's great. Yeah, I have some more. So we're gonna actually flip sides. This is actually kind of funny. Like
a
just
little bit of an awkward setup. But despite the staging, we actually work very closely together. This is not like a symbolic thing that we tried to set up here.
Vercel on one
We're
side,
just gonna randomize
Meta on
every
the
once in
other.
a while.
Jason, this one's for you. So I know that there are a lot of existing kind of nuisances in React syntax right now. And so like, one of those might be like SVG. There's some like trouble around like self-closing tags, class, et cetera, et cetera. I wonder, the first part of my question is, do you think it's possible to address some of those maybe long-standing issues at a compiler level? So that's question number one. And then kind of in the second place is, well, you might not want to give secrets out about the future. What does it look like? What are some classifications of things that you see us maybe bringing into a compiler for React? Some problems that we can solve maybe in the future?
Yeah, sure. I can take a stab at that. And then I think the team can probably weigh in. I think, yes, I think it's definitely, our decision to step into a compiler is not unprecedented, right? Like, we've seen people in the industry do this in multiple frameworks. We actually also, within Meta, we've been doing this for a while too. We have a concentration of folks who have developed compiler expertise or who came in with compiler expertise. We build a relay compiler in-house to take GraphQL template literals and generate artifacts out of them. And I think jumping to a compiler model does like unlock a whole range of capabilities, from syntax to like things that affect the whole programming model. I think you asked about like what are some of those things. Gosh, I think we're really excited to explore them. As we've been going through this process, beginning with memoization, which I do think is just kind of one, tackling render performance, this one specific part of render performance, which happens to be a pretty big DX pain point, at least for us. Yeah, I think we've gotten glimpses of a bunch of other things that make us question, like, oh yeah, could we take a look at effects? Maybe we're taking some things for granted here, or actually maybe there's some room to make this much less painful. Maybe it's the dependencies are right, or maybe we can look at state or refs or context. Like all of this stuff, I think is up for the compiler to optimize, improve, and ultimately, I think we try to approach problems not just from this like super narrow view. Instead, we take a broader like, can we build this? Can we invest in something that's really a foundation? Not just a single like one little trick that gets rid of use memo or something like that. So, yeah.
Oh, sorry. I thought I saw a handoff. Yeah, please. Yeah. This is such a weird position. There's someone behind me. Did someone say something? Go ahead.
Come out to the cool couch. Sorry, I couldn't help it. Yeah, sorry. Trying to think of a real answer now. Yeah, the compiler is really a foundation, and what we're shipping today is really just the first sort of feature. So I think about it like we have a really solid foundation in the compiler, and it is not only about auto-memoization. It is a compiler that deeply understands React. So we gave a demo 3 years ago of something that was really just focused on attempting to do auto-memoization. And what we realized is we had to, in order to make that work, we had to understand your code at a much deeper level. And so we actually went back about 2 years ago and rewrote the compiler from the ground up based on everything we'd learned up until that point. And that is what is shipping today. And so now with that much deeper understanding, we're able to do auto memoization, but we can also do more things on top of that. So one thing we've talked about is shipping an ability to call context or hooks from inside use memo callbacks, where you could have more fine-grained access, so that, for example, today, if a component accesses context, well, whenever that context changes, the component will re-render. But you might just be grabbing one kind of tiny slice of the context. With the compiler, we are going to, if that piece hasn't changed, it will quickly bail out and you'll get an optimization. But we could go further and actually figure out, the context changed, but we can just figure out we don't need to do anything in this component at all, which would obviously be even better. And so that's a case where we can start to say, does this even need to be an API? Or could this just be an optimization that you never have to think about? React just works faster out of the box. So that's where I think it really starts to change things, where do we even need an API? But that's not ready yet. Coming in the future.
You got some people really excited just now. Yeah, give it up, give it up. Fewer APIs, we love it.
Michael,
Yes.
do you mind if I just want to praise the team who implemented the compiler real quick, and I can say that because I wasn't one of them, but I watched very closely the whole time along, and I'm going to suggest to anyone who hasn't done this already to go to the compiler playground. What's the URL again? It's like playground.react.dev. And you can type in some React code and see the compiled output. But I'm going to encourage you to do that because you don't just see the compiled JavaScript output. You can see all of the compiler passes that's happening under the hood. And not that it's important to know all of that stuff, but it's just really a testament, I think, to how much impressive engineering work went into this project. And also, to the question, I think it really gives you a sense of the potential of this kind of tool, given just how much the compiler is already able to infer from your React code. And I think with your imaginations, you don't need for us to really tell you what's coming. You can probably guess it, what some of those might be.
And possibly from some of your tweets, maybe. All right, Mofi, I have one for you, actually. So this is, as I was watching your presentation this morning, I was just getting, memories of like when I first saw React and the React Virtual DOM, and this idea that we could have write declarative UI, and it would just handle all of those insertions for us and do it with like great efficiency. And so I want to talk with you about the sentiment around, I guess, giving up control over performance. Because I can imagine that many of us in this room feel this sense of loss almost, as we have learned a very hard thing. And we love to hold on to hard things and just feel like, that's mine, I earned it. And so I'm curious, like, what has sentiment been like as you've rolled this out? Have people felt positively about it? Have there been things that people didn't feel positively about?
Yeah, I can answer that. I think the sentiment's been overwhelmingly positive. In fact, I think manual memoization isn't just tedious, it's pretty error-prone. So in the past, you've seen like production-level sevs come out of somebody writing a use memo and later kind of editing that value after the memo call. And we've found a couple of these cases as well when rolling out the compiler. I think in general, developers are pretty relieved to kind of give up control in this sense because it's not something that people really should be thinking about and worrying about maintaining. I also want to talk about a little bit of the work that the Flow team has been doing at Meta to use compiler inference and kind of this new framework, programming model framework, to enable better type errors and type annotations in Flow. So we've been thinking about how maybe functions passed to use effect might differ from functions used in render, for example. And I think there will be more kind of developer experience related work coming in the future. And I think that's really exciting because it's not really APIs that developers have to learn, but it's really like IDE extensions where
It's like, oh, you might be using this in a slightly suboptimal way, or this looks like you're doing something wrong. Like, are you sure you want to do this in an effect? Or
Yeah, thank you. I'm curious, and this can be for anyone. In that experience, I know that we've had a lot of ESLint rules up to this point, and that's kind of directed us up to a point. Now we can kind of get a little bit more fine-grained and like get into areas that we haven't been able to get into before. Does that change the developer experience? Like, does it like take it out of the editor, or like what's the workflow for that? Like, does it feel the same? Is it kind of like the same thing at the end of the day?
we expect it to feel the same, but it's very much work in progress.
Okay.
Yeah.
Cool. Ricky, I'm going to pick on you for a second because I saw a tweet about this. So there was some concern immediately around the fact that this is announced as a Babel plugin. And so I saw a tweet of you saying like, "Hey, no, there's like this is just the way you connect to the compiler." Tell us a little bit about kind of what we might be able to expect in terms of integrations long term.
Yeah, I think that's a great question because on the Dark Place, I saw a lot of like, oh, it's just a Babel plugin. It's absolutely not just a Babel plugin. It is an actual compiler, and what we published today were Babel bindings to make it easy to adopt in existing apps. So you can imagine an alternative where we would have shipped like a whole command that you would need to run in a separate process, separate from your developer server. That would kind of not be great. And maybe we'll have that eventually, and maybe we can build that out. But what we have now is a compiler runtime that has Babel bindings, and we're able to add other bindings for like SWC, so you can adopt it into more apps and more pipelines. So what we want to make it do is make it as easy to adopt as possible. It's one of the React principles of gradual migration and gradual adoption, so that everybody can try it out and get all the value and benefits of it without coming in like really hard with changing your entire pipeline.
Awesome, awesome, I love that. I think that'll probably set a lot of us at ease who are thinking like, do we have to go back to Babel to get the cool stuff?
Yeah, so one thing just to add on. So we obviously know that some folks are using other tools like SWC, tools that are written in Rust. So sometimes having to even enable a Babel plugin at all might slow down your build. So definitely aware of that. If you look in the repo, we've actually started porting the compiler to Rust. So you can expect that over time.
Yeah, give it up, give it up.
Give it up for Rust. Rust, Rust fans. All right.
Got some crustaceans in here, let's go.
That's kind of currently on pause while we're just continuing to get the compiler to be, it's experimental, so we want to work through some more things, but definitely it's on our radar to look at. And of course, that would still be, we want to have, in that world, it would be Rust, but still exported as a Babel plugin, so that if you are using Babel, you can still just drop it in and run.
I want to push on the compiler thing, because I think something that's interesting about React's history is that there's been this, since the beginning, a very symbiotic relationship with compilers. So like first with Babel, and then later with TypeScript. I'm curious, what does it look like kind of now that there is a React compiler, like to integrate with those types of things? Like is that something that will just be like handled eventually, or is that something that we'll always kind of have to, like, does it put TypeScript in like a secondary position if you're using TypeScript to compile your JSX? Is that a weird question? Did I fully misunderstand it? TSX.
Yeah, I mean, I think it'll, so right, like today you have TypeScript running, checking your code, right? Usually some folks use TypeScript directly to compile, others will just use TypeScript just for checking and then use Babel for the actual compilation. So that really doesn't change.
Got it.
Yeah. So
okay, cool, perfect.
For example, you'd have the TypeScript running in your IDE, also having our ESLint plugin running in the IDE, and they just work together. Yeah.
Awesome. Thank you.
And I think one of the things that you see with these tools as they evolve is when the more that they mature, the more everything starts to integrate together. Yeah. And so it's going to be kind of just a Babel plugin right now, but it'll the whole ecosystem will start to integrate it into more tools. And it'll be more seamless.
Awesome. Love it. All right, so we're going to move kind of off of compiler as the main topic, and so I can actually like sit on this side of the room for a second. Josh, I want to start with you. So you showed us some really cool stuff in the way that React 19 is introducing some new niceties around HTML, which I'm super excited about as someone who loves HTML. I'm curious, why now? So we've seen, we've had React Helmet kind of doing a similar type of thing since the very beginning of React. And I'm curious, were there APIs that we needed that didn't exist up until this release to be able to do this effectively? And I guess, were there any surprises that you found in bringing that into the framework?
Sure. So yeah, I think that there were some things that are kind of new in React 18 that sort of changed the dynamic. So streaming is one of them. We didn't do streaming before that. And so, I tried to highlight in my 2 talks, why that's challenging, because we have this tension between sending something to the browser as fast as possible, but also knowing the whole state of an application and being able to kind of reorder things and whatnot. So before, you just render the entire thing and you wait until it's finished, and then you're like, oh, these are all the style sheets. I can just send those first or whatever. So that's new. But I think that the other thing that's kind of important to convey is that, and I hope this came through in the talks, we don't just solve preloading or solve style sheets or solve metadata. They all interplay with each other, and so shipping just one of these things isn't good enough, I guess. We could have done the work over time, and maybe we would have kept it behind a flag, and it's on the experimental release or whatever. But when we ship it, we want it to be useful kind of broadly. And we don't just look at each of these in isolation, they're kind of coordinated. Suspense is another kind of component of this where the whole style sheet solution wouldn't even work if we didn't have suspense. So we only have had suspense, at least the real suspense, since React 18 as well. And I know that 2.5 years is a long time for a release. It's not like we ship majors super quickly, but one major after, we started utilizing these features in some of the the new HTML coordination stuff. So it's partly just the philosophy of shipping something coherent that's really well integrated, and part of it's that we live in a different environment now. We have this new capability, and it introduces potentially a new challenge, and we want to kind of help smooth that over and provide the best of both worlds. Oh, and I guess for surprising things that I learned, I guess I knew CSS was hard, but I really know that it's hard now. Way more than maybe I thought I wanted to before I started doing this work. And I'm not even talking about making things look pretty. I'm not good at that. I just mean kind of coordinating it within a browser environment. So TIL.
Yeah, I like that. It went from head knowledge that CSS is hard to heart knowledge. Yeah. I feel that. And then, so maybe a little inside baseball question. I know that React prefers F-word code words for projects. And so I'm curious, did this HTML effort have a F-word code word?
We like F-words. Okay. They're not 4-letter words. Sure. So, I'm sure that some of you have heard of terms like fiber. In fact, it was actually in a few talks here. But yeah, when we work on stuff before it's public, we want to be able to refer to it by some name, and so there's a long tradition of naming these things after the words that start with the letter F. And so, of course, this project also had an F-word project name. I actually kind of Easter egged it in my talk. I'm not sure. I think somebody laughed, so I think one person got it. But this project was called Float, and the metaphor is things float to the head.
I love it. Let's applaud for that. That's good. That's a good one. I like it. Yes, we're forgetting about some of those F words today, actually. All right, so that's cool. Andrew, I'd like to talk with you next. So React has introduced a number of newer APIs. And so we've seen a handful of new APIs today around actions and use optimistic, and we've seen some form APIs kind of cropping in. And some of those are targeted at UI developers. Some of them are targeted at framework authors. And now I think we even have some that are like targeted by like compilers or like machines or whatnot. I'm curious, regarding the use optimistic and the form hooks, do you feel like those are things that developers should latch onto and use directly? Or if you have a framework that already provides optimizations or APIs for those things, should you use those at the framework level?
Yeah, it's a really good question. It's always a different, we'll have a different philosophy based on what the capability is that we're trying to add. So, and it's sort of a spectrum. So on the one side, I think a good example is use effect, right? Yeah. I think everyone nowadays kind of gets it when we say, ideally use effect would mostly be used by libraries, and you would pull it in very sparingly into your app code, not because it's impossible to use, but sometimes it feels like it. And so that's an example of something where it's more on the side of, okay, this is designed to be a low-level hook. But then there's other things that are not that, like suspense. I would argue suspense is something you usually wouldn't put inside your libraries. That very much is something that the application author and even the designer would want to be able to coordinate at the top level. So but even that's a little complicated because suspense is the thing that enables streaming. So streaming is kind of a low-level thing in terms of implementation. So I don't think there's a clean answer, but I also think that the lines are going to blur a lot, especially now with the compiler. Yeah. Like as you say, there's going to be new capabilities that we add to React that developers never directly interact with themselves at all or write code for at all. It just kind of magically happens from the compiler. And we already have versions of this with frameworks like Next and Remix where they add optimizations using React features like the ones Josh showed, the preload stuff. If you're a Next user, you're probably never going to write preload at the top of you're not going to use that inline script thing or inline CSS thing. It's just going to happen automatically for you with Next. So that's a similar thing to the compiler where those things could be used perhaps manually, but they're really designed to be used with the framework or with the library in mind. So to address use optimistic specifically, I think that's another one that sort of bridges the gap or bridges both ends of the spectrum, because we certainly designed it where we want it to address like the kind of basic entry-level cases, even slightly more sophisticated ones, like in Sam's talk where he was showing the optimistic shopping cart example. But there's a lot that goes into making actions and that pattern good. In the same way that there's a lot that goes into making a router good. Mm-hmm. And you can maybe spin some stuff up yourself, or you could like write your own data library in an afternoon yourself. But is it gonna do cache invalidation right? Is it gonna integrate with your routers correctly? Is it going to account for, all of these cases that someone who, the folks who build React Query, for example, have been spending years thinking about that stuff, and same with Next and Remix and Redwood. So really, I think the best practice is still, even though you're using hooks like use optimistic, use action state, or actions in general, the idea is still that you're going to use those in combination with a sophisticated framework that has particular opinions. And there's not one way to do routing. There's not one way to do cache invalidation. Like, Next and Remix and Redwood are going to have different approaches to that. But the idea with actions is by providing the basic pattern and the core primitives in React that can really only be implemented at that level, we're at least giving people the architecture, the framework, and using that in a slightly different way than we usually use those words, for how you should be thinking about how to structure your applications.
Yeah, I love that. So very much still on the train of React recommends a framework and probably prefer the framework tools, and then at some point the framework might adopt the
Yeah, am I allowed to say that without getting in trouble now?
I said it.
Yes.
Awesome.
I think one important point on the framework point, because it comes up a lot, is for almost every app, you're either using a framework or building a framework. And building a framework is really hard. I was watching Josh's talk today, and I've been following this work. I still don't understand it. It just takes so much effort and so much like wiring and consideration. Like if you're installing an app with React, first thing you're going to do is you're going to need routing, right? And you're going to need data fetching, right? You're going to need to integrate all of these things that you're going to need to build an actual app. You end up building your own framework. And for a while there, we were publishing Create React App as a framework, but it just doesn't evolve with all of the new features that we're providing. And so the recommendation is use a framework or take it upon yourself to build a framework. And that's really a hard route and hard to get right, so rely on the experts. I think if you were to talk to framework authors at Next and at Remix and at Redwood and at Expo, they will tell you how much work goes into it. And how difficult it is. And one other point about the frameworks is that the frameworks that we recommend, I think all do a good job at letting you pick and choose certain features, right? So one of the memes that was out there when we made this recommendation is like, oh, React's telling us that we have to use a server now. It's not true. You could build spas with all of the frameworks that we recommend, right? So you can continue using your client-side app in any of those frameworks. One of the advantages of using one of those frameworks is that if you do want to start using server rendering in a particular new route or a high priority route, you can opt in on those particular routes and then gradually migrate your app to different patterns. And you get to pick and choose what you do. And if you want to build that picking and choosing yourself, that's an additional layer of complexity in building your own framework that you just don't want to have to deal with. And so I think it's great that there's so many options and so many frameworks out there where you can not have to build it yourself.
Yeah, I agree. And it's so cool to see so many of them at this conference show their plans for RSCs and kind of reintegrating into what you've been talking about for years in React development. Super cool. All right, we're getting low on time, so I want to continue forward. Now, there's no way that we got out of this without talking about signals. So we're going to talk about it now.
Sorry.
So React is really interesting because we've actually seen a lot of kind of casualties in the language, like from React, like object observe and like web components to some extent kind of lost a lot of momentum once React proved out this declarative UI authoring model. Now, conversely, signals have been gaining a lot of momentum. And so I think every non-React framework right now has some implementation of signals. I'm curious, like, will we see a React signal API, or is that kind of orthogonal to the way React works? This is for anyone who dares to pick it up.
I think Joe should go first.
Joe?
Why me? Yeah, where to begin? So let's start with the easy part of the question. So obviously, if signals were to become part of the spec, React supports JavaScript, so we would support signals. The most obvious thing would be the new use API lets you unwrap a promise, or it allows you to access context. It would be totally reasonable to have use accept a signal, right? And as that signal publishes new values, then your component would update. Like that, obviously, if that becomes part of the spec, we'll support it. Whether we will see React actually adopting signals, different story. This is why they gave me the mic. So signals is really, show of hands, who's kind of familiar with the idea of signals? I'm just kind of curious. Okay, cool. So for those who are not, just very briefly, so you have some idea of what we're talking about. So signals are an idea that goes back about 30, 40 years back to the early days of functional reactive programming research. The basic idea is that you have, you kind of build up a computation graph. You have these nodes that connect together, and at the kind of input to the graph, you have your sort of state, things like state. And then you have derived computations, and then at the end, sort of on the outside of this, you then have places where you're using these values in your UI. So you kind of have this computation graph. If you're struggling to picture this, think back to in the keynote where we kind of showed the computation graph of what React compiler is doing, where we have things like songs flowing into filtered songs flowing into the UI. So that kind of a computation graph. And the idea with the signals-based framework is that you write code to manually construct this graph, and then the framework kind of manages updating it for you. So you're actually like, you're basically metaprogramming, where you're writing a program that produces a computation graph, which will then execute. So this means that things like if statements, early return, in particular like a conditional early return, doesn't quite work the way you expect, because now your return statement is running at the wrong point in the program. You're early returning in the meta program, not the real program. And if that sounds complicated, it's because it is complicated. We think that is a lot easier as developers to write first order programs where you just write your UI, right? You just write a function that describes the state of your UI. And then from that, we can extract out that computation graph and use that to optimize your application. So signals, if we were to explore them, it would be an implementation detail. We're not even sure that that's actually the most optimal implementation detail. Really, so it's great that other frameworks are exploring it. Genuinely mean that. Like, it's really great that there's so much exploration of different approaches in the ecosystem. But we don't think it's really the right fit for React as a programming model. We don't think it's like a great fit for the implementation. And in particular, just that ability to write code that describes the current state of the UI and think in that way is just so simple. And I think that's what's made React so approachable to so many developers. And the key thing is, as we showed in the compiler section, we just can take that information and optimize it under the hood. So hopefully that answers the question.
Can I add one more thing to this? I'll be brief because we got to make sure we talk to Dan a little bit too.
Yeah. I got a good one for Dan.
Okay. One reason I've seen people excited about signals, aside from just like the performance implications, is a lot of the other frameworks seem to be interested in this idea that if we can all agree on signals as the way our frameworks work, then there'd be better interop or something. We heard similar things from like the web components crowd for a while. And there are obviously selfish reasons why we're not as interested in that, because we're already doing pretty well for ourselves. But the less cynical answer is,
I thought you were worried about getting in trouble up here.
I had a drink earlier. But the less snarky answer is, React really does work differently than these other frameworks do, in a way that sometimes I feel like people don't appreciate. The concurrent stuff that we built, I know we went a little overboard hyping that stuff for so many years, but it's pretty cool. The optimistic feature, the use optimistic stuff that Sam was showing off, I think you'd have trouble implementing that in Signals, to be honest. That's the type of feature that once you play with it, I think you're going to realize, like, oh, this concurrent stuff, they weren't just speaking out of their ass. Like, there's something to this idea. And the compiler is built in such a way that makes the React model still work while also getting some of the same benefits as Signals, even though it isn't implemented in the exact same way. So we feel pretty confident in our strategy. Maybe we'll be eating crow in a few years when everyone else is off in Signals land and we're stuck with our stuff. But I think we're going to continue to rethink the best practices, and we're feeling pretty good about it.
Love that. All right, Dan. Great, nice. You didn't even get in trouble. You got applause for that one. That's amazing. All right, so Dan, this is a little bit more of a community-oriented question, and I feel like you're like the person best suited to answer this. But watching your talk, I felt like I understood for the first time kind of like how we got to RSCs. Right? There's been so much conversation about it, and it's been really hard to track, but like watching your talk, I was like, oh, like I see the logic behind it now. And I know that comes from a lot of hard work and open discussion and like open communication where you're not entirely sure how you're communicating this thing yet. And you do a masterful job of having that conversation openly and repeatedly, like over and over and over again, having that conversation. Now, I know that sometimes there's a tendency to, like, it's almost become a meme at this point, to be like, oh, the React docs are Dan Abramow's timeline. And I know that that's not really fair to you because you're exploring these things and whatnot. This is a very long question, by the way, but I think it embodies a lot of us. You know, because you're exploring, you're trying to figure out how to talk about these things so that all of us can have a better onboarding experience. And React is this really interesting, like Seth said it before, like it's a really cool R&D project that gets tested at the scale of Meta, but a lot of these ideas are new and innovative. I'm curious, how would you like to see the community respond as we go into some of these new programming models? How can we best support the messaging of curiosity and learning in the open, being correctable, like as things get fleshed out in real time? Like, what are your thoughts around that? How can we better support curiosity and learning in public?
Ooh. I don't know.
That's all.
I think like one thing I've seen, and I've kind of gotten more like cynical over the years about this. I think like my cynical take is that I think for a lot of people, you know, just like the abstraction level at which they got proficient just becomes kind of like a part of their identity, and then when there's like a new layer on top, you know, I mean, a lot of new layers on top don't work out, right? So like a lot of people are just, oh, this is a fad, but some are actually good, and I think in a lot of cases what happens is just people kind of close themselves off to a bunch of stuff, and I think like with both like with hooks, I think with hooks it was a bit easier. Like I think with hooks there was a lot of controversy, and you know some people still hate them, but it's mostly settled. Whereas like with some like server components, I think it is very much controversial still. It's starting to settle a little bit, but you kind of have to like spend some time with it. And there's also like differences between, you know, you try like a framework that's like not fully baked yet, but that's like a different from like the concept doesn't make sense. So I think like people have this like all this like different like experiences trying stuff, and what I'm saying is like I think I've gotten more jaded about like there is a lot of people you really can't convince about anything new, and that's fine. Like some of them will come around eventually, and like some will go to like greener pastures and like find something that they like more, and maybe someday they'll come back. But I've most consistently been kind of inspired by just like new people, like, you know, popping into the ecosystem. And like with, you know, like with hooks, like I remember like Nat Allison, she was like, I think like she like tried to rewrite her, like one of her projects with hooks, like literally like on the day of the announcement, I think, like here at ReactConf, like the last time I was here, yeah. Like in this venue. And that was just like exciting to watch. And I think like with server components, it's also been the case that there were like maybe like 3 or 4 people on Twitter who were like not negative about it. And like that was really like, you know, that was actually like 2 of them are like in the front row here. And like the thing is like, it seems to be the case that like often this is like, some of these newer things, they land better with people who are just haven't been like exposed to a bunch of stuff before, and they're kind of like new to the industry, or maybe like have been here for a couple of years, but actually like their thinking is pretty clear, and they also don't have all this like baggage of opinions that, you know, like they're like they feel kind of they have like the need to defend, or they don't have this you know, like things like their livelihood doesn't depend on a particular technology winning and stuff like this. So I think like I'm just always inspired by the new generation, and I mean that just sounds like I'm old, but I just feel like whoever
the youth,
the youth, yeah, like it's just like if you aren't getting it, like go talk to the kids. That's not quite what I mean, but there's always, you know, and like people learn, like people who grew up with like this stuff, like they're gonna have like different opinions than like people who grew up with like stuff from years ago.
Yeah.
So you just find new people. Like it's fine. Somebody will like it maybe if it's good. Otherwise, yeah, that's kind of your problem.
Just find new people. Just find new people. I love it.
And Michael, if I can add on to that, because I think you asked a really important question: is how can the community help us? And I think, like, one thing you have to like keep in mind is that, and I think somebody said it earlier, is that React is a research project, right? And so when we also are building in public, right? And so we try to be very transparent and share what we're working on. One, because, mostly because it's going to be in GitHub anyway. You're going to have questions about it. But we try to be very open and build in public. And so when we do that, we start sharing our ideas. But because it's research, we don't really know the answers yet. Yeah. We're still discovering them and iterating and trying to innovate. And so I think the way that people can help is by really, when you're seeing what we're doing and what we're working on and what we're sharing, disambiguating like the state of what things are in, because I think there is this like cycle that gets created between like, you know, screenshotting pull requests and saying this new thing is coming in React, you got to learn it right now, and that creates a bunch of pressure for people to like start learning those things. But if it's very early on in the stage of that new feature, it's going to change a lot over the time. And as it's going through those different iterations, if you're trying to keep up with it, it's going to just be very confusing to try to keep up. And I love that there are so many great like educators in the community that are helping to teach people about what's coming in React. And I think the way that they can help is just helping to reinforce messages like this is experimental, this is still in research, and setting the expectation for what the state of these new features are whenever they share them.
Love that, thank you. So we're a little bit over time already, but I hope that you'll entertain me for one more question, and we'll try to do maybe like a speed round. You could like one word it or like, you know, one sentence it. And this is more like an existential question. We're gonna have you on stage without, you know, thinking about death and life and all that stuff. For one question, this one's for me. We've seen an explosion of AI, right? And so we've seen it writing components for us, right? Using some of these really cool, like amazing libraries like Radix. And now we have a compiler, so like robots know how to make that automatically generated code automatically efficient. And I'm curious, like, what does that leave us with? Does that, as like UI developers, does that push us more into the application stack? And I guess if you had one skill that you would recommend to everyone here as UI developers that they should, you know, sharpen up or let go or gain, what would it be? So that we can continue to come to this conference for the next 5 years, the next 10 years. What would that skill be?
Oh, I think my answer is like really kind of maybe pessimistic in the sense that like, yeah, let's just automate the whole thing. Like, and unfortunately, I don't know what to do. Like, I don't know how to do anything else. So.
I like it. I like it. Find new friends. Automate your work.
Yeah, I mean, I think we should optimize everything, add PGO to our compiler, take advantage of AI, but I think as ultimately we're building for humans, right? And so I think that as developers in React, we need to keep, our superpower is being able to empathize with the human that's using this and building a delightful experience.
Love that.
Yeah, my answer is going to be very similar. Is you know, our goal has always been with React that we want you to be able to kind of push the code to the side and not, as much as possible, you want to be directly authoring the user experience. That's what you want it to feel like. You just drop a component in that describes the UI and then it happens. And really the ultimate version of that is just telling ChatGPT, build me an app. So like in spirit, it fits a lot. But the other thing is, I think what the best React APIs have, I always feel like in this research project that we keep referring to, one of the things that feels like we're discovering is UX principles. So like suspense is an example of that. That really felt like a discovery when we landed on the design for suspense. And if you can detach yourself from the idea that you're a coder first and rediscover maybe your love for just really amazing UX and polish and how to build the most like kick-ass, like awesome apps that just feel really great when you open them up. And that, I mean, maybe that'll get replaced too, but I think that is the thing that in this AI-dominated world, we humans can contribute, perhaps.
Love that. Yeah, I'm not so certain about exactly what the future of programming in an AI world will feel like, but I've always been jealous of people who can like write C++, and I know there's still people out there who like write web apps in C++, and that seems like a crazy thing to do for me because I just wouldn't know how to approach that. But for the person who acquired that skill, that's a tool for them, and they love it. And while maybe people start moving up the abstraction stack and start using AI to produce applications, like 99% of what gets built is products or experiences. Like you build stuff because it's valuable. You don't build stuff because it's JavaScript. So, there will be people who work in lower level languages forever, basically. At least that's my opinion. But it's okay if the sort of the shape of like what it means to build something changes and the tools you use change. And it's also okay if you use React in 20 years because you like it, even though that's like the C++ web app of today right now.
Love it.
Yeah.
I think to your question about like what we should do to prepare, I think definitely learn how to grow vegetables. Farming is probably gonna be very useful when the AI take over. But more seriously, I think like you said what can we as UI developers do to prepare, and it got me thinking a lot about like yes, we are UI developers, but ultimately we are problem solvers, and AI is but yet another tool at our disposal to help us, build great experiences for people. So like whether you write your code in JavaScript or English, if you tell an AI to build it, like there's still that element of, you as an individual helping to problem solve. And I can't imagine AI doing that anytime soon, although I'm honestly not an AI expert. So maybe it is possible. But I do think that that's like a really important skill that we all bring. And so, yeah. But if not, farming, we need food.
Okay, I'm gonna actually, we're way over time. I'm getting some, hovering in the back. So I'm gonna have to cut you off. But find them, find out what their secrets are to surviving the next 10 years in this AI apocalypse. Hey, I hope that you will stand with me and just thank all of these incredible members of our community for the hard work that they've done. This has been an incredible day. Yeah. Awesome. Thank you so much. Thank you so much. We're going to bring Ashley back out.
All right, before you guys turn around, I do want to give one quick call out. We found a small bag. If anyone lost their bag with the little pouchy thingy, in the back corner, yes, in the back corner, it'll be available. You'll be able to claim it there. All right, awesome. As y'all are heading out, it's time to party. There's going to be food, drinks, patio, so follow the flow. We made it to the end of the session. Thanks again for paying attention, participating, and sharing the vibes. I'll see y'all in the crowd. And tomorrow.